good morning yesterday. I said we're Balenyo, but I said no, that's not how you pronounce it. It's very soft. You have to be we're Balenyo, can't be we're Balenyo. So I'll give it. I'll practice. At least I've got 2 or 3 days that I must continue to practice. So, but welcome. Thank you very much for joining us on the second day. I think I'm quite happy with the attendance. When you look in other conferences after what IFATSEA did last night, people don't pitch up on the second day. But I think now the attendance here it's quite impressive. Without further ado, I think we'll kickstart with the first panel discussion for today, which is the predictive maintenance. Maybe let me try and explain it in layman's terms. Those that have done strategy or attended management courses, they will tell you about the Johari window. When you look at the 4 quadrants, there is a quadrant that speaks about the blind spot. Those things that you don't know, that you also don't know, that you don't know. So predictive maintenance, it will help you with that. That if you don't do something about this thing, this is what will happen, because you don't know, but it will preempt you as to essentially this is something needs to be done before it's too late. So to avoid being reactive and be proactive, it's intended to do that. And with the increasing complexity of the CNS and ATM system, I think Richard yesterday eloquently put it. So ensuring that there's a high availability and reliability of our system is critical to ensure the safe and the efficient air traffic operations. So traditionally, the maintenance has always been reactive. We've got scheduled preventative maintenance. Somebody was talking about filling the check sheet or the forms yesterday. But any unexpected failure and unnecessary interventions, because what typically happens, you will go today to do your preventive maintenance check sheet, everything is done. Following day, you walk into office, you get told that your radar has failed. You're like, but I was there yesterday, everything was working fine. So what happened? So this panel will explore how predictive maintenance powered by data analytics systems monitoring, your machine learning is being applied in this environment, the CNS ATM systems, so that we can anticipate these faults and improve our decision making and reduce the downtime. Because we'll know that we spoke about the SLAs, the service level agreements that we'll have with the suppliers. So the downtime is quite critical. The sooner you restore the systems, the better, and the efficiency of the performance of your system. So this discussion will be spearheaded by none other than Madam Fortunate Tumuhaise, who is the Senior Technical Officer in Research and Development within UCAA, and she is a member in good standing of IFATSEA. I was tempted to read her profile, but it's quite long. It will take me a day to complete it, but she has done exceptionally well in this area. So she will spearhead that. She will be joined by a panel that she will introduce herself. Ladies and gentlemen, Madam Fortunate, thank you very much.
Thank you very much, Engineer Sam. Good morning. Welcome back from the action-packed day yesterday, and welcome back from the cocktail as well. Special thanks to IFATSEA for that icebreaker. I think it was really necessary. And today we are back to business. Before we start, with your permission, I request that we start with a word of prayer to bless the day. I invite my sister Ida. Since yesterday it was with the Christians, today let the Muslims bless the day for us. Just 1 minute. It's okay from where you are if you want.
Bismillahirrahmanirrahim. Dear God, we thank you for having brought us yet another day when you can humble and dedicate ourselves to the services of you, Almighty. We thank you for the gift of life and health. We thank you for the journey mercies of all the delegates who traveled to this place and for the good time that they've had since they've arrived in Uganda. We ask for your blessing and grace as we deliberate on the different ways of taking the ATSEPs forward in this conference. In the name of God, most merciful, most beneficial, amen.
Amen. Thank you very much, Ida, for that. So today we are starting the day with predictive maintenance in CNS ATM systems, and we have a panel of very brilliant engineers among us that are going to take us through this discussion. My job here is simply to guide the discussion. We have about an hour to do that. I'll start with Engineer Selzing Miri. He is a seasoned professional in the aviation industry with over 30 years of experience, currently holding the position of President at the National Association of Air Traffic Engineers and serving as General Manager at the Nigerian Airspace Management Agency. Engineer Miri has demonstrated exceptional expertise in the installation, maintenance, and flight calibration of navigation aids nationwide. His extensive track record includes successful overseeing numerous installations and maintenance projects for nav aids, showcasing his proficiency and dedication to advancing the aviation sector in Nigeria. Ladies and gentlemen, please welcome Engineer Selzing Miri to join our panel. Thank you very much. Also, we have Engineer Robert Jere Omusonga. He's a distinguished professional with a strong background in both engineering and aviation. He holds a Master of Science in Industrial Engineering Systems and Management and an HND in Telecom Engineering with ongoing PhD studies in Applied Electromagnetics. He has served as an avionics instructor at the East African School of Aviation at Qatar Aeronautical College. Please welcome Engineer Omusonga. You're welcome, Engineer Omusonga. Also, we have Engineer Peter George Kimario from Air Navigation. He's an air navigation engineer with Tanzania Civil Aviation Authority. He has been an air navigation engineer since May 2021 with over 7 years of cumulative experience in electronics and telecom engineering. He's registered with the Engineering Registration Board. He has worked at Netis Tanzania Limited as a project supervisor from 2018 to 2021, where he oversaw electrical and telecommunication site projects, as well as maintenance activities. And currently, he's working with Kilimanjaro International Airport as air navigation engineer. Please welcome Engineer Peter George Kimario as our third panelist. Thank you very much. And then our own engineer, Richard Kato Sembatia. He's a practicing engineer, registered with the Engineers Registration Board of Uganda. He holds a master's degree in power systems engineering and a Bachelor of Telecom Engineering, both from Makerere University. He has served in the Directorate of Air Navigation Services for over 13 years. He's passionate about the leveraging of open source technology through in-house R&D initiatives for improved efficiency and productivity. Please welcome Engineer Kato Sembatia. Yes. So welcome to this panel discussion. There's a lot of knowledge. I don't know if you can feel the knowledge full in this house. Yes. So I would like to start with an introductory question, given that we may not have quite an elaborate presentation, but we are going to share first an introduction to this topic. Engineer Kato, what do you understand as predictive maintenance, and can you help us understand, as we are today, what is predictive maintenance? Are we in any way moving towards it? What is our current model of maintenance that we are doing generally in Africa? And how can we move towards predictive maintenance?
So, thank you, Fortu, and greetings everyone. I think the best way to start is maybe I'll assume that we can define predictive maintenance, or maintenance for that matter. In layman's term or language, maintenance is a set of interventions that you perform as an ATSEP to either correct a malfunctioning system or to make sure it never fails. So it's a set of activities or interventions that you perform to either ensure that a certain piece of equipment never fails, or if indeed it's unserviceable, you're trying to restore a service. So if we put that on the side, there are three ways of achieving this, okay? The first way is you have what we can call corrective maintenance. You are at a given station X, and for some reason a given system fails. And then typically your supervisor constitutes a team and you attempt to restore service. That's corrective maintenance. Okay, so we classify it as reactive. In other words, you're reacting to a situation, okay? And then we take it a notch higher. You can have what we call scheduled maintenance. In other words, you have a schedule or a roster with predefined times at which you perform this maintenance. It could be quarterly, it could be biannually or annually.
Recording in progress.
Based on the recommendations of the manufacturer of a given system. And then if you take it a notch higher, there's what we call reactive, or proactive rather, where you don't wait for the fault to happen, but by studying the behavior of certain key parameters of a given system, you're able to predict that a given failure will happen at a time T if no intervention is done. So in a nutshell, that is a predictive maintenance. In other words, you study the trend based on the data, the parameters, and you can approximate, okay, that if no intervention is done on the system and things remain as they are, the system will fail. So in other words, you have a chance to intervene way before a fault happens. Yes, thank you.
Thank you very much, Engineer Kato, for that. Indeed, we are trying to change our mindset from reacting to what has already happened to predicting to what is going to happen. Engineer Omsonga, what types of predictive maintenance technologies are currently most feasible for us to implement in Africa today, given our environment and how we are still trying to adopt and catch up with the technology that is out there? Because of our aviation regulations, you find in our environment the safety and all that we will find ourselves struggling to catch up with the technology. So in Africa, what types of predictive maintenance technologies are most feasible for us to implement?
Thank you. I think before I answer the question, just want to add something on predictive maintenance. I think the other types Richard has said are very common. That is corrective and preventive. Now, Predictive maintenance has been there, even without AI. I'm avoiding to use the word AI because predictive maintenance has been there before, especially critical systems. And in CNS, it has been there to some extent, but not much. For example, if I go back home on CNS, how do we monitor our systems? We only monitor the status. Many times, maybe the others doing other things. Take, for example, navigation systems, which are scattered all over. Sometimes we wire remote control units to be able to see the status at our control positions. Now, the status we see are they're just indication to show the status of the equipment. But they don't give us the trends, what Richard has said. They don't give us the patterns, the trends, or the behavior that can tell us when the equipment fail. Or it does not collect data to tell us the equipment can fail at the time T. Yeah? So what has been happening before even AI is that predictive maintenance has been there, but at our level. AI is only coming to enhance. Now, if I just talk about predictive without talking about AI, I would say that in the scenario I've given, I require something like not just something to give status of the equipment. Status, I mean something to tell me equipment is on or off, is serviceable, unserviceable, or it is downgraded, or it's indicating some other parameters, but static in a manner. Yeah?
Yes.
Now, I may require something that gives me a continuous monitoring, which gives me the performance trend and the behavior of the system. Yeah, that means then I require something that can collect data.
Yes.
Yeah. So previously we have had some systems, CNS we have not had, but some systems will have people using master sensors. Yeah, to do and collect the data, so that this data can form a pattern. Yeah. Some have used now with the advent of AI. Some are using what we call machine learning models to try and look at the patterns and then model them to be able to predict when the failure will occur. Yeah. Some are using, and then all this must happen in real time. Real time then means that we must use something that can give us information at our fingertips. Yeah. And the latest technology they're using is like IoT, Internet of Things, so that even when I'm seated here, I can know somewhere in a remote area, this is the behavior of my system, and then I can know how to arrange the situation. Yeah. And apart from that, we have many other technologies, as we said yesterday. When you are learning one technology today, tomorrow it becomes obsolete, another one comes. Yeah. So basically, those are the few technologies I think can be available in Africa as we speak.
Yes.
Because that's what the market can provide for now. Yeah.
Thank you so much for that. Indeed, you have also explained to us the data sources that we can get this information from, because for you to be able to predict how the system is going to behave, you need to know how it has been behaving over that time. Thank you so much for that preemptive answer. So, as we are trying to get into that kind of predictive maintenance, Engineer Peter, what do you think are the major barriers to, sorry about that, what do you think are the major barriers to us adopting this predictive maintenance in the African CNS ATM context, and how can they be overcome?
Okay.
Sorry?
Okay. Thank you, Madam. Good morning, everyone. I'll just mention some of the few challenges or the barriers for implementing this predictive maintenance. The first one, I think, is the regulatory requirement. As we know, we as air navigation service providers, everything we are doing has to be regulated by our CAS. So normally I'll take example of my country, we are not doing the predictive maintenance, it's the scheduled preventive maintenance. So normally after we have commissioned a certain equipment, maybe communication, navigation or surveillance facilities, we are developing the procedures manuals that we are deriving them from the system equipment manual on how we are going to maintain our our facilities. So from the procedure manuals, they should be approved by our CAA, and if from the procedure manuals we are identifying what we'll be doing daily, including daily checks, weekly checks, quarter checks, even annual checks. So everything is analyzed there, and as we submit those documents to our regulator, they approve them, and when they come to do an oversight, they are assessing how we are doing our daily works by looking how do we comply with those predefined documents that we are using. So the first challenge will be, will the regulator approve these tools that will be used for predictive maintenance? Because involving this machine language and the other tools that will be used need a regulatory approval. We need to assess their reliability, their accuracy, and when anything goes wrong, as Mr. Richard explained yesterday, who do we sue? Who do we take accountable when the tool that have been used to predict a failure fails me? Who will be taken responsible? Is it the CAA who approve? Is it the manufacturer? Or is it the ATSEP who follow the schedule for all the analysis basing on that tool? The second challenge is the adoption for us as ATSEP. You know, I have 3 years experience in aviation. What I'm doing is actually the replica of how I found the system, how I found the ones who I met in the system were doing. We normally used to do this preventive maintenance whereby there's a schedule. I'm going to do a maintenance according to the schedule that has been arranged. So moving from traditional ways into a new way, adoption, the just culture of just doing the maintenance, waiting for maybe an equipment that has been failed, I go and restore the facility. So we as ATSEP, we are the main barriers. Adoption, accepting that the technology is changing fast and we have to move to adopt it with the new technology. Another challenge is the resources. I mean the allocation of funds. Implementing predictive maintenance requiring an investment. We as air navigation service providers, as yesterday we have been indicating that training is, we lack funds on training. Right now, investing in this predictive maintenance require funds first to purchase the system, to integrate them, and even to train people to understand how this system will work. So right now we are facing the challenge of funds for equipment training and other mandatory training that we as ATSEP required, and now want to move to predictive maintenance. So everything's need money, need funding, and we don't have this fund. Another thing that this predictive maintenance require a lot of data gathering. We need to know how will we maintain the integrity, the quality, and the availability of this data. How do we preserve them? How do we store them? How do we ensure the continuity of this system? So, and as we know, cybersecurity is one of the important issues. Collecting this data from the system require some sort of permission from the original equipment manufacturers. They has to unlock the system for us to enable to gather a lot of data, so that those data we can use them to predict on how the trend of the equipment. So allowing the system, expose the system to internet is threat to cyber. Somebody can just interfere with the system. Somebody can just analyzing the system logs, know the loopholes, and it will be a threat to CNSA team. Thank you.
Thank you very much, Engineer Peter, for that. Actually, you have touched on a number of issues. You've talked about the cybersecurity threat, on having to use some of this new technology, especially AI. You might trust that this AI is doing a lot of work for you, but how do you know that the brain behind this AI that you're using is actually there only to help you do what your work? How sure are you it is not collecting data that is going to be used against you? I would like to ask Engineer Miri, in the same light of cybersecurity, how do these how do predictive maintenance systems increase cybersecurity vulnerabilities, and what mitigation strategies should be considered?
Thank you. Going by all that we have mentioned, you will agree with me that predictive maintenance is going to depend or rely on data, and from all that we've been trying to put across, you are going to rely on so much data to carry out predictive maintenance. You are going to be using a lot of emerging technologies like the Internet of Things, machine learning that my colleagues here have mentioned, and all this rely on data. So you see the vulnerability there in the sense that you have a larger platform for cybersecurity to trend, because by the time you are dealing with a large volume of data from different platforms, you're already vulnerable. So this is going to expose the whole process to a lot of cyber threat because of the processes that are involved, except deliberate and intentional mitigation processes are put in space, or otherwise you will run into crisis of having different channels by which you could be attacked. And if we are to talk about the mitigating channels, you discover that you have to be very intentional about this. You have to be very intentional about this, knowing that this is a reality that we have to live with. We have to plan toward it, so we have to be deliberate in putting structures in place that will dictate and alert when there are seemingly form of threat coming into this data. But one assurance I want to give us is that the whole process of this data gathering through these processes that we have mentioned, some of them have integrity in themselves to really protect it from cyber security. So the fear of vulnerability should not discourage us embracing the predictive maintenance, because most of the process have integrity in them. When you talk about like blockchain, somebody mentioned it yesterday, I think it was Richard. Yeah, and you discover that it has integrity in itself to try to protect that system from being tampered with. And so when you are using some of these tools of predictive maintenance, you should be able to analyze which is best for you to adopt, and then you adopt it with the consideration that this is your peculiar situation and this is how you want to protect yourself from it. And then let me quickly add that you can also segment your processes, so that if you have to deal with data in this form, you should have some kind of backup in several other ways, so that if there is a failure, you don't have a total failure. You should always have something to rely upon. So we have several ways of storage. Either you use the cloud or you use whichever ways of storage, but we must make sure that we have reliable redundancies for all the processes or instrument of predictive maintenance that we are going to be adopting, so that we can conveniently protect ourselves from cybersecurity and threat, which is also a reality. Thank you.
Thank you very much, Engineer Mary, for that. Maybe just to poke your mind further, for me, when it comes to cyber security and risk management, we have these quality management standards. For example, there is one that is for information management and security that is already in place. has that been adapted for this current trend of AI and how we are trying to use it for predictive maintenance? If I may bring it down to our how we are trying to do cybersecurity, I know if I'm laying up a network in my maybe data center, I should have a firewall to make sure I don't have such attacks coming to my systems. What is the equivalent of that if I am using an AI tool that I have, for example, downloaded off the internet? Is there anything that is in place yet?
Yes, just like my colleague here says, most of these things are in place, but is the acceptance to use these processes. You know, like the whole discussion on cybersecurity, there was a lot of argument. I remember precisely in Argentina during the General Assembly, the person that came to do a presentation on cybersecurity was a controller, and he was trying to convince us that it is the responsibility of controllers to handle the issue of cybersecurity. Sam, you can remember? Yeah, and we're like, oh, this is strange to us because we thought this is our responsibility as engineers or AFATSEA. And somebody is now telling us that, so there are a lot of processes that we can actually, adopt. But until we accept and agree to use those processes, they will remain a mirage. And I want to challenge us as AFATSEA, to own it up and then take responsibility that this is our work and that we can do it. And we discover that by the time you accept this, right at your table, you have a lot of processes you could adopt and then take care of the cybersecurity issues. There's quite a lot. Thank you.
Thank you for that, Engineer Miri. You were, this is still back to you. Okay. You were encouraging us to take up this mantle for cybersecurity, but how sure are we that the AFATSEA are competent enough to take it up, to know what to do when they are trying to implement cybersecurity, trying to implement predictive maintenance? What competencies must the AFATSEA acquire to effectively operate and manage these predictive maintenance systems?
Thank you. I think the first competency I would say AFATSEA require is to wake up. Yes, we have to wake up and accept the reality of the change we find ourselves in. Let me give you a critical example with myself. I'm somebody that's a little static when it comes to change. When this bag that men hang behind, I don't know, this, just like the conference bag you gave us now, we don't used to have it before. When those bags started coming, everybody I see is just hanging this bag.
Yes.
Just hanging this bag. And I told myself, no, I'm not going to be part of it. What is this thing that every man is just hanging back? Just hanging back. Old, young, children, everybody is just hanging back. I told myself, if you give me that back, I'll hold it in my hand. I refuse to accept it for a very long time. Today I'm hanging it. So the earlier we accept this, the better for us. Let's wake up to the reality that we are living in a dynamic system. Things are changing, and we have to accept it. Secondly, AFATSEA has to build capacity. We are talking about some of these emerging technologies that are coming up on almost daily basis. They are actually not new. They have been there, but they have not been explored. And then the reality is coming on us now that we need to explore these areas to better our lives. So AFATSEA have to develop themselves in capacity building. We really need to take it seriously, and this applies to every one of us in any unit. You know, you could say that no, like mostly those who are already a little advanced may find it difficult. I remember in my country when we had these present facilities that we are using, we were transiting from the old navigational aids that were analog, have no computer interconnectivity or nothing. And when we started bringing in the new system, some of the old hands who have been there very good in maintenance refused to accept this. And they say, no, anything, give this younger generation, they are the ones that can handle it. So they refused to build capacity. And eventually with time they were fizzled out. So one of the competencies that IFATSEA need now is to take this very seriously, build capacity. Good enough, we have a lot of information on the internet. The best university you can attend now is the internet. You can read everything on the internet, either young, old, or whatever stage of this profession we are. Let's get used to trying to develop ourselves in these major areas. Learn to know about how does machine learning operates. We're talking about machine learning. Predictive learning, predictive maintenance is going to hang mostly on some of these things. And either you like it or not, whichever field of engineering you are maintaining now, you have to do it. Learn about it. What is machine learning all about? What is Internet of Things all about? We're talking about data analysis. We're talking about blockchain. These are all tools that we are going to be using. So let's start learning about this. Let's start developing ourselves and building capacities in this area, so that by the time the reality is done on us that we need to use this thing, we are well ahead and we could use them with convenience, with a lot of knowledge, and I think that will help us. And part of the competencies we are trying to develop is what we are doing now. You know, conferences like this avail us opportunities to learn, and these are areas where we build also our strength to be able to face up the challenges of our unique profession. So I want to challenge us at IFATSEA that we need to begin now. Now, if you have not tried to give your attention to some of these things that we're talking about, begin now, no matter your age. Even if you are having a year or two, or even maybe some months to leave the system, you may not know where and how you may have to do with some of these things. Maybe you are engaged on consultancy, or you are engaged as to provide some services. You will still have a lot to do with this. So let's begin now by trying to explore all that these tools are able to do, just like we have mentioned. All of them are on the internet. You can go there, explore them, read about them, and then try to see how you can use them. So IFATSEA, let's start now. Now is the time to build our capacity. Thank you.
Thank you very much, Engineer Mary. Now is the time. I'll move on with that mantle. But as we are adapting, us as the IFATSEA, our systems are not exactly adapting at the same pace. We still have the challenge of legacy CNS ATM systems, and we are also still dealing with the challenge of being locked in with a few suppliers on the continent. So, Engineer Omusonga, how do we ensure interoperability between these legacy systems and these predictive maintenance technologies that we are hoping to adopt?
Okay, thank you, Fortune. I think maybe I just go back a bit. Currently, we have CNS systems which are not linked in any way to new technologies which can do predictive maintenance. But then how do we then bring in tools that can enable predictive maintenance? And if we do that, then how do we ensure that when these tools are brought in, they are not tied to a particular system? So that today, if I'm a supplier, I don't have to supply you equipment and then say, these particular tools can only work with my equipment. That way, then I'll be tying you to myself. I think the freedom we want about this AI and predictive maintenance is the freedom to be able to choose what you want and who to do business with. Because we can also fail on that and find that we are tied. When you are tied on somebody or have no new technology, you are going to use whatever he has at the measure which he wants to give you. Yeah. So what we need to look at, let me just look at basically, and I give an example maybe of a simple thing like a power generator. A power generator, many times you can maintain using what we call the condition-based or time-based. Condition-based means you can say, after every 100 hours, I'll do service. That is planned. That after every 100 hours, I do service. That's a condition. Alternatively, I can say, I'll do service after 3 months. Whether it is working or not working, I'll do service. Yeah. Now, for us, with our CNS, which is almost the same, I can say, for me to do ground checks on VR, for example, I'll do when I'm just about to do flight calibration. Irrespective of whether it's failing or not, I'll have no time in between to do that. Yeah, because that's the way I'm wired. But now, with predictive maintenance, which we want to bring in, we want to say that we should have the system itself advise us through the data that you have been collecting on when it's supposed to be done flight checks and confirm if necessary whether it requires calibration or not. Yeah, that way you save a lot, because we shall not require a lot of money to take out inspectors or people to go and check his system from time to time. Now, back to your question, how do we bring this in? To bring this and be dependent, it means that we must start with our solutions here in Africa. Let's do all we can do and try to see how we can adopt our own system, which I know is very, very possible, because we can have models of machine learning, we can have sensors, we can have what we call natural language processors, so that all this data that you are locking down in the maintenance logbooks can be converted into meaningful use through AI algorithms to be able to help us adopt this particular system to this particular tool to this particular system. So that when you are buying a system, for example, a VOR, we don't have to buy once already installed with the tools, because being so, then we shall tie ourselves with that particular supplier. Now, the challenge we have is that we must, from the start, when we are buying systems, we separate the two. Yeah. Then let it come, and then we connect, we link it ourselves, because we are going to link, like, for example, Kenya have about 15 navigation system sites. Yeah. Now, if we say that we have to get a supplier to do all that for us, so sell us what we call a turnkey system, whereby it's already installed AI linked to the system and all the other tools in one package, then we shall be using a company whereby we have flexibility to move from one AI system or tools to another system. We shall not be able to do that. So what I would ask is that let's learn this ourselves here. The tools that we require, which you have mentioned, we require to learn machine learning models. We need to do the natural language processes. We need to learn how to do AI algorithms, so that we can actually have we can have what we call decision support systems. Yeah, and if we do that, then we shall be able to interconnect our current CNS systems with the tools that we have developed. Yeah, thank you very much.
Yes, thank you so much, Engineer Umsonga, for that. As we are getting all these to-do action points, how shall we measure that we have achieved success? How shall we know that we are on the right track? What are those KPIs that we can look forward to as air navigation service providers to evaluate that actually we are moving successfully towards predictive maintenance implementation? Engineer Peter, do you have an idea on that?
Okay, thank you. On the KPIs, after implementing this predictive maintenance, first the KPI should be specific, should be measurable, should be achievable, and it should be available. This all saying that what you can't measure, you can't explain it. So we need to ensure that this KPI that we set to to show that we can safely move from the predictive maintenance we can safely move from the this traditional ways of doing maintenance to predictive maintenance. So we might look into number of factors. I might mention a few. First, we'll see on the equipment reliability. On the equipment reliability, we might look on the factors that are measurable, including the mean time between failure, the mean time to repair, and also the overall equipment efficient equipment availability. So if we are collecting a lot of data on the equipment functionality and equipment behavior, we can easily predict when the failure will happen, what will be the time taken to restore the equipment, and the overall system availability. At our country, we normally every month prepare the serviceability reporting, taking into account the downtime and the uptime. We calculate the percentage and we show the availability or the serviceability of the equipment. So with this predictive maintenance, analyze the system logs, it will be easy to determine these factors. Another KPI we can look is the cost. As we know, every maintenance is associated with the cost. For the planned maintenance, we can easily set into the budget for the section, but for the corrective ones, we cannot predict on how many corrective maintenance we can do. But when corrective maintenance, when the failure happen, you have to do corrective maintenance. And doing corrective maintenance, it involves purchasing of spares, payment of extra duty allowance or an overtime to engineers. It involves fuel, car cost, and a lot of things. So after we implement the predictive maintenance, we have to assess what was the cost before and what is the cost after. The cost for purchasing the spares, for paying the extra duties, the cost for fuel, and the overall running cost of the system. Another place we can see the customer satisfaction. As we know, we as air navigation service provider, we provide service first to pilots, and we provide to airplanes, and we provide service to these users, including air traffic controllers and the aeronautical information officers. These are our customers. So measuring our KPI, we need to see on how much our customer are satisfied. We need to see the things like how many faults are reported, the downtime, the response time. We can just even prepare the questionnaires and submit it to our users, including pilots. How are they satisfied with our system? How many times have maybe a pilot is cleared for an ILS approach and he found that maybe the localizer is not available? Or how many blind spots in communication or navigation have they encountered? We can even talk to our air traffic controllers on the reliability of the services, how comfortable they are with the reliability of our system. And the another area is on the safety and compliance. As we know, we as ANSP, we need to be, we are audited, we are regulated. So during audits, there are incidents that are reported, there are findings that are reported due to the maintenance schedules that we are doing. So after going to the predictive maintenance, we need to assess, after moving, how many incidents you have found. When the regulator comes and inspects us, are the finding decreased or the finding of the equipment malfunction are still there? So all of these factors are measurable, and we need to measure them. We need to set the targets, and the targets need to be set between the ANSP and the regulators, so that we can easily assess them and we can know that if we are achieving or if we are not achieving, and if this model, is it practicable or we are just creating a lot of inconvenience during our maintenance. Thank you.
Yes, maybe I can add a word or two here. So one of the biggest selling points for predictive maintenance is the idea that instead of stocking so many spares,
Yes.
you can do what we call just-in-time stocking. So many of us can relate. You've seen cases where you have a set of spares that are not used throughout the life cycle of an equipment. So what that translates to typically is money. It's money that is not put to use. So in that direction, one of the KPIs he mentioned is the cost. And I think if you evaluated the locked up cost in spares, if you tracked this, you can improve this precisely if you do your predictive maintenance right. Because why would you have to stock almost the entire equipment in modules on the shelves, collecting dust, and yet you're never going to use these modules? So if you have a KPI, like locked up cost in spares, for example, so if you can put this cost as low as possible, then it is highly likely that you're doing your predictive maintenance right. Because if the equipment can warn you in advance, 6 months in advance, that a given power supply module is deteriorating, it means you can place the order at the factory. It means you can factor in the logistical time and all that you need to have the item cleared and received. It means you literally don't have to stock too much spares. And it means that money can be used maybe to train personnel on other things and to invest in other things. And so I think that is one of the direct KPIs that we can track to tell whether we are doing this right or not.
Yes, thank you very much, Engineer Kato, on that. And you also mentioned something very pertinent. Can we convert that cost of spares into sponsoring training for the ATSEPs so that they are more competent to convert into this predictive maintenance, so that we are more competent to get onto the cybersecurity and the use of AI in such? Maybe a year from now, when we gather again for such a conference, can we ask ourselves the same question? How much have we learned? A year from now, how much shall we have learned? How many more ATSEPs out there will have gained the knowledge that they require in order to be competent to get onto this predictive maintenance using AI and the such? So, Engineer Kato, like you have said, there's a lot of change that is required amongst us in order to be able to achieve predictive maintenance using the new technologies. So how can the ANSPs manage the cultural and organizational shift that this requires, so that we can trust and adapt AI for operational decision making? And as we are adapting these changes, are there any concerns regarding ethics and regulations?
Thank you for that. Yes, so I think the question particularly relates to the resistance to change and the inertia that our organizations tend to have. You typically, even with the very good intentions, you have to create very strong justification to the decision makers for you to introduce any changes in a working system. I remember when we had just joined, there was a saying that if a system is working, please don't touch.
Yes.
Please don't touch. So in that regard, number one, we adopt what we call a risk-based model. For every change in the industry, typically, you'll have to do a risk assessment. And the idea here is you identify all potential risks and vulnerabilities, and you propose mitigations for them. And of course, you may not reduce the severity, but you reduce the likelihood. Okay, you reduce the likelihood and so on. So number one is to do the risk assessments. If you're going to convince management or the regulator, the language they understand is a safety case. Do you have a safety case? And one of the things that power your safety case is the risk assessment. And you ensure that nothing is in the 5 A's and you know the matrix. Yes, so the other thing is to demonstrate value, okay? Because at the end of the day, this is about money. If you can demonstrate value that if we adopt this particular technology, the bottom line is going to improve by so much, okay? It becomes easier to relate with the decision makers because they understand dollars. They may not understand when you say, we have so many spares that we don't use. But if you translate this to dollars, then the discussion starts to make a lot of sense. Then the other way I can think about is to do pilots. Say, for example, I may not introduce predictive maintenance on a live system because the stakes are too high. But for example, if I did this using a pilot, a demo setup, and I collect this data, I'm able to generate the insights. And whereas I may not act on the insights in the moment, but I'm able to demonstrate to the leadership that I can predict failures before they happen. And if I do this over, say, 1 year or 2 years, I have a very good data set that I can use to build a very strong case to justify to the leadership that there's value here and there's credibility in the technologies. So in other words, we cannot just adopt these systems blindly. There are a number of things within the industry that you have to try and see how to adhere to in order to build the confidence of the decision makers and the regulators, and hopefully you can get acceptance. Yes, thank you.
Thank you very much, Engineer Kato, for that. I would like to open up the floor for questions from our very good audience today. Any questions regarding, please? Did I see a hand up there? Yes.
I think he has a point here, just to...
Okay, to add up on what my colleague has been talking about piloting, we all know the case of this Boeing 737 MAX series on the issue of MCAS, the maneuvering characteristics augmentation system. It was like an automation system that was created to just keeping the plane balancing. So that system, the pilot were not aware of that, and even the manufacturer himself, Boeing, was not disclose it. And we know 2 fatality accidents happened, the Ethiopia Airlines and the Lion Air. So when you are going to predictive maintenance, we should exactly do the piloting on not on a live system, so that those challenges and the difficulties that we can encounter, we can rectify them before going to a live system. Let's take example, you implemented the predictive system maybe on the radar system, and the system tells that it fails or it degrades the performance. You decide maybe to phase out the system. A lot of costs are associated. So doing piloting, it will help us to know exactly how will the predictive system works. How will we gather the data? How will we protect the data? How will we train? How, as IFATSEA, we can train? How we can have a smooth migration from preventive or from the scheduled one to the predictive maintenance. Taking a pilot study and understanding it very well. It's not an overnight thing. We have to be sure on when we are shifting, how we are shifting, and what are the outcomes. We need to know them, prepare risk management or prepare risk matrix, and have a fallback procedure that when this fail, how will I go back to normal? How will I will ensure the service continuity and the business continuity model on ensuring the safety? Because whatever we do, our primary objective is to ensure that the safety of air navigation service is maintained. Thank you.
Yeah, thank you very much, Peter, Engineer Peter, for that. How sure am I my data is safe? How sure am I we are upholding safety and security, even though we are under this pressure to adapt the technology? We have to go back and keep our first principles true. We had a question from the audience. Please introduce yourself and then ask your question. Thank you.
Okay,
very much.
Thank you. My name is Gilbert Manyonge from Kenya. First of all, I want to congratulate you guys for the good presentations that you have done. My question is, I can see the urge for us to move away from the traditional preventive maintenance to the predictive. So are we saying that we are just going to blindly move away from the existing maintenance management systems, or are we going to integrate the predictive maintenance tools to the existing maintenance management system? Then I would like the panelists to try and address the issue of transitioning from the traditional preventive maintenance to the predictive maintenance in our legacy systems. Then the final part is, of course, we are going to use the sensors in implementing this predictive maintenance. How sure, are we sure, 100% sure that we are going to get the right data from the sensors? Or in a nutshell, how are we going to address the false positives in our predictive maintenance systems? Thank you.
Thank you very much for that. Before we lose that trend of thought, I would like to invite Engineer Umsonga to answer that. Maybe if I can give a small recap of what he's asking. How are we going to integrate the predictive maintenance in our current legacy way of operating? How are we going to transition from this legacy preventive maintenance to the predictive maintenance? And then are we sure we are getting the right data from these sources of data? I believe you had mentioned a bit of that earlier. Thank you.
Okay, thank you very much. The first and the second question, I think they are related. The third one is a bit different. I'll answer them separately. It's about transitioning from where we are, which is mostly predictive maintenance, which is mostly preventive maintenance, to predictive maintenance. Now, maybe let's make this clear. When we are talking of predictive maintenance, we are not saying that now there will be no preventive maintenance. The two will run concurrently in this manner. The kind of preventive maintenance you have been doing is what you call time-based or condition-based, without any data. It's not data-driven. It's either time or condition-driven. Yeah. Preventive maintenance, which you have been doing, is time or condition-driven. You do because a certain condition has been seen on the equipment, or you do because certain time has come to do certain actions. Now, predictive maintenance can aid preventive maintenance. For example, if already your data shows that your equipment is likely to fail at a time T, that means you won't wait the time bound to carry out your preventive maintenance. You will do it as predicted. You will carry out your preventive maintenance as predicted. So we are not going to abandon preventive and they say today, from today, no preventive maintenance will be done. It will be done only that it will be based on prediction. That way we save. It's to be more costful or beneficial in terms of cost than what we have been doing, which is condition-based or time-based. So we are not throwing away preventive maintenance. We're only enhancing it by bringing predictive maintenance. We do preventive based on what has been predicted. I think that I'm clear on that one. And then the other one, I think my colleagues also come in. The other one is about, the last one is talk about the data. Yeah, the data is talk about how sure are we that this data is going to be effective. The sensors are going to have enough data or correct data or data of integrity to be able to be used without issues of how good it was. Yeah, the issue of data, and maybe my colleagues will come in, is a matter that is have to be addressed from very beginning. Why? Because data represents the expertise of the system. You get wrong data, your maintenance will be as good or as bad as the data you have. Yeah. So from the word go, our data must be based on expert. As much as we are saying that we don't need corrective maintenance, we need it because that is where our expertise data is coming from. I am an expert on VR. Today I work 1, 2, 3 years, I record my data. Yeah. That data forms the basis of what we are going to use in AI. If it's not correct, AI will not be correct. So whether it's our sensors, no matter who they are, But if the data we have is not correct, it won't work. So basically, the data, it will be as good as the ATSEPs. If ATSEPs are not good, the data will not be good. Yeah, thank you.
Maybe I can supplement a little. Okay, yeah. So on the second question of data integrity, you have set up a system. How do you trust the data that the system or the yes, sorry about that. Yes, how do you? The question is, how do you trust the predictions that this predictive maintenance system is offering? So, if you think about it, one of the key areas of concern is what my colleague has highlighted. If you have a very poor training data set, when I say training in this context is how do you generate the models, the prediction models? You go through a process called training. Part of the training process is you have a data set that you label. And labeling is simply saying this is okay, this is not okay. For example, if you're tracking a parameter such as RF power, radio frequency power, assuming you're working on a transmitter that is rated to operate at 100 watts, okay? That is the ideal radiation power, okay? Imagine you're tracking this RF power over a year. And in the first year, things tend to look good. You have your 100 watt. But eventually, you start to register 95 watt, 93 watt, 92 watt. Eventually, the idea is this transmitter will deteriorate until it cannot radiate and cover as by design. So the labeling is you're trying to label and identify those data points that are undesirable or anomalies, okay? So which means if your data capture process was not okay, the model you'll get will not be okay. So you'll make very bad predictions. So garbage in, garbage out, like he mentioned. Then on the second bit, you know how we do audits on many of our processes. And the idea is to introduce the checks and balances. So one of the things that most people point out in this whole context is that we should not delegate our powers entirely to the machines. So there's the idea of the human in the loop. So even with a prediction, there has to be a qualified individual to look at this prediction and compare it with the realities on ground, and then proceed on whether to act on the prediction or not. So I imagine in the first phases of this, we shall have people within the loop of the process to audit, to verify the predictions as we refine the models, as we improve the models. So it is not unlikely that in the future we shall have, as part of the audits, we shall also audit our predictive maintenance systems. And in these kinds of audits, you'll have people running drills. You simulate situations on the equipment side, and then you see whether your predictive maintenance system is able to flag these situations. And it is likely that eventually we shall run these in cycles of maybe quarterly or annually, and all these are ways of improving our confidence in the systems. And at a lower level, maybe you can say, instead of using one sensor to capture this data, you can do redundancy. In fact, sometimes you don't want to use two, because if you have two and both, one is saying, this is wrong, this is correct, how do you decide? So you go for an odd number, because then the vote is easy. Majority, democracy, you say, how many sensors are saying this is okay, versus how many are saying this is not okay. And you say, okay, fairly, if more sensors are saying this is not okay, it is likely not okay. So there are those low-level design decisions, and then there are high-level design decisions, as well as checks within the systems. So I hope I've tried to.
Yes, you have. Thank you very much. Actually, as you mentioned, not to delegate all the thinking and the learning to the machines. I know I'm really passionate about AI, but I have this underlying fear of what will happen 50 years from now when we have taught all the machines how to think and we have forgotten how to think ourselves. So at some point, we might need to strike a balance where we have to keep thinking. We have to keep this muscle working, otherwise it might forget. So, Engineer Mary, you had something to supplement to that.
Yeah, actually what I wanted to say, Richard has mentioned it, in the area of the reliability of this data. Redundancy is very important, and he has just rightly mentioned that. You have to cross-check your data with several other tools. And then I want to mention particularly that for every system that you are trying to gather data, you will need to study the best tool that can give you the best data. It may not be applicable to all. And then I think our OEM has a role to play in this, in the interoperability of these facilities. Some of these facilities or this equipment, some of them may not be exposed or compatible to some of the data information that you need to be able to access this. So you also have to study the kind of facility you are trying to take data from, because that will help you in be able to get the most reliable data. But as he also mentioned, I think we need a period of test. You know, have to test run some of these things, not just to take it hook and sinker and start using it. You have to test run it. You have to prove it through some of the maybe laboratory, and be sure that this works and works perfectly over a time before you fully deploy, you know, to use them. Otherwise, you will run into crisis, and we know that mistakes in aviation are very costly, and we wouldn't want to have such. Thank you.
Thank you very much. Another question from the audience. Yes.
Okay, thank you. Timbile Anogo from Burkina. For us technicians, the easiest way would be if the manufacturer already implements the possibility of predictive maintenance, so that the system itself could give directives to technicians to say parameters are deriving, so you could do this, you could do that. But now we are working on R&D in our companies. Think that it should be a good thing that things are harmonized or standardized. I mean, for a given equipment, what should be the format of the data, so that locally the technicians or the engineers can connect to the system and upload the parameters and make the application that analyzes the system in order to implement the predictive maintenance. I think that this should be a good thing. But if there already studies or works on in this direction, I mean standardization of data set implementation.
Thank you very much for that. Who would like to take that? Engineer Peter? Perfect.
Okay, thank you. I'd like to respond on the on that. I think for I don't say modern system. For most of the system, we have this something called the BITE, the built-in test equipment. It's like a built-in system that they manufacture, have it in their system, that they collect all the system logs, all the performance parameters are there, and it generates system logs based on the time that you want to assess them. So from these system logs, they are there, It's just our duty as ATSEP to analyze the logs and know actual performance of the system. It just show only the logs, but the predictive maintenance will add a value that it will just analyze the logs, and basing on the trend of the logs, based on the trend of the failures, basing on the trend of the performance of individual equipments, it can predict to you that maybe on this transmitter the power amplifier will fail. So it will just alert me basing on the trends, as my colleague Richard was explaining on the power degradation. So what exactly caused that power degradation? There must be a certain equipment or a certain chip in that transmitter that degrades. So analyze it. We have the system logs. Actually, the current system support these logs. We can get the logs. The issue that do we have someone that can clearly have the intelligence and the machine learning or an AI to analyze the logs and to predict that basing on these logs, my equipment will fail on a certain time. Thank you.
Thank you very much for that. Yes, Engineer Msanga.
Yeah, I think there's part of his question which maybe it's not coming out. Yeah, the format. Yeah, exactly. The format or the data sets. Now, he says this equipment may come with already format or data sets from where it's coming from. But maybe what we need just to look at is that many equipment, the environment attached. You see, if I come with the equipment from Japan, the environment there is different. Let's say, for example, some of the parameters I'm tracking is maybe temperature, pressure, signal degradation, maybe vibrations, yeah? Now, in the environment of Japan, that could be different. So if the system was already developed in Japan, and the data sets are for Japan, and then you bring here in Uganda, it's very unlikely that these data sets will work for this particular system. Yeah. So it's important that you have a time to drive or develop your own data for the system in an environment in which you have put your system. I'm not saying the digital twin data or the prototype data it came with is wrong, but you have to beef up your data by include the local context. Yeah. Thank you.
Thank you very much for that. There is also something he mentioned about standardization of the data set. If you're having a manufacturer putting an aspect of predictive maintenance, and then also you have an R&D effort also towards predictive maintenance, do we have any kind of standardization framework that can guide us as maybe a continent or as a nation? Do we have any effort towards standardizing or creating a framework for predictive maintenance? Maybe Engineer Mary, do you have something towards that?
I think that has to be developed, because that's exactly where we are now. Looking at what is ahead of us, part of what is our responsibility is to start developing procedures throughout adopting this predictive maintenance, and that will automatically bring in the kind of processes that will be used. So it is also a responsibility to this house, the IFATSEA, and our regulators, our ANSPs, to begin to look at, the processes of adopting this whole predictive maintenance issue. So the standardization is going to come in the document that will be developed, and I want to believe that even this discussion is already forming a working document that is going to be helpful for the implementation of this predictive maintenance. So going forward, you will discover that we will be on the same page, having understood properly what we are supposed to do by reason of a workshop like this and other documents that will be developed. So I think it's a process. The process is ongoing. The standardization is not already automated or already in place, but it's something that is going to come up in a process of time. So I want us to like open up just like we are doing now, and begin to look at what generally we are going to be adopting. So I think in the process of time, when this house has fully developed, materials on these discussions, you will discover that the standardization will never be an issue. Thank you.
Thank you so much for that. Another question from our president, IFATSEA. Michael, can you give our president the sorry, please give him the, okay, you have someone already? Okay, go ahead and ask the question.
Okay, thank you very much, colleagues, and good morning. My name is Thomas Chauke. So the question is an online question. Someone watching online, he said I should ask this question on his behalf. So the question, it reads as follows: how do we assess and link these emerging trends as a result of digital transformation to our level of development as a continent to ensure a smooth adoption and implementation? Thank you.
Thank you for that. Engineer Kato, would you like to take that?
I'll attempt, but I hope I understood the question. So I'll try to re-echo it to see whether we understood it the same way. So from what I noted, it says, how do we assess and link the emerging technologies to our level of development? So my understanding roughly is there seems to be a concern that maybe these look like technologies for the rich economies. Yes, so, but I don't want to think like that. For example, Excel, something we all use, can be a starting point for this. So I think sometimes we from these kinds of discussions, it can appear like this is something very advanced, very out of reach, but many of us collect parameters from equipment on a monthly or quarterly or biannual rate. I think we can all relate. We always have checklists, and but if I can ask, where does this data go? At best, you have a box file somewhere, and you punch in the holes, and someone not observed or whatever, and then you file. So I think, in as much as this looks a bit advanced, we can start from there. Okay, you have all these parameters that you've been collecting on the DVOR, on the ILS. Of course, many of them may not matter, because if all you're collecting is lead on, lead off, the lead is green, that may not really provide a lot of value. But if you dig in and look at some other parameters relating to the current, the voltages, there's value here. And so, in as much as this discussion may look a bit extremely advanced, we can start from utilizing the multitudes of reports and data that we collect from equipment, and then we throw it into Excel. You'll see some of these parameters deteriorating if you pay attention. A brand new equipment, and actually one of the ways of establishing the ground truth is your reference, is what you trust to be true. One of the sources for your ground truth is the factory acceptance report and the site acceptance report. We know when we go for these exercises, there's a whole lot of parameters that you check in the factory. If you kept tracking some of these parameters, you can be able to predict if your modules are failing or not. So I think to answer the question more directly, yes, we may not have a linkage. The discussion may not appear like there's a linkage and to poor countries or developing countries or slow developing countries and all that. But in my opinion, there is something we can do within our capacities, from the reports we collect, from the tools that we already have. The idea is now to create time and focal persons to really dig into this data and compare it with the factory acceptance reports, with site acceptance reports, and try to make sense out of this. You'll pick some insights, I guarantee. I hope I have tried to show the linkage.
Okay.
And I want to add something.
Okay.
Yeah, I want to add that, you see, Africans were doing quite a lot And let me tell you, we are good at what we are good at. The issue at hand now, we can even be the driving force for the global aviation body, because most of the times what we can do, we think we cannot do it. But I want to assure you that Africans were doing very well, and we will continue to explore that strength. And I want to challenge us here to believe that we are good as where we are. We are not small. Just like he said, we can start where we are. Where we are, we can start. There's no law that says you must implement this whole process in a day. So where you are, what you have, the resources you have, there's always where to start. So I believe we are good enough to do this. We have the intellectuals. People like you and I are here exploring these processes. And if we go out there and put our hands on the facilities and try to implement these things, we'll discover that it is as easy as we never thought of. Thank you.
Yeah, maybe just add something before. Yeah, I think the question wanted to maybe to spread fear that maybe Africa is not ready for this particular technology. Unless because there are two things here, technology and maybe cost. He tried to imply that maybe cost may be too high for us, and also he's tried to say maybe we don't have the capacity to handle that technology. But what has come out is very simple. Big technologies don't come from big brains, and I think when Richard was saying yesterday, some of the casualties which are going to be to go down because of this technology are people who have what we call professional qualifications. AI does not require a degree. I think I'm right. It doesn't. In ANS, I mean in CNS, we have done more complex technical things, more better than this, more advanced. Adaptation of AI tools or predictive maintenance requires basic education. Basic education. It does not require, and I think Africa, we have too much basic education. Yeah, it's just too much. Maybe if you mention cost, we can say maybe cost may be issues, but we are saying for this particular technology, even if it means selling the whole of Africa to have it, we would rather do that. Yeah, but also, if you look at technologies like M-Pesa, which is spread all over the world, is a technology for Africa, isn't it? Maybe some of you don't know, but M-Pesa, which is all over, is a technology for Africa. What you are talking about is nothing compared to M-Pesa technology, which is a system used all over the world. Yeah, and this is African born. So the issue of technology, well, it's okay. I don't think that there should be a deficiency of knowledge or technology in Africa. I don't believe so. This is a very basic thing, and every time we hear people saying that adaptation of AI is done by elementary school dropouts, people are hobbyists, people are just enjoying themselves. At that level, surely we can't fail. Yeah. Thank you. Yeah.
Thank you very much.
Okay, my name is Jubilant Kane, and I'm with ACAMS, a solution provider. I would first of all want to thank the panelists for this very engaging conversation, because I believe these are the right kind of discussions we need to be having if we want to make progress, especially in our industry and for that matter in Africa. And as a solution provider, we equally have also prioritized predictive maintenance solutions, and I'm proud to say my company ACAMS currently has an active solution that actually focuses on that. Hopefully tomorrow we can talk more on that during my presentation, but I believe to have a solution that can collect faults, that can report failures, use machine learning to based on the historical data available, to even use mean time calculations and then predict future faults, I believe it's a very cost-effective measure, and I believe Africa is actually ready for it. And if you look at it, I don't think it's quite expensive, because if you look at the kind, I don't know for other countries, but a few places that I've been, you realize that the maintenance culture is a little bad or is very poor, where we would have to wait for certain systems to, experience very long downtimes, or have to actually break down before some reactive measure has been taken. So to be able to predict using the frequency of failures or how quickly certain systems are able to go down, and then predict that, okay, this ATC CNN system in a particular airport went down at this time, maybe 4 or 3 times in a year, and our system is able to predict that, okay, maybe in the next couple of weeks the system can go down. I think it's a very good information we can rely on. And not to sound as if I'm marketing my product, but the systems allows you to log and store data, which is another headache, because at the end of the day, when you even store them, where do you keep them and what do you use the data for? So all this analytics and data are available to you for you to play with the numbers, and the system also helps and guide you in predicting, and also help you at least set necessary interventions to avert future faults. So I'm quite happy about this conversation, and I would say kudos to the panelists and the entire team. Thank you.
Thank you very much for that. My president has had a burning question just behind you.
Thank you. Yeah, so first of all, I wanted to add something on the previous question, the issue to do with adoption of this technology and whether we are ready for it. The good thing, the panelists have already addressed the issue of where can we start from. So according to me, the level where we are right now, we can actually take advantage of this predictive maintenance, because like Engineer Kato said, we collect this data on a monthly, but currently we only put it in box files and store it away. So as of now, at the very minimum, the least we can do is to transform that data that we collect and ensure that at least we capture it in an electronic format, which can be as simple as Excel, and then do the analysis from there. Okay. From that level, we can then move to the next step, because this data, as Engineer Peter has already stated, is available in the equipment itself, because the manufacturers do have a lot of this, they do plan for a lot of these situations, and include the built-in test equipment that has this data. Okay, so what we need now is to find a way of interfacing with these systems to pick this data in real time. Okay, currently many of the systems are being developed with the standard monitoring protocols, that is SNMP, where we can actually retrieve this data in real time. So if we can pull this data from the systems and then have it in our predictive maintenance system, we can observe and monitor the parameters in real time. Okay. If I use an example of let's say the radar system, you know, there are lots of things that you could be monitoring. You could probably be looking at, let's say, the rotation of the antenna head. So in there you have a motor and it's rotating, so you'd probably want to look at the rate of those rotations, the current being drawn by the motors, and so on. Okay, so this data could be available within the data set that the manufacturer provides. Okay, but you could also have a situation, for example, it's just an example, maybe you want to look at the vibration, the rate of vibration on the motor head, on the radar head. Okay, so for that, maybe let's assume that there is no data that you have. So this would now be the third step, where you're looking at integrating new sensors and other data sources that are not originally provided by the manufacturer. So for example, you could have a sensor on the radar head that is looking at the vibrations, the rate of vibrations. You probably have another sensor that is looking at the current being drawn by the motor, for example, and then you'd integrate these into your system, okay? So you see this 3 steps. The step 1 of doing the minimum, look at the data that we are collecting. Step 2, take advantage of the data that is already being provided by the equipment manufacturers. Then step 3, we can now add our own sensors to collect more data that is not already there. In that way, I think we shall have this predictive maintenance nailed down. Thank you.
Thank you very much. I had Engineer Mary here whispering, very good. I think, like he had said, it's complementing exactly what he was saying, that we actually have what we can start with, and that is really reassuring for us. I think we have time for one more question. Yes, 1 or 2, 1 and 2, just one. They've given me only one more question.
Thank you. Shadrach Gerupe from Kenya Civil Aviation Authority. My concern is in this predictive maintenance. One, there are some inherent problems in the equipment. Does predictive maintenance address this? Because I see that some data are more difficult to process, either like just as my friend has said, like vibration, like the sound, some electrical whatsoever. These inherent problems are the ones causing damages to our equipment, really. And if you now embrace this technology, it means we will have a lot of sensors, because some problems are within the equipment. How is predictive maintenance addressing that? Thank you.
Yes. Who would like to take that question? Okay, Engineer Kato.
Yeah, so the question is,
how can we solve the inherent problems in our systems?
So when you say, maybe we need to qualify the word inherent. When you say inherent, are these problems related to the design, the choice of material that is used in the design of manufacture of the, when you say inherent, just to ensure we understand each other properly, what do you mean by inherent? Is it something that is inherited from the design process? Or?
What I mean is like now, for example, noise in an equipment. That noise comes within the equipment. It's not either from other sources, you see. It is something which comes within the equipment, some faults. Like now, the rise of temperatures, what those things. Can we really process some data? Is it very easy to process those data so that we can predict the outcome in future? So what I mean by inherent is something within the equipment causing damage.
Okay, yeah, so maybe we can pick an example. If you say, for example, you have an equipment that has moving parts, and for some reason the moving parts are humming, okay? Say the moving parts, maybe it's a fan, a DC fan, or you use this fan to do some cooling. And say you observe that on a given day, your fan is humming. So then the question is, can we identify the root cause of this humming by using predictive maintenance? And when you say, is it easy or not? The answer is, it's not easy. But of course, once you have the data, you now begin to look at the possible root cause, okay? And this cannot be a blind search. You also need to understand the equipment itself and try to see the root cause, the relationship between the behavior, the observed behavior, and then the inputs. Many of the times here, most of our problems actually on the continent, as far as the reliability of equipment is concerned, are associated with the quality of the power. And that's why this is a very good starting point what kind of power are you injecting into the equipment? Many people or many manufacturers will tell you we are looking at 240 volts, 50 Hz. But there are places you go to and you barely have 150 volts, or even the frequency is 60 Hz. So there are implications. But if you don't track this, you'll only focus on the humming of the fan, but you may not tell. But over time, you start to identify patterns, okay? You can start to identify patterns and the relationships between the data sets. You say, for example, we've observed that every time the input voltage is 150, I have a fan humming, okay? Then you can see the causality. Of course, the people in data science will tell you that correlation is not causation. But if you dig down eventually, you can find some of the root causes of some of these things. So in other words, the more data, the better. But you also need to understand the equipment, and you need to pay attention to identify the relationships between these data sets. Yes, thank you.
Thank you very much for doing that justice. I'm afraid I may not be able to take any more questions for now, because our time is fast spent, but please be free to approach the panelists even during the break for more engagement. I would just like to give us a chance to wrap up. Each of us on the panel shall just answer the question. If you could recommend at least one immediate action for any ANSP represented here, what would it be towards predictive maintenance? What is that one parting recommendation that you would give? Starting Engineer Mary.
Yeah, thank you. I think to the ANSP, I will strongly recommend a strong awareness on the issue of preventive maintenance, and then to start having budgetary allocation to the training of ATSEP in positioning them to be able to build capacity to take this challenge of the new trend and the disruptive technologies that are emerging. So to the ANSP, I think we need to invest more in the training of our ATSEPs, giving them the right exposure, allowing them to attend workshops, forums like this that can develop their capacity to be able to give the best to the ANSP. The more we expose these officers, the better we have the use of them. So I think if we can explore the potentials of our ATSEPs, there's quite a lot the ANSP will have to benefit. So this is just but the starting, and we can do more in organizing workshops like this and other documents that we can explore for the betterment of our services that we provide to the aviation users. Thank you.
Thank you so much.
Yeah, mine, I'll just, parting short, I'll just pose a question. This is a case where you have two ATSEPs. One who is very good at corrective maintenance. He does his job very well and is able to work within time and deliver results. And then there's one ATSEP here who can be able to predict when the equipment is about to fail and arrest the situation. Which of these two is more important in the corporate? The one who is able to take his time, do corrective maintenance very well, and deliver, or the one who is able to identify failure before it happens and then arrest the situation? Now, maybe what CIA should be thinking about is how important are these two people? I'm saying each of them is important in its own phase, but one can phase out the other. Now it's upon you to know which one can phase out the other. And if you look at it critically, the guy who can be able to predict whether and when the equipment fails and take action before it fails is likely to increase the equipment uptime, and also levels of safety will be higher. But then he needs data from the guy who knows the system, or else his prediction won't be correct, isn't it? So the two guys are necessary. But if you are given a choice, a hard choice to phase out one, whom would you phase out? I think that's my parting shot. Yeah.
Thank you so much for that.
Okay, on concluding, my advice to ANSP is that we should change the perspective on how we are doing maintenance. We should focus more on data, because on these emerging technologies, data is the center of everything. So we should focus more on analyzing the data and analyze the system logs to just know exactly what does the logs tell me, what am I supposed to do. And it's not only about analyzing the data, but it's about enabling us as ATSEP to know exactly what the system does, because having a predictive maintenance in place is just one thing, but using it effective to ensure that my serviceability is up, my equipment uptime is good, and the required level of safety is met is another thing. We are having these technologies, they're emerging, but we as ATSEP and as ANSP, training of ATSEP is very important, because I might have the system logs, it tells me exactly that the system will fail. But if I don't have someone who can just rectify the problem that the predictive maintenance is just showing me, it's another thing. So the system, the equipment trainings are very important, but how do we train? That's where the issue comes. And on the maintenance, we should not just only look on the LEDs. You know, when maybe I enter the office, I'll just look on the LED, all green, green, green. I say my equipment is fine. But going through the system logs, I may identify there are a lot of parameters that are fluctuating. And with time, my equipment will be off. So we should focus more on, rather than just thinking that this is okay, basing look on the LEDs. I must share a simple experience on the telecommunication sites. You might find the equipments are off, or the equipment are failing. We did a research and we found that power is an issue. So we did we invent this remote monitoring for monitoring the power. We see there are three sources of power. We have the commercial power from the utility. We installed the backup system, the generators and the batteries. But the system kept waiting off. So we discover a way on how we can monitor the performance of each system through the alarms. The alarms tells us each and everything. When the mains fail, the generator failed to peak, I should know. When the batteries are the main power supplied to the system, I should know how is the depth of discharge, at which point I should allow my battery to discharge. And the system itself, according to the consumption of power, how long the autonomy of the battery will last for how long. So it just alerts me that I don't have mains power, the generator is not running. Maybe it's not running due to low fuel or some mechanical problem within the system. The battery is taken over. I should know the depth of discharge. I should know the autonomy of the battery. I should test my batteries to know that how long they will be last. So this predictive maintenance will allow us to analyze more of our equipments, and will help us to predict in the future that the lifetime of equipment will be maintained well, and I will ensure that the safety in provision of air navigation services is met. Thank you.
Thank you so much, Engineer Peter. Go ahead.
Yes, thank you. I think most has been said. Data is the new oil, like we mentioned. Collect that data, analyze it, and make sense out of it. And then number two, we should stop looking at the systems as black boxes. I really emphasize, as you write your specifications, as you specify new equipment or upgrades on equipment, please request the manufacturers to provide standard interfaces for you to pick data in formats that you can make sense out of. And unless you really push for this, it's usually harder to ask for such features later during the life cycle of the equipment. The best time is when you're writing specifications. Ensure you ask the manufacturers to provide standard interfaces to allow you to pick data and use that data the way you wish, because you've paid for it anyway. Yes, so thank you for that.
Thank you so much, Engineer Kato, for that, and many thanks to this wonderful panel. Please give them a round of applause for a very good session this morning. I can see Kasirie has something, a small token of thanks to them. Please come and hand it over, and I think my job here is done. Thank you so much for being a good audience.
Thank you. For us, we don't just clap, we also give something. So please, Brenda, do the honors.
Thank you very much, and enjoy your break.
Thank you so much. Wow. For our dear guests, it is already 11 o'clock or some minutes past. It is not like we are delaying you for your breakfast because we have little, but in Uganda there is enough food for the entire year with variety. Every day we can give you something different for the next 1 year. So please, the delay was because of your questions. You had very many questions. So without delaying a lot, allow me to say a few things about the panel. I want to commend the organization for the balanced panel. This setup was fantastic. And many more panels are coming, but when I was looking at this panel and what they were engaging in, they were really, really balanced from left to right. But I have to warn you as the audience, pay attention to the questions, not the answers. And that's why I have to appreciate the audience for those many questions you've been asking. Thank you so much. Robert was answering something and he mentioned, he used very many words, but was asking, what is your value at your workplace? He used many words, but is asking, the organization is asking, whom should we relieve, whom should we stay with? Then one of the delegates talked about false positives. Those are very new words and interesting. So as we engage, there are three things I've picked out. We are sharing insights. We are sharing experience. But above all, we are sharing context. My brother from Tanzania kept on saying, like, at our place, we do it this way. And Richard is also saying, at our place. So you can see we're having this variety from all over the continent. That's so beautiful. There's nothing that works as a magic wand. I'll live by leaving a quote right now. A design is invisible, seamless and intuitive, serving without drawing attention to itself. I'm talking about a design. A bad design screams its inadequacies and makes itself noticeable. Don Norman, as engineers, or the engineering that we are, we must stay invisible to stay visible. When everyone is talking about your work, just know we are doing a bad job. Stay in the background. Predictive maintenance. Think in the future, look for those problems before they surface. This panel has really done a very good job dissecting that. Stay invisible to be visible. That's engineering. That's what you signed for. Please go for breakfast. It is ready. But the rule today is, because we have lost a little time to keep up with the schedule, you can just go pick whatever you want. There is enough. Pick, come back, then we continue. That's about 15 minutes. Is it agreeable? Thank you very much. Same place. Just come with a cup of tea and whatever you pick. You can even go back if you feel it's not enough. Thank you.
Not perfect, but I hope you see my worth. 'Cause it's only you, nobody knew I put you first. And for you, girl, I swear I do the worst. If you stay forever, let me hold your hand. I can feel those places in your heart no one else can. Let me show you love, oh don't pretend. I'll be ready, baby, you know I'll sink or swim. Oh don't you worry, I'll be there whenever you want me. I need somebody who could love me at my worst. No, I'm not perfect, but I hope you see my worth. 'Cause it's only you, nobody knew I put you first. And for you, girl, I swear I do the worst. I need somebody who could love me at my worst. No, I'm not perfect, but I hope you see my worth. 'Cause it's only you, nobody knew I put you first. And for you, girl, I swear I do the worst.
Baby, take my hand, I want you to be my husband. 'Cause you're my Iron Man, and I love you 3000. Baby, take a chance, 'cause I want this to be something straight out of a Hollywood movie. I see you standing there in your Hulk outerwear, and all I can think is where is the ring? 'Cause I know you wanna ask, scared the moment will pass. I can see it in your eyes, just take me by surprise. And all my friends, they tell me they see you're planning to get on one knee. But I want it to be out of the blue, so make sure I have no clue when you ask. Baby, take my hand, I want you to be my husband. 'Cause you're emotions are locking, and before you could ask, I answered too fast. And all my friends, they tell me they see you're planning to get on one knee. So now I can't stop thinking about you. I figured out all the clues, and now I ask, baby, take my hand. I want you to be my husband, 'cause you're my Iron Man, and I love you 3000. Baby, take a chance, 'cause I want this to be something straight out of a Hollywood movie. But I'm done. No spoilers, please. But I'm done. No spoilers, please. Baby, take my hand. I want you to be my husband, 'cause you're my Iron Man, and I love you 3000. Baby, take a chance, 'cause I want this to be something straight out of a Hollywood movie, baby. No spoilers, please. But I'm done. No spoilers, please. Oh, oh, oh. Right from the start, you were a thief, you stole my heart, and your willing victim. I let you see the parts of me that weren't all that pretty, and with every touch you fix them. Now you've been talking in your sleep. Oh, things you never say to me. Oh, tell me.
I found love for me. Darling, just dive right in. Follow my lead. I found a girl, beautiful and sweet. I never knew you were the
Members, welcome back. We are about to start in a minute. Okay, let's start. Our next agenda item is AI in aviation, exploring the impact of AI in aviation safety and cybersecurity. Another very different topic altogether, but still connected to the theme of the event. I'll call upon the president of IFATSEA, Madam Angela Habali. Take us through. Thank you. I did not hear some hand clap. I know your hands are full, but please. Thank you. Angela.
And surely you have to clap. You know, in my country, we say it's a ladies' era. So being the IFATSEA president and standing in front of you, I feel proud. Thank you so much, the director of the ceremony. We have a very interesting paper this afternoon, whereby we are going to check on the issues of AI integration in the CNS ATM systems. We have heard from the different presenters from yesterday when we spoke about the 4th industrial resolutions. The papers of today, also in the morning, it also touched upon the AI. We are not going to be very much afar, as it has been said. And as we all know that AI plays a vital role in the safety of air traffic management, the AI alongside human intervention has created the benefits by enhancing efficiency and increased capacity on air traffic management. We have its benefits and its impact, which now it's our role as an IFATSEA to look upon. So in our discussion in the paper, we are going to look upon two things. We'll look on AI integration in CNS ATM system. We'll explore how service providers and regulators implement it and the challenges they are facing. And this is going to be presented online with our very good and experienced presenter, Mr. Nkululeko Ntombelo. We will also have a second paper, which is going to check on the impact of AI in safety and cybersecurity. That also will be presented with Mr. Katongole Joseph. Let me welcome Nkululeko Ntombela, who is our first presenter. Mr. Nkululeko is a seasoned aviation system specialist with over 15 years of experience in air traffic management, CNS systems, and innovation strategies. He serves as the Supervisor of Technical Services at ATNS Uppington and formerly held leadership roles, including Vice President of Operations for SAAT, SEPA, and Technical Standards Specialist in the ATNS CEO's Office. Internationally, he contributes to Eurokai WG114/SAE G-34 on AI in aviation and chairs South Africa's Innovation Work Group under the National ATM CNS Implementation Committee. A published IEE researcher, he holds engineering and business qualifications from UNISA, DUT, and WITS Business School, along with multiple aviation and safety certifications. His work bridges technical excellence, regulatory alignment, and strategic innovation in aviation system. Welcome, Mr. Nkululeko. We are all here waiting for you.
Thank you, President, and good morning to everyone in Uganda. I feel the spirit of Uganda as I'm sitting here. Without wasting any time, I would like to observe all the protocols. Greetings to ARP, and thank you for leading this region to have this beautiful and successful engagement that has been happening in the last day or two. Greetings to all the leadership of Uganda, all the presidents of ATEPS associations, including my president, Thomas. I'm really glad to be here. I won't waste any time. My job is simple here. I just need to get my presentation, and you're gonna have to confirm if you can see it on your side. Okay. I guess it is ready on my side. Confirm if you can see it on your side. Can you confirm if the presentation is...
Yes, we can see the presentation. You may proceed.
All right. Thank you very much. As highlighted, I'll be presenting on the AI integration in CNS ATM system. And my name is Kulego Ntombela, as already been highlighted. I won't waste any time, but I just want us to understand firstly the background. I know a lot of speakers have spoken about what is AI. Probably if I listen to those presentations first, I was going to remove some of the slides, but bear with me as we go through this. So AI refers to the technical or technology that appears to emulate the human performance, typically by learning, coming to its own conclusion, appearing to understand complex content, engaging in a natural dialogue with people, enhancing human cognitive performance, also known as cognitive computing, or replacing people on non-execution of non-routine tasks. Applications includes autonomous vehicles, automatic speech recognition, generation, and detection of novel concepts and abstractions, useful for detecting potential new risk, aiding humans to quickly understand very large bodies of changing information. A little bit of background. AI is actually a relatively very old concept, or we call it computer science, that encompasses several techniques and covers a wide spectrum of application. AI is a broad term that we all use. We like saying AI for the industrial, but you need to understand what we mean by those words. The definition of this AI word has evolved as the technology develops. AI application can be divided in model-driven AI, also known as symbolic AI, a data-driven AI, also known as statistical AI. And the model-driven AI applications encompasses, for example, a well-known expert system that are still programmed in a traditional way. We have a current breakthrough now that is leading to a different level. And that breakthrough is linked with a machine learning, which is the use of data to train algorithms to improve. So when you look at deep learning, it's a subset actually of the machine learning that emerges through the use of deeper neural network. Brings the learning capability a bit closer to a functioning of a human brain. It enables applications like computer vision and natural language processing that were out of reach before the emergence of this deep learning. When you look at data-driven learning techniques, which are very disruptive in essence, and by opposition to software development techniques cannot be assessed through traditional means, approaches, and there are no regulatory guidance material that are clearly defined yet, but we'll go through that, and I'll highlight where we are in terms of the regulatory compliance or requirements thereof. I'm not sure if I have went too far. Okay. So, and the reason that's why then there was a need for developing a novel approach and trigger a specific focus in a work that is done by Eurocare, a work group 114, and in collaboration with SAE G34, which there's a development of the AI regulation in terms of that. And in collaboration, there is also EASA and FAA that are participating in those work groups. And luckily, as ATNS, we are part of that work group. We had an opportunity to lead in some of the sub-work groups of that work group, and I was representing the country when it comes to that. You'll see this is a well-defined, this is taken from EASA roadmap, how it defines the different levels of AI. And I'll refer you where you can find more information that actually will tell you more about that. So, an AI adoption in Africa and the whole world is increasing. And we are aware of that because we are talking about it today. And we're having all this session, the entire 3 days dedicated just to talk about that. And it increases at a very rapid pace, with many industries using AI to improve business efficiencies, reduce cost, improve service delivery for their clients and customers. The acceleration of AI over the past decade is strongly driven by the factors such as big data. Companies are collecting vast amounts of data. And we know in our industry, a lot of speakers have spoken about that we have data scattered everywhere. And we know that when it comes to AI, that data might have to be cleaned up, and we properly train the tools using the accurate data, because if you train it with cluttered data, you're gonna get cluttered results at the end. So computing power, the ability for computer system to perform tasks and processes that with the highest level of accuracy, leading to increased speed and efficiency in operations. And there was a beautiful presentation that was done on for Industrial Revolution, actually covered this item very well. A development of increasingly powerful algorithms and architectures. So AI is already integrated in our everyday technologies, and some of our African companies are using generative AI in at least one of their business function. It is clearly visible that the aviation system and industry at large is already affected by this technological revolution. We look at the security, the simulations, the passenger services, and many, many more. We have reduced separations, term-based separations. We have the runway incursion monitors that are already being used in some areas. So we need to note that AI does not only affect the products and the services provided by navigation service providers, but it also triggers a rise to a new business model, new ways of controlling the airspace. Maybe the traditional way that we know, it might be changing. So we need to be ready for that and actually understand what impact will it introduce and how we're going to adapt to those changes. So as ANSPs, we need to urgently look at what is our role in driving AI, specifically considering the below key points. Question that we need to ask ourselves: what are the opportunities and challenges presented by the introduction of AI in ATM? How does the introduction of AI affect the ANSP's primary goals and of delivering safety in the skies? How does the introduction of AI affect the ATM process and regulations? What action should ANSP take to meet challenges brought by introduction of AI? And there are just a few answers here that already have been provided when you look at ICAO. I put the reference there where you can find this information. They talk about the areas of application in aviation, AI application in aviation, things like predictive maintenance. We had a lot of that. Crew scheduling, training simulation, productive issues identification, flight optimization, air traffic management, autonomous navigation, advanced decision support system. So those are just few of the many areas. And someone said it nicely to say, we're going to have new job opportunities that does not exist today based on the use of AI in aviation. So what are the challenges, though, that will be brought by the introduction of AI into our space? We're going to face with issue, or we are already faced with the issue of AI transparency, clear interpretable AI outcomes, the issues of data security risk, where sensitive data security, cyber attack prevention. How do we deal with that? Because that means we're opening ourselves up as we adopt AI. Ethical and bias issues. We need to look at bias prevention, transparency in decision making, the regulatory compliance, the global regulations, safety standards. You'll notice now that as we adopt AI, the regulatory requirements is no longer going to be centralized in your own country, but we might find ourselves actually having to comply with the same standard globally, since that the data will be more shared than ever before. The technological challenges talk about legacy systems integration, real-time data processing. The implementation cost talks about investment in infrastructure and training. So to address the challenges, then apologies, to address the challenges that will be experienced in aviation, what is the rest of the world doing currently? You'll see that we currently, as I highlighted, we are busy with developing the governance and legislation for the use of AI in aviation. One of the work that we are currently busy with is the guidance material for the use of AI in aviation, which is done under the SAE G34 and EuroCare Work Group 114, focusing on implementation and certification relating to AI technologies for the safer operation of aviation systems and aerospace vehicles. This work group comprises of 600 members, including ATNS, promotes and standardizes artificial intelligence in the entire aviation ecosystem, both airborne and ground, addressing both manned and unmanned. So the regulatory bodies such as the ICAO, the EASA, and the FAAs have started to draft guidelines and regulations governing AI in aviation through the collaboration of these work groups. And this focuses on ensuring safety, accountability, transparency, and ethical AI use in aviation. ICAO is actively working on developing a regulatory framework for AI in aviation, particularly in areas like safety management and air traffic control. Global harmonization of AI standards is a key priority, as we all know. So just to give you a brief of where is the EASA roadmap coming from and the phases that they have actually went through, you will see that it started in 2021, where the first usable guidance for level 1 AI and machine learning assistance to human, where the exploration and the first guidance was developed, and currently sitting at the phase 2, which is AI ML framework consolidation, where the first approval of level 1 AI and ML has been done, and we have the roadmap 2.0 already out, being published. I think you can Google it and find it online. It's already out there. It outlines a lot of things, the robustness, there's a lot that is covered there. I think most of the questions, when they come, you'll see that some of the things are already being covered in those roadmaps. So working together with the work group that we are part of, we take inputs from those roadmaps, including the FAA one. When we look at the EASA approach, what they did, they took the up-down approach, and then the FAA approach was the down-up approach. And the aim was that they want to understand from the from the bottom, and then make sure that they understand the impact of each and every implementation by using the case studies, while FAA looked at what is existing and how can we then make sure that it don't impact what is existing, and then start going downwards. So as you read those road maps, you'll understand their approach, but the aim is to meet halfway. I think there was one example that was made about the tunnel that was digged somewhere in the world. The other part will be digging from one side, and then you'll meet halfway and the tunnel will be complete. So this is the FAA thingy. But what is ICAO then doing in that case? In the areas of ICAO is engaged in various activities supporting multiple initiatives in the domain of artificial intelligence, such as partnering in the UN AI for Good Annual Global Summit, presenting work session on AI in aviation, as well as participate in mobility sessions, hosting internships, developing in-house deep learning AI models, showcasing natural language processing techniques for aeronautical information management, as well as document summarization, supporting local AI companies, network startups, and incubators such as Talis AI at Centec and Concordia District 3 by providing ideas and coaching. It also collaborates with McGill on the introduction of AI in aviation inside the McGill Data Science and Machine Learning program. It broadening the horizon of the AI in aviation through workshops organized in a collaboration with CRIAQ, and exploring the creation of AI in aviation focus group under the auspices of ITU to address issues relating to compliance and certification. It also collaborated with XPRIZE Foundation by providing AI challenges and participating in the global initiative on AI and data commons, in collaboration with ITU on the United for Smart Sustainable Cities initiative, including the use of AI for urban mobility. Participation also in Eurocare Work Group 114 that I'm part of on the artificial intelligence. So you can see that the world is coming together, colleagues, when it comes to this. There are no silos anymore. And we need to open ourselves up and ensuring that we work together to reach this goal. So the question is then, where to begin when implementing AI in aviation? So defining an AI strategy will assist in understanding as a first step understanding how can AI be used to improve efficiency, and how can we adopt and develop AI models that are in line with the company strategy and all aviation regulations. When organizations to successfully adopt and implement AI, it is important to identify key focus areas that will drive the AI strategy. The key focus areas will assist to define the AI roadmap for the organization, which will stipulate how can the organization use its data and the technologies to build advanced artificial intelligence that will assist improve efficiency in the organization. So one of the simplest ways that have been defined also by one of the paper that was published by IK was the first step. What you do, you identify the traditional aviation sectors. So that block represents the initiative stage or the initial stage where all the conventional areas within the aviation industry are identified and categorized in a form, informs the basis for understanding the variety and the scope of the industry. Then examine the current aviation curricula is the second step, and this block involves reviewing existing curriculum in aviation programs. It's the process of understanding what knowledge, skills, competencies are currently being taught to prepare students for roles in the aviation industry. And then the next thing will be research AI technologies in aviation, and this block will represent the investigation and understanding of the new technologies being employed in the aviation industry, which particular focus on applications of AI. This research helps to establish clear picture of the current potential use of AI in the field. And then you can define the new competencies requirements. And in this stage, the new competencies needed for working with AI in the aviation industry are identified and defined. So number 5 will then have to establish AI competency based on DICOMP. The identified AI competencies are structured and defined according to DICOMP 2.2 framework. And then number 6, you then perform the gap analysis of the existing program. And this block will involve comparing the existing aviation program with a new AI competency requirement. It's process of identifying what areas the current education and training to not cover in relation to newly established AI competence. And then propose revision for AI integration in the curriculum. And this block involves making recommendation for revising aviation program to integrate the necessary AI competence. We also have to understand AI basics and capabilities and practical competencies for AI. Someone spoke about data analysis, data science, and I think there was a question from my president. This slide I included it just to maybe assist in answering that. Engineer yesterday did well in answering that, because we do need those basics as the 8 steps to start actually expanding our scope, as we know that it demands us to do so and evolve with the changes that are happening. With that said, colleagues, I would like to thank you. That was my short presentation, and I hope it did invoke some questions that will then be ready to answer them later. We hope to see you in the 53rd IFATSEA General Assembly in Cape Town in November. Thank you very much.
Let's give a round of applause. Thank you so much, Nkululeko, for the very beautiful presentation, which is more of an eye-opener. To me, I thought what we are discussing, we might be among the new ones. But it looks like the world has already taken an eye on that angle. And ICAO is also doing some work, which as per ICAO tradition, I am happy they are starting on the training side, as you have shown us on your presentation. I have a personal question which I'm reserving. You will answer it later. But it looks like we might need to have a new annex on AI, because it's something which is cutting across the industry in the aviation, the airline, the airports, the ANSP, the regulator themselves, and so on. Okay, thank you. Let us pose some questions. If you have any question, just please note it down. We will be taking the audience questions after all the panelists will come here. We have a second presentation, which is looking on the impact of AI in safety and cybersecurity. And this is going to be presented by Katongole Joseph. Mr. Katongole Joseph, he is, okay, let me just load his bio. Mr. Katongole Joseph is an aviation safety and cybersecurity expert. They call him CNS ATM system specialist. He is a seasoned aviation system engineer and a cybersecurity expert with over 14 years of experience at the Ugandan Civil Aviation Authority. He specializes in CNS ATM systems, aviation cybersecurity, and network infrastructure, with a strong track record in aligning systems with ICAO standards. As a senior technical officer, Joseph has led key initiatives including cybersecurity hardening for CNS ATM systems, AMHS network integration, and AIM automation projects. He also developed the UCAA cybersecurity policy and has trained over 50 staff in cyber hygiene. Joseph holds a Bachelor of Engineering in Telecommunication Engineering from Kiambogo University and a Master of Science in Data Communication and Software Engineering from Makerere University. He is a certified information system security professional and has received specialized training in ICAO, IFATSEA, and aviation cybersecurity from IATA, ATNS, and the Korea Aviation School. A dynamic and engaging speaker, Joseph brings practical insights and real-world case studies from Africa's aviation sector, making complex technologies accessible and actionable, particularly in areas of cyber resilience, emerging technologies, and aviation safety compliance. Let us welcome Mr. Joseph Katongole.
I don't know if it's still morning or if it's afternoon. Good afternoon, everyone. My name is Joseph Katongole, and I'll also take this opportunity to welcome you all to Uganda, a very beautiful country, and I'm quite certain everybody has enjoyed their stay, stemming from yesterday, and it's all written in the numbers that we have today. Thank you very much, and I'm here to present my presentation. Oh, how do I go back? It seems the back button doesn't work. I'd like to go back to the beginning. Okay. Thank you. So, I'm first of all honored to be here and to present to you a topic I am very enthusiastic about. Yeah, so my name, again, as spoken, is Joseph Katongole, and I've been in Uganda. I work in Uganda Civil Aviation Authority as a senior technical officer, and I am glad to be here. So I'll start off with pretty much an introduction. we have had many definitions, and we wouldn't so much want to delve into the definitions of what AI is. AI has so many definitions, but depending on what you decide to use it for, you can come up with something that is relating to AI. But in this case, I would pick AI as just a computer system because it runs on hardware, and it's a computer system ideally that performs tasks that would, in most cases, require human intervention. So what this gives us is we have intelligent algorithms that we use that are developed, models that are developed to perform various tasks and activities and actions as well. So this is what AI offers to us. It offers us a way to learn from data, a reason to solve problems, and a way to adapt to new inputs without explicit reprogramming. So AI gives us, we have vast amounts of data that have never been explored, yeah? But with the use of AI, we're able to explore and look at this data and generate sense out of this data. So this is what AI is giving us. It gives us a reason to solve problems, yeah, or decision making. Because AI gives you, with large amounts of data, AI can give you an easy summarization of any report that you might have. Yeah, it would give you a summarization of a report. And this is what AI, because it can scroll through a lot of data and be able to generate a report. Yeah, and then the beauty about AI is it can explicitly adapt to new inputs without requirement of reprogramming. We know this, that if you use machine learning, you're going to be able to learn, oh, I'm far from the mic. Sorry. So if we use AI, we're actually going to be able to learn, to be able to adapt without need for reprogramming. So it makes reprogramming unnecessary, or reduction in reprogramming, because we have vast amounts of data and we have systems that are trained to be able to learn and learn from the new data that you provide with the system. So, but above all, what AI provides is new levels of efficiency. And this is what we're looking for in aviation, because we need to save time and money at the same time. So we need to look at what AI is, because we have had a worry that AI is going to replace us. And this briefly analyzes the capabilities of both humans and what AI can do. Because the humans on one side have reasoning, yeah? The humans have creativity, because you are the one that assigns the AI system a task to do. That's the first thing, yeah? The humans understand complexity. This is very important. Humans can do qualitative analysis. This is where you are certain that you're not dealing with data, yeah? Humans have ethics, and this is a very critical part of AI, of what humans can do, and the need for humans within the system. And then humans also are good at decision making. AI might make certain decisions, but not all decisions can be made by the AI system. So we are looking at humans being able to provide strategy. Yeah, decision making is in terms of strategy. So it's encouraging us to be more of critical thinkers, because now we have systems in place to be able to solve our problems. So we need to be critical thinkers. And then on the other side, this is where machines excel. Machines excel in processing large volumes of data, because if I give you a log file that's even just about 1 megabyte, you will take so long to analyze that particular log file or process it. But with a system in place, you would be able to process a large volumes of data. And this is why machines are excelling, and this is what they're providing to us. They're also fast at data processing. This is very evident. Yeah, the quantitative analysis that systems provide, because they're dealing with large data sets, so they're able to provide good analysis, the accuracy. This will not be able to get from humans, or it will take a longer time to achieve this. And then they're able to do more repetitive tasks. Repetitive tasks in this case, that humans get bored a lot if they're doing repetitive tasks. And it is inherent in humans to get bored. If I come to the station and I am doing the same task, it becomes more of a routine and we're tired of that. But machines are able to do them the same way and more efficiently. So I'll explain now, based on the previous slide, I'll give the reasons exactly why we use AI. Most of the critical priority, the most critical priority of aviation is safety. And this we will not stop to re-echo. It is safety. So AI could play an important role in the following ways. And I'm going to look at these ways as the slides go on. So we have enhancing safety, because that's the most critical part. And then we will use AI in risk management. That's also another important part of managing aviation safety, at the same time risk. And then we'll use it in boosting cyber resilience. That's also another important, how we can use AI in cybersecurity. And then we have spoken about it. The entire morning, the panel was about predictive maintenance, and I wouldn't stop to re-echo it. Yeah? And then it can also be used in air traffic control, and I'll explain. So first, we're going to look at how AI can be used in ensuring and enhancing safety protocols. Yeah, we talked about the predictive maintenance, that I'll not re-echo, but in terms of safety, yeah, with AI algorithms, we are able to analyze a lot of data, yeah, and analyze historical data and forecasts. Now I'm looking at predictive maintenance in terms of safety. Yes. So before, maybe we're looking at more of predictive maintenance in terms of systems, of CNS systems, but here we're looking at it in terms of safety. Yeah. So we can use AI to be able to ensure that we have safe systems and prevent systems from mechanical failure. It's pretty much the same. The second is real-time monitoring. Yeah. The beauty about AI is it can alert and trap and alert you about any system or any environmental conditions, especially when integrated with sensors. So we have programming languages. We have frameworks, actually, not programming languages, but frameworks. We have TensorFlow, we have PyTorch, we have RapidMiner. All those are frameworks that are available that can be used for you to be able to manage and monitor your systems. Yeah, you can use them to analyze and quickly note any anomalies, and therefore enhancing safety of flight and any aviation systems that we have. And then we have automation of hazard identification. You know that AI improves detection of potential hazards. Yeah, it could be system equipped, because we have to equip our systems with autonomous. We have to equip our systems with AI, or we can equip our systems with AI to be able to identify any irregularities, yeah, in flight data or air traffic system logs. Like we said earlier, that AI can process large amounts of data. So here we're implementing AI to still analyze logs, which is one of the ways we can implement and enhance our safety. So these are the challenges that when it comes to safety. Yeah. The first challenge that we have is over-reliance on AI may reduce human oversight because we trust the system so much, and yet we have to keep the human in the loop. So the most important statement that we can pick from this is trust but verify. That is a very key statement, especially when it comes to AI systems. We have regulatory hurdles in certifying AI-driven systems for safety. IASA is doing something. I think there was a presentation earlier about that. And FAA is also doing something about this. They're coming up with models and a framework to be able, because a framework, as you know, is not a solution to a problem, but a framework is just a guide for you to be able to solve a problem. And that's why these frameworks, and IASA is interested in that. So we also have a challenge of accounting for human-AI interface, especially with apps with high levels of automation. So ahead there we'll talk about something that we call trustworthiness of AI. And this gives re-echoes a way to solve these particular challenges. Yeah, and then there's also evaluation and mitigation of uncertainty. This also falls under the trustworthiness of AI that we will discuss somewhere ahead. And then now we come to another very critical part of aviation, which is managing risk. And all organizations need to be able to manage risk. Yeah. So you know that in the traditional ways of managing risk, we are not able to, we have to look for, you identify your assets, the normal process, identify your assets, and then once you identify them, then you are able to think about any weaknesses that you might, or any risks that are impending to that asset. But here you have a more data-driven risk management process. And this is what AI is giving us. Because the landscape or the threats are evolving as we go on. Threats are evolving. So with real-time based live operational data, we're able to even detect what we think about as maybe a 0 day or something. Yeah, so we're able to detect that when it comes to the implementation of AI. And we have frameworks. There's a framework, NIST has a framework for, this framework is majorly for managing risk. Yeah, it's for assessing the risk of using AI system. So this is, then we'll have, in terms of managing risk, we also have real-time data visualization. This gives us, the minute that you have real-time data analytics, you are well equipped to manage risk, because risk is definitely managed by having a lot of information to be able to carry out a decision. So you cannot make a decision if you don't have any data. So this is what AI gives us. So the immediate access gives you a way to respond to any risks or enhancing situational awareness. And then we have another issue of that where we can be able to manage risk is simulation of what-if scenarios. Yeah, because in most cases, we don't have enough resources to be able to simulate a certain, maybe what we would call sometimes a response plan, or if a fault occurred, how do we respond to these faults? So this gives us a way, with the integration of AI or use of AI technologies, we're able to simulate, to create simulation environments and be able to understand how best we can respond to incidents, yeah, and be able to start up contingency plans. So this is very important, and this is what AI is providing to us in terms of risk management. There could be many others, but that's what I could think about given the time. And then we talk about boosting cyber resilience. Cybersecurity in aviation has now become a very, very, very important and crucial part of aviation. It is because systems have evolved. That is the first thing. We used to have systems that are purely radio, but now systems are evolving. And systems evolving, they involve a lot of data, they involve a lot of networks. And with this, we need to also be able to provide ourselves with the necessary skills to be able to avert these cyber threats. So, like I said, it gives you a proactive cybersecurity strategies. Because we said this, we have already said that cyber threats are emerging and they're evolving. So we must adopt more proactive ways and strategies to encompass not only technology, but also process and policy enhancements. So from the research or from the implementation of AI, we would be able to come up with policies that are able to avert any cybersecurity threats, and thus being a lot more proactive in this case. And then integration of cyber defense, that is, and threat anomaly detection. Most SOCs that we know, that's security operation centers, or any SIEM that we use, most of them have integrated AI within their operations. So if you're looking at a SOC, a SIEM, you are able to note that most of these, either let it be the Meta framework or any framework that is being used in cybersecurity, is now using AI. And this is not something that can go unnoticed. So most of the SOCs, most of the machine learning models, and this is what they give us, because AI learns from data that has been received. The beauty about it is also able to detect weaknesses or zero-day attacks much faster, because we all know a zero-day, somebody has not thought about a weakness, or the software developer has not thought about it, and then an attacker pounces. So with machine learning and AI, we are able to detect these zero-day attacks much faster. So now we need to also now talk about employee training and awareness. We can use, first of all, AI to do this actually, but also most importantly, AI is employee awareness is very crucial in terms of cybersecurity. So we need to train all our staff to be vigilant and to be able to understand when something is not right, especially in terms of cybersecurity, when something is a threat, or when somebody is trying to do a phishing attack. So this employee awareness training is very important, and we can use it with the implementation of AI systems. So here are some of the challenges. There are so many challenges that have been spoken about, but as we know that these systems, much as they're providing a solution to us, they could also be a problem to us. And that is something to note. Because if you have an AI system, if you are using an AI system to solve a problem, another person is actually using the same system to attack you. So we need to understand how we are able to protect ourselves from these systems, and that's one of the challenges. And then we also have ethical concerns of AI surveillance, say for example in airports, because how do we use the data that we collect in airports? So we must have a way of securing this information. And then I'll go to the AI impact in aviation. So AI has greatly impacted or enhanced operational efficiency within airports because of first of all, it reduces the time, and it reduces the time to perform different activities, resource allocation, and then maintenance. Because we have data driven, we are making decisions based on data that we have available. And then it has also helped in adapting to emerging threats. Like we had said, AI can adjust to the emerging threats that we may face as we use AI within our environments. And then we also have a compliance with standards. This is also a very crucial part, that if you need your AI systems to be accepted, especially if, as we plan to invest as Africa, or this community here available, as we plan to invest in AI, we must make sure that we are developing systems that are globally accepted. So we have a number of bodies that have not tried, but are doing something to ensure that the systems we use in AI have the systems that we use in AI are actually meeting the required minimum specifications for any system. So we have a framework here. I don't know if it's very visible, but we must adopt, for organizations that plan to implement AI, we really must adopt a risk-driven approach. Yes, this is what guides most organizations. We must have a risk-driven approach to solving these problems. We will start with the base. Like I said, AI involves the use of computers. So the base will definitely be IT infrastructure. And yesterday, the president was talking about issues to do with moving into cloud. Yeah. So we must adapt to the beauty and the advantages that we get when we use these cloud infrastructure for our operations. Because before, we have been priding ourselves, one of the most security thing that we boast about as aviation professionals is we say our systems are not online. But now we are talking about things to do with cloud, yeah, and we're running aviation systems in the cloud. So we need to now adjust our mentality about this. Rather than just saying this is one of the most secure ways, we need to embrace this technology and be able to, and we need to embrace the technology and be able to adapt, yes, and implement this. Then we talk about the safety data building blocks. Before, the panel before was talking about data standardization. So here you must define your data. What kind of data am I inputting? You must talk about the data types. Yeah, what kind of data types am I looking at? You're talking about what kind of structure of data are we looking at? So this is very critical in being able to have a system that gives you information that you can value. Yeah, because if I give you garbage, I would expect to get out garbage. So this, at this level, is where we need to ensure that we standardize the data that we are feeding into our AI systems. And then the next stage is the enterprise safety services, anomaly detection. Once we have this data, and then we have this risk identification or dashboard, then we are able to now identify, as long as we have our indicators of compromise. Because if you're using an AI system, you must make sure that you know when to tell that this is a problem. And you must feed the system with your indicators of compromise to be able to know that this is a problem or this is not. Otherwise, you won't be able, you must have a baseline. And then on top, that's where we go to the risk-based decision making. Based on the data and how much information we have derived, then we can know how much risk is before us, and then we can make decisions. So this is simply a way of being able to come up and implement the use of AI within our environment. So we talk about another, that is AI trustworthiness. There's so many things that we can talk about. How safe is this system? Because then it is very critical in successful introduction into our aviation programs. So once we are sure that we can trust the system should be able to be transparent and easily explainable. It should be it should be safe, and it should be easily explainable. The results must be easily explainable. Oh, sorry. Oh, the present. Yeah. Okay, so that's where we were. Sorry about that. So we're talking about AI trustworthiness. There are a number of parameters that we'll look at. Its safety, the ethics that are involved, because we need to be able to find out that the system that we're integrating is actually giving us exactly what we expect it to give us. And this is where the trustworthiness comes in. So looking forward, we said, whereas AI offers advantages, human intervention remains very critical in the safety and in aviation safety and ATC. Yeah, and this is very important. So we are not going to lose jobs. We are very certain that our intervention is very, very critical in this. So this calls for us now. What we need to do is, this calls for a blend in technological integration with human capabilities. Yeah? Oh. I think I've been attacked by yeah, so, and then as we look forward again, as AI continues to evolve, regulatory frameworks will need to adapt to ensure safe and ethical deployment across aviation ecosystem. So this is what now would guide us to be able to ensure that we actually have safe systems in place and the use of AI within aviation. So we need to have that collaboration between aviation authorities, cybersecurity experts, and developers, because it is very essential in ensuring that we have successful integration of AI within our operations. And then I'll conclude by saying AI is definitely here, and we will have to adapt to it. That's the first thing. We will have to adopt, and it is transforming and enhancing safety protocols, strengthening risk, and at the same time improving our cyber resilience. So the goal of aviation, and I will state that as you see it in there, is to ensure that we have safety within our operations. So thank you very much, and I'll just end my presentation by just a very very short quote by Johnson Smith, who said that the difference between ordinary and extraordinary is just that little extra, and that is what AI is providing to us. Thank you very much.
Thank you so much, Joseph, for the very beautiful presentation. Let us give him again a round of applause. we all could see the passion he has towards AI. He was often using the beauty of AI, you see. AI has done a lot, and it's a problem solver for many, many, many issues. Actually, personally, I had a chance to visit China Express based on the issue of the risk management, what was presented by Joseph. They're using AI to predict the dangerous pilot. So they gather the information, the flight data information on how a particular pilot is handling that equipment during different phases of the flight. How they use, the way they handle the equipment during the landing and taking off, during the different weathers and so on, and how this pilot is behaving. You know, all those information are collected in the flight data recorder. So from there they can predict this pilot requires maybe strengthening in these areas, or we have to release this pilot because in most cases during the winter season or during the low visibility, they are not able to perform and so on. So there is a lot. Really, the AI is the beauty. I will call upon our different panelists whom we are going to discuss on the two papers presented. First, I would like to call Engineer Jacques Chimpanga. Engineer Jacques Chimpanga has more than 20 years of success as an ATSEP in different international organizations. He holds a diploma in electronics engineering from the University of Kinshasa. He also received training in management and maintenance of several aeronautical systems and equipment, aviation security and safety awareness. Engineer Chimpanga initiated, managed and successfully achieved many UN projects in Goma and Beni Mavivi airports, including the construction of air traffic control tower in Beni Mavivi airport, installation of VLS PAPI at Goma International Airport, and WGS 84 campaign with 8NS in 17 DRC airports. He was further involved in the maintenance of ATC towers in various locations in the DRC. Join me to welcome Engineer Chimpanga to the panel. Have a seat. We also have a second panelist, my fellow president from KPIs, Mr. Wilberforce KT Lalang. He is a senior ATSEP officer and current president and CEO of KPIs. He is an ICAO certified CNS, ANS inspector, ICAO aerodrome engineer. He is a registered professional engineering technologist with master's degree in computer science, BSc Electrical and Electronics Engineering, and HND Electrical and Electronic Engineering. He has a high degree of initiative and self-motivation and has over 3 decades experience in ATM, AIM, and currently as an ATM system security champion and a member of the ATM Infrastructure Security Committee. Join me to welcome Engineer Wilberforce. I was looking, I couldn't see you. Then I got frightened. Welcome, my dear panelist, the very experienced one. We are going to discuss on the two papers that have been presented by Nkululeko and also Mr. Joseph, but we will also get the views from our panelists, knowing that they are all the experienced professionals as for if you had properly the bios. So they are also going to share their experience on the topic. not by order of importance, but because he's also the president, I will start with you, Mr. Wilberforce. There are a lot of things that have been presented on the AI, and we cannot say that it is a new player because it is already there in our CNS ATM systems. And our users, specifically the air traffic controllers, they are also using it now. So what do you think the threats or dangers it poses towards the ATSEP and the systems? Because you know that we have to minimize these dangers when we are doing the transitions. So the risk during the implementation of AI and CNS ATM and cyber defenses have to be looked upon. What can you say that on the dangers it poses towards the ATSEP?
Good afternoon, everyone. Especially when two experienced presenters have given their output, you reach a point that sometimes you dare to think that what you are supposed to give is already been given, but not to that one. The dangers are actually quite, and when you look at it, is that AI is actually a double-edged sword. In that the AI itself, when you use it properly, it gives us efficiency, and actually in aviation field, it will actually improve on so many other things that we have been not actually obtaining or performing as we intend to. So first of all is that cyber criminals actually use it, and they have been not be having the speed at which they work, but because of AI, they're actually perfecting their work, because when they do their work and program their codes, the speed at which AI actually implements it's quite high. So we need to look at how do we remedy the issue of cyber criminals attacking our systems, and especially now when we are putting our systems into the internet. What are some of the things that we need to remedy? So, and the second one is that the importance of because I said it is a double-edged sword. When you say double-edged sword, it's a positive. It gives us a positive in which that, at the same time, when the cyber criminals are actually perfecting on their work, it is also the other reverse. Is that the AI, we use it to correct these attacks, is the one that now we can use it more, and it help us to do it. For us to actually achieve this, is we need to look at how do we achieve that. We have in Kiswahili there is what we call kusikia na kuelewa. Sorry for those who don't understand it. It is, you can hear something but you can't understand. AI has come into the field that we have. I know all of us have heard of it, but do we understand it? Do we go deeper into it, understanding it? Because you find that majority of us, we just read on pamphlets and all those things, but we have not gone deeper into understanding the understanding of it. What is this AI? Have we actually done some deeper understanding of this thing? In Africa, the perspective to me I'm getting is that we have the technologies across, but we have not taken one step of that, of taking ourselves one step ahead to advance on it, read. Because for me to be qualified, you must have done something. Somebody has to give you a certificate of what you have done. Somebody else has to query and ask you some questions so that you can. So we need to now register ourselves and do courses that can help us to remedy what the cyber criminals are actually using AI for. So to my perspective, I think we need to look at how do we train ourselves? How do we acquire the skills and the knowledge? Because when we hear about this, we come here, we've heard about this thing, we've not taken the next step of how do I know and engage with this cybercrime. We have courses that help us to actually try to understand how it works, because when you continue reading about AI, is that it is a fusion of so many codes. So unless you understand one of them, you will not actually have the expertise on the other side. So to my perspective, I think we need to look down and say, how do I train myself? And how do I go in to get the knowledge? But what is blocking us actually is the attitude that we have. We have an attitude that somebody else will work on that. Somebody else has gone to school and he has gotten something, let him continue. We will be referring to him. But you know, knowledge is always changing. If the other person does other things and moves away from where it is, where will you be as an accept, as an individual accept to be put there? Because AI, we have said, it cuts across all sections. Whether you are doing CNS, you are doing, surveillance, you are doing navigation, you're doing communication, it is cutting across. So my take is we need to do some trainings. There are trainings that are given by various institutions. Some are even free. You are given, you do it, and then you can now use that online certificate to go to an institution that you can now advance on that, and then you do some of those things. So I think, in my perspective, we need to train ourselves. Thank you.
Thank you, Wilberforce. That is really a danger and a threat, because as it has been noted even in the previous papers, everybody is telling we have to train, and we should not stop. Thank you. To you, Engineer Jacks, there are some challenges that has been presented in the first paper and also in the second paper of Joseph. So what is your input if there are some additional mitigation strategies that you think they can be implemented in order to maintain system integrity and flight safety?
Good afternoon, everyone, and those who are following us online. First of all, I welcome this opportunity to participate on this panel. Thank you, Regional Director and President Isaac. So before answering to your question, let's give a few words on the topic of our panel. AI in aviation, AI integration in CNS and ATEM system, and its impact on aviation safety and cybersecurity. The impact can be negative or positive from AI. Negative impact can have seen as challenges, while positive impact can be seen like benefits. So, to mention some benefits, positive impact, can say that AI can help us to have a failure detection and resolution. And secondly, AI can help us to have predictive maintenance. We have seen a lot of examples, and at the end of, we can say mention the last one, the decision support to accept. Some challenges, the challenge must be addressed to some levels, because we need to first to identify those challenges, and after assess them, try to find solution, implement those solutions, and later on monitor on the change of those that can bring those solutions. So 5 levels can get challenges. Is the first one is the political and regulatory. Second, the ISP, the business area. 3, the technical level, operational level, and at our level at SEP. So now, to reply to your questions, I think that is too early to evaluate the AI system, because first, we don't have products, not yet. I heard that Mr. From ACAM, he said that there is a system already in the market. Okay, it's fine. So you have a product on the market. So the second way, before evaluating this system, we need to use it in an environment. And they mentioned here, the environment is not ready. At the level of political area, and regulatory, they are not ready. They mention it. FIA is still making some papers. And the ISP, at the level of organization, when we acquire this equipment, at the level of ISP, what is from now is unclear, cost effective, unclear benefits from AI, implementing AI. Is the additional cost to the ISP. Are they ready to buy new equipment? They don't know what benefits will come from those equipment. So, at the level of IFATSEA, are you ready to go through an equipment? We are not full training on that. The manufacturer can say, technically my equipment is okay, it's fine, it's working. But in the environment, it can fail. Myself, the user, I can fail the equipment. That's why I think it's too early, it's very early to evaluate AI system for those reasons. So the first one, the product on the market. The second one, the environment is not ready. Before finishing my explanation, I want to give one example. I was in charge of area control center, Kinshasa Area Control Center. So we installed the VCCS. And during the day, the VCCS was failing. We wrote to the manufacturer. It was the best one in the world. Everywhere they use the same VCCS. The manufacturer asked me, according to you, what is the problem? I said that I don't know, but I monitor that there is, in the night, the equipment is working very well. But during the day, in certain hours, between 10 and 11 and 2 p.m., the equipment is failing. I think maybe it's the temperature, hot temperature. So the expert of the equipment came in Kinshasa. He said that we analyzed the log that you send. You may be right. It's the environment of the equipment which is not good. The equipment itself is okay, it's fine. So we solved the problem, with the environment, not this equipment. You see that we cannot evaluate or judge the AI system before using it and before preparing the environment to receive it.
Thank you. That is a different view of the AI, which is also very critical on the environment of our operations, especially us in Africa. Thank you, Engineer. Guleko, are you online? Yes.
Yes, I am online.
From your presentation, which was an eye-opener, because now we could see that the world is doing a lot of work. The FAA, the EASA, and also ICAO has proposed some a roadmap where we can start. So what can you tell us as a takeaway? Because here we are, more of us are at CEP, and we have different presidents of our associations back at home. What can you tell us so that we can advise our bosses on the regulatory strategies that are going to ensure safe and effective integration of AI in CNS ATM system while we are maintaining our operational performance standards?
Thank you, Commissioner, for that great question. Yeah, I think the starting point when it comes to AI integration into our organization, first, we need to understand our position where we are as an organization when it comes to AI implementation. So the proposal will be you develop the AI position paper for the organization so that it understands itself where it is. And you use that paper to advocate for AI and ensure that the working paper is actually complementing the standards that are being developed. As example have been made with EASA Roadmap 2.0, EuroKED 324, FAA Roadmap, and there's another one from UN, although it's high level, which is ISO IEC AWITS 25223. You incorporate all those guidance material to actually boost up your submission. And you can also refer to the used cases that already exist. Things like your time-based separation, your runway incursion warning systems, safety event predictive metrics tools. Those are things that have been actually trialed and actually, those cases have been analyzed. And they were analyzed for the sake of addressing the issue of the AI trustworthiness. And that can boost the position paper when you submit to your leaders, because that actually can determine that this is where the world is and this is where we are as an organization. And in order for us to get there, we need to understand where we are and how can we bridge that gap between where the world is and where we are in terms of AI. I think for me, that will be the starting point. Yes.
Thank you, Nkululeko. So it's basically we have to conduct the gap analysis of where we are and then study on the available proposed frameworks and roadmaps, and then write a paper and advise our seniors on that. Thank you, Nkululeko. Back to you, Joseph. Today when you are doing the presentation, I recalled upon the issues of the SMS, the safety management system. And I was trying to think, now with the AI coming, we have the SMS in place. I was trying to see how we are going to, again, another thing of integrating the systems inside the system. Anyway, we have seen the benefits of AI in cyber defense and its challenges. AI, we say it's an imaging. Cybersecurity has also been there. So these are the things that are now moving concurrently in ICAO. And they're the paramount tools, because when you speak about the aviation safety, I've seen you have proposed a framework from your presentation, and I understand the council has got also a framework that is guiding on the cybersecurity management. So what can you propose the risk management and mitigation that we can adapt when we are doing the AI integration into the CNS ATM system?
Thank you. Thank you very much. Thank you very much for that question. We have frameworks in place. First of all, I think if I got the question right, it was about risk. Yes, so we have frameworks in place that are able to assess the risk or the imminent risk that is provided by the use of any AI system within our operations. So, for example, then there's a NIST framework. Yeah, there's a NIST framework that analyzes the implementation of AI systems. It analyzes any AI system to be able to, of course, it checks a number of parameters. It follows the map and the map and governance also as well. So these frameworks are there to help us or guide us on how to implement or include AI operations within, AI systems within our operations. So with the adoption of these frameworks, they're not the solution, but they're just a guide. So because the beauty about, or the reason we use frameworks is that it helps you have checks and balances. You will not miss out on a thing if you have a guiding document. So this is why we have these frameworks in place. IASA as well is, it has a roadmap for the use of AI, and it focuses a lot more on the ethical part of using AI within our implementation. So these frameworks are really available and we should use them. And another question comes in that for us in Africa, I could say, we're mostly consumers of technology. So how does this use of AI really affect us? It's a big question actually, because we're consumers of technology. We have no technology that we develop. It's a question we need to think about. How do we now position ourselves, since we're consuming this technology? How do we position ourselves to be able to understand exactly what is happening with the new changes that are coming in? I think that is a food for thought for all of us. Thank you very much.
Thank you, Engineer, for the food for thought. You know, I am proud and I was very happy to see the comms that has been developed in-house. So I am sure there is a lot of work and the benchmarking we have to do on how you are going to do this kind of integration and how you are going to convince the regulator to change some of the things. Without further ado, I know that there might be some people with the burning questions from the audience. Maybe I could return back the mic so that if there is any question to our panelist.
Questions? Either the topic was very heavy, or you are still internalizing with the low RAM. Thank you. There's a question here.
Yeah, thank you so much. I'm Matov David from Uganda CAA, Air Navigation Services. SMS department. My question is about as we at least we are now aware of what is going on in the rest of the world. I just want to, maybe I missed something. What is the role of the regulator in all this, and is the regulator already on board, or we shall go ahead and the regulator will find us? I don't know.
RD, you want to answer on that, or you have a question on top of it? Okay.
Thank you very much. I guess as the protocol, I must introduce myself. My name is Sam from IFATSEA. Yeah, I think the question that has been posed by David is very pertinent, and I think I've been following the discussion from the morning. I think as we answer that question, maybe we may want to expand a bit that in some of this discussion that we are having, there's a sense that the regulator is standing somewhere and say, do whatever you want to do, then we'll come back later and provide an oversight. Which to me, it's a huge gap that we need to look into. That how do we ensure that we walk the journey together so that we don't go and be innovative about certain things only to be called to order, so to speak, by the regulator. So that because it does appear a lot of times that you'll find that the regulator is in the room, but we're talking as if the regulator is not even here. Only later on, then the issue appears like as if no, regulator seem to be hindering the introduction of technology or innovation, because the elephant in the room, or the burning question that we cannot avoid, innovation and regulation. Already there, you've got a challenge that you need to confront. Because the regulations, when they look at issue of innovation, safety is paramount. Do whatever you want to do, but it shouldn't be detrimental to be it the profession or whatever that we have in place. So as we respond to this, maybe we may want to expand a bit as to, and to David's point, where is the regulator in all of this? Thank you.
Thank you. We'll take 3 questions, then the panelist will answer. You can continue after.
Me, I might actually ask a childish question, but don't blame me. Sometime back, I think it was 30 years ago, I was sent on a course in Florida of artificial intelligence. And when we reached there, they introduced 2 languages, Prolog and Lisp. So we studied a bit. But most of the time you are supposed to go to the library and read for yourself. But to prove that you had read, you would have to write, he gave us an assignment to write a program in any of the languages of how to control people playing baseball. So anyway, we wrote the programs, but he had given a rule. When you bring your program, those days, you know, there were diskettes, what. You have to write a user manual and then come with a disk. I will load it in my PC, I run it, then I try to destroy it. If I succeed, you have failed. No other way, once you succeed, you have. Anyway, I didn't fail, but my question certainly is that now when you are going to teach people AI, because all these guys have to learn AI somehow, are you going to go back to those basics of these other languages of long ago, Lisp, and or are you going to learn from some other bigger, modern things, which might lead you where you don't want and might kill your own initiative? So that's what I need to understand.
My name is Avleno Tenan, Angolan delegate. So, I want to greet everybody here in Portuguese, our language. Boa tarde a todos. Boa tarde. In Shakespeare languages is good afternoon, everybody. In French is bonsoir. Is indeed? Okay, bon après-midi. Merci. So, man is undoubtedly the greatest machine created by God. So, in this case, face this time we are talking here about AI. My question is, first of all, is despite advances in AI, that have been proven that AI is a result of existence of the man, and not the other ways around. Therefore, the question is, what arguments or ways can be used to contain this phenomenon, which has gradually replacing the human activities in aviation sector and the overall sector? What we can do? This is my question. Thank you very much for paying attention.
Thank you for your question, but maybe before you hand over the mic, let me just try to rephrase. You're asking what argument can be used to encounter AI that replaces a human in aviation. Thank you. One last question, then we'll give to the panelist, and then we'll hand over the mic for the next question.
Good afternoon, everyone. My name is Serime Sunkalo from Burkina. I would like to thank the presenters and our panelists. I have one question. I want to know, what role do you expect AI to play in aviation over the next 10 years? Thanks.
Thank you. Can I hand it over back to the panelists? We have 4 questions. The question number 1 being the role of regulator in AI. Anyone who is ready to answer? Nkululila, are you with us?
Yes,
I'm
I'm
sorry.
here. Thank you, Program Director. Maybe I can take that one and try and take the last one. When it comes to the role of the regulator in terms of AI, I believe that the assumption that we might have is that the regulator is sitting somewhere and waiting for things to unfold, and then they will come and provide guidance material. Colleagues, the reality is we are all faced with a new phenomenon, with a new era, including the regulator. The regulator, they are part of the people that are working through the development of the guidance material. Reason being that they have not come up with anything is because there are a lot of studies that are happening. I think we made an example of number of guidance material that have been done, including ICAO. You look at ICAO before they can actually come up with a new annexure or come up with a new guidance material or recommended practices. there will be a lot of work that will happen behind the scenes that will guide the decision that they'll make in order for them to come up to a conclusion to say this is actually what is going to guide us as an aviation community. So in my presentation, I did highlight a number of regulators. They might not be in our continent, but they are playing a role in there. But we need to also bear in mind that most of the time technology moves very fast, at a very fast pace, to a point that the regulator gets left behind. To be an example, we've done some analysis in our country where we had to look at the ICAO recommended practices that are adopted by our Civil Aviation Authority, and they become a regulation. And when you look at the technology that we're using, you'll see that those standard and recommended practices actually refer to all the technologies than the technology that you're currently using. And it becomes then our role as a users to then raise that with the regulator to say, technology has moved and this is where we are. What is recommended there is no longer being used. So how do we then close that gap? And then there are committees within each and every region that sits. One of them in South Africa, I think it's CARCOM, where then they will sit and look at those gaps, and then they will come up with new recommendation that will cover that is new technology. So this is a process, and I think we need to just understand that as much as they have not come forward in most cases, currently, it doesn't mean that they are sitting back. I know that even our regulators, they are participating in a lot of work groups, number of them cybersecurity work group, the AI work groups. And the reason for that is because they're trying to gather more information and more understanding of this new technology and be able to develop a standard that actually will withstand the time. So yeah, that is just a touch on that one. And then the next question was, what role do you expect AI over the next 10 years to play? That is a great question. I think AI is already playing a role in aviation. I'll give you an example. There are a number of initiatives that have been implemented globally that are just waiting for the regulations to be published, and then they can get implemented. One of them is the A350-1000, which is Airbus 350-1000, which is autonomous aircraft that is being underdeveloped. The reason is it has not actually participated in transporting us yet. It's just because they are waiting for this guidance. So you can see where the direction is going, and most of the innovators and the organizations already have the technology, just waiting for the guidance material and the regulation to be published. So the expectation thereof is that we expect human to have less load in terms of air traffic controllers, to reduce the load on the air traffic controllers. In terms of the repeated activities or repeatable activities that they have to do, those can be automated. We expect to have an airspace that is more flexible. Instead of having extended separations, you can have reduced separation. That means you can accommodate more traffic with a level up in terms of the safety implementation and the warnings and thereof, and the mitigation that can be put in place. So in future, it's the same. I always think this as when the calculator was introduced, and everyone was scared that we're going to stop thinking now. We cannot calculate using our heads. But actually what it does, it just makes the process faster. Instead of you sitting there putting a long equation trying to calculate the number that you can just press 2 buttons and you are able to get it within a few seconds. It shortened the time that it will take you to do some of the activities. And those are the expectations as you move forward. I hope I have covered those questions. Thanks, Program Director.
Thanks, Nkululeko. Thank you so much. I think you have covered. I can also add up on the role of the regulator. You know, when you check in the aviation industry, most of the time when the technology changes, the service providers are the ones who are kind of giving the directives to the regulator on how they can do the oversight, because their interest is on whatever new technology you're implementing, how do you ensure the safety? So this you have to explain to them, and they have to be convinced. With time, as Nkuleko has said, the guidance materials are coming from the ICAO, which are, you know, going to tell them this is what you should follow, this is what you should adapt and everything. Then that one is included. You told me you are coming from the SMS side. You know that SMS was implemented first before the SSP in most of the countries. So we are the ones who should advise the regulator most of the time. So the countries, I would say, they will adapt depending on what the service providers technology they have. We have another 2 questions that are yet to be answered. Another one is on the machine learning languages, the curriculums. What are we going to teach our ATSEPs? Are we going to start from those days, or we are going to focus on where we are now? And but there are dangers that have been touched upon. Anybody from the panel? Yes, Karibu Joseph.
Thank you very much for those questions. Maybe to also re-echo something, especially to do with the involvement of the regulator. In this case, the regulator's role is to, first of all, ensure that any implementation is safe for aviation. That is the first. But also, we need to come up with regulations, because otherwise we wouldn't be, what will we regulate against? So we must have the regulations. And the regulators must also be equipped with this knowledge. So much as we are also, the technical people are ensuring that they are moving forward, we need to invite the regulators as well to be equipped with this knowledge as well. So that they are not left behind, and they know how to assess the regulations that are in place. And secondly, if we are using AI, majorly because most of this AI implementation is possibly outside the actual operations of these systems. So you're looking at the use of AI just to be able, say, for example, to carry out predictive maintenance. Yeah? So that is part of safety, yes, but we're using it to analyze the data. So if I pick data from a system for purposes of analysis, I think that is fine, because we're trying to learn something from that data. So that is really okay. So the regulators in this case must be able to now also be abreast with the technology that has come before us. And this is also another challenge that the regulators have. So in regard to the issue of the required training, yeah, there's so many frameworks, there's so many programming languages. Everyone picks something of interest, but you need to know how to pick what is right. You may not know that as an individual, but that is why we have events like these. You can pick some information from events like this. We encourage, and one of the most important things about such conferences, or what ICAO recommends, is international collaboration, or any collaboration between staff or between countries. Yeah, you will not fail to get information that can guide you to achieve a certain goal. Because as an individual sitting down, it might take you a much longer time. But if you have a discussion with Tanzania regarding what do I require, or there are universities that are available to guide professionals on what they would need. And also we need to encourage people now to pick interest, because most times people may not be interested in learning something, but we need to pick interest as individuals now that this has come before us, and we need to pick interest to be able to learn, because right now this industry is not looking for people who are, say, very professional at something, or they're good at programming, or they're good at this. No, the industry right now is evolving, because before, and the times when we used to use hose for digging, it used to take a much longer time. Then there came mechanization. Yeah, so we are now, you're now diverting your energy to doing something else. So because of the evolvement or the advancement in technology, we are now having to reassign ourselves or our resources to now more pressing needs. So we are asking ourselves that we need to have people who are critical thinkers, because this is what you need to give your AI system. Yeah, so we need to have such people to be able to understand exactly what you need to be able to be trained in. You can have that collaboration. Yeah, get the collaboration, find a colleague, have a discussion. Okay, my path is this, what do I need to learn? Yeah, so this information can be availed to you by another professional, because these consultations will help you if there's no sense of direction, or there's nothing that has been put forward for you to be able to learn something. So I think that would be of so much help for us to be able to understand exactly where we want to be and what we need to learn in this case. Thank you very much.
Thank you. You're welcome, Engineer Jax.
Yes, Angela. I want to add something to the question that the role of AI in the 10 future, the 10 years. So for me, I think AI must be the decision support to accept. Let me give you an example. So at Kinshasa, at the area control center, one night the power gone off. There was no power. So at that moment, there is no control of the airspace of DRC. I was in charge of the ACC, the area control center. Then everybody started calling, from the political level, transport, everybody. The regulator, there is no power. Okay. I picked the phone, he was my director, telling me that there is no power, what are we doing? So I said, no, I will fix the problem. I called the technician. The technician said that I run the generator, but there's still no power in the site. I go to the inverter, see if the inverter is working. He went there, the inverter was shut down. But the inverter has a processor. The processor can manage all the input power from the provider, or from the generator, or from the battery. But the problem, sometimes the system, the manufacturer can say that the system can work in that condition. But there is some issues concern that you can find only on the ground when you are using the equipment. At that moment, the inverter goes down and the manufacturer don't think about that. When the inverter goes down, nothing can work. I just say to the technician, push the button which is written bypass. When he bypassed the inverter, the power came back. We lose 23 minutes, no control of the airspace because of the generator of the power. You see, at that moment, if the AI was running, I have the algorithm. The technician can check the algorithm and ask the AI, no power, what can I do? The AI can suggest the solution to him. But what I'm saying to Richard give an example yesterday with EOS. But if the AI reply in English, but the technician don't know English, at that moment, more stress, and he cannot solve the problem. If the algorithm is written by me, African engineer, are written in my mother language, do this, he will do it quickly. You see this problem. So at the moment, the AI can tell him if the power supply is failing. It can tell him that in the store there is another power supply. You see, in the midnight, you need to take a decision. He's under pressure. You need to have clear decision. And AI can help him to guide him how to find the solution, the right one. And at the end of the day, is the technician will go to replace the damaged power supply. So the AI can be decision support and guide the technician or the engineer to repair, to fix failure.
Thank you, Engineer Jax. So the human is not going to be replaced. I hope your question is answered. I think the issue of time. Okay, we'll take 3 questions of those who cannot sleep tonight if they haven't asked their question. Then the rest of the question, I think, can be discussed outside with the panelists.
Madam President, how do I choose that one who can sleep tonight?
They have to raise their hands.
Thank you very much. Good afternoon. My name is Davis Udoku from Nayi, Nigeria. With the introduction of AI, it means that our systems will no longer be a closed system. And our systems will have to be connected to the internet. And because they'll be connected to the internet, how can we be assured that data that is being obtained by AI from the operations, from its operations within our systems in the airport, will not be sold by the OEM? Because right now, data trading is actually a big deal. We pay to acquire these systems, and at the end of the day, the OEM makes money from us by selling our data. That's one question that I have. How do we prevent that? Secondly, just like my brother in the middle said, I think Africa should begin to think about developing local AI solutions that can be used in our airports. As when you depend on foreign AI systems, stolen data can be taken advantage of to cause problems that will require only the OEM to solve. Are you understanding? So the AI will cause problems on behalf of the OEM, and at the end of the day, you will contact the OEM and he will say, okay, let him send a team to come and solve it, and then you have to pay him for it. You know, thereby milking our governments and our ENSPs of funds. Also, we need to remember, I share the carefulness of, I share the carefulness of my brother when he said that we need to be very careful in the deployment of AI. Remember Boeing 737 MAX 2020? Most of those aircrafts were actually stalling in the air. And I believe it's actually because of AI systems that were being deployed in those aircrafts. And the pilots could not actually control the aircrafts because the AI took over, stalled the aircrafts, and then caused crashes. So we need to be careful. How do we prevent these? Thank you very much.
Good afternoon, House. My name is Ibrahim Yusuf Oyo, Nayi, Nigeria. Mine is more of a suggestion. As the IFATSEA Africa region is now creating awareness concerning the AI in relation to aviation sector. I am suggesting that the IFATSEA Africa region should create a Vedic of AI by maybe conducting a workshop, maybe quarterly, to its members so as to boost their confidence and create a basic for them to at least individually or by the respective SPs to build from that stage. So as such, members will use that to explore more of the AI solutions and thereby mitigating the risks associated to that. Like my colleague here said, maybe some companies will use that opportunity to store data and some other information. But if we are well equipped and most of our members are aware and can create some certain things by themselves, we will be able to protect our data. As such, those companies can never steal our data. Thank you very much.
Which one? Richard.
Yes, thank you. Greetings, everyone. Mine is just an observation that there seems to be an understanding that the deployment of AI is synonymous with connection to the internet. It's not necessarily true, and I think we need to strike a distinction. Luckily today, you have some open source models. So there are two schools of thought. Of course, like any other advancements, you have the proprietary models that are mostly marketed by the companies that we know, OpenAI and Meta from Facebook, and then the Gemini models from Google. But on the flip side, there are some open source models. And the whole idea is you have a model that you can work with offline. You don't have to necessarily link into the internet resources. So it's not true that the deployment of AI is synonymous with a connection to the internet. So, and I think for me, personally, I think in a way of managing risks, the first approach for us would be to try and exploit the open source models, the ones that we can deploy within our closed environments, and then, because otherwise the risks, the attack surface becomes immense. And so it's not true that the deployment of AI is synonymous with the hooking systems onto the internet. There are other alternatives, but of course, like the previous members stated, it takes some curiosity to see what are the capabilities of these models. The key example is DeepSeek. If you've been following, the Chinese were able to produce an open source model whose performance was almost at par with the proprietary models. So an open source model is something that is explainable. You can see the parameters, you can even study the algorithm, and you can audit the algorithm. So I think aviation will likely start with the local open source models and then eventually, yes, thank you.
Thank you for clarification and suggestion. I think minute of the floor. I am told people are extremely hungry and we have to break for lunch. But before going, we will respond on the two questions. The first one being on how we can ensure the data obtained from AI cannot be manipulated. It is explained that it's not necessarily that it's in the internet, but I think we can have an answer on this, because AI it works with a lot of data that is collected from different systems. Anyone who can respond to this? How can we ensure that the data that are collected from the AI are not manipulated?
Okay, I think, thank you for clarifying that the data can be stored in your own servers, not necessarily connected to the internet. And when you look at it, is that most of our equipments are actually not online. Basically, like one of the system only that is currently being connected online, that is the AIM system. The others are online, not online. So when we procure an equipment, we should understand and give the specifications to make sure that all what we need is within ourselves. And if in case you want to allow the EOM to have more of access, is that we need to have an agreement with them, so that in case they want to use our data, we have to give a go-ahead. So those are confidential, we call it confidentiality, and that one can actually still protect what we have as organizations. The other thing that I was looking at is that apart from having them within ourselves, is that previously we had talked about how do we understand this, and when we have more knowledge on these systems, we can have more, because this knowledge is always evolving, and as we continue, we tend to understand actually what is happening with AI and cybersecurity. A good example for us is in Kenya is that the organization decided that because of the introduction of new technologies coming in, we started a program training not only ATSEPs, but also operators on the basics of cybersecurity. And when you do that, you put each one of them in focus to understand and know if this thing is, if I get a message that give me this, with that knowledge that you have already, you can know that this is not supposed, I should not act on such a message, or something happens, you don't have to action it yourself, but you can get some advice from the other section. So when we do that one now, you'll find that we'll have more knowledge on how to back our systems and make sure that our data is safe with us, and at the same time we are advancing in all these things. So I think that is partly what I think we should look at.
Thank you, Engineer. Any other input from the panelists? The last input. We want to close our session.
Yeah, thank you very much. Maybe to also add on that, just like Richard said, that most of our systems, it doesn't mean that the systems are actually running online. But also in the event that you actually, because most times developers might use APIs that are connected to the internet. So you must have measures in place to ensure that your systems are actually safe for those systems that are connected to the internet. And then for the suppliers, just as I said, it's mostly what we definitely call supply chain risk management. So you need to have measures in place with the supplier to ensure that your data is actually not going to be used for anything that you don't authorize them to use it for. So that is very crucial, especially in the agreements that you have with the suppliers as they give you these systems. Of course, those agreements must, because for them, if you have those agreements in place, it's a way of protecting your data that you have within your system. So I think that would be all I could say. And then maybe also for the AI systems, I think somebody was talking about an issue to do with getting different results or something like that. So you need, of course, whatever you have to define your inputs, and that is what we talked about, data standardization. Because if you're to get out information that is relevant to your research, then you must have to input clear and standardized data. I think that's what I can say for now. Thank you.
Thank you, Engineer Joseph. Nkululeko, do you have anything before we wind up?
Not standing in front of people's lunch, I'll try and be short. Yeah, this is a critical point. I think it's something that you shouldn't really brush it off. I'm saying that because currently we have this assumption that the OEM don't have access to your systems. And the reality is, in most of the systems they do, although we think that our network is closed, you will know that when you have if you're using Top Sky, let's say Top Sky is down, and then they log in remotely and actually assist you to restore, then you realize that actually that data, they do have access to it. The question is, what policies do you have in place and agreements with those service providers not to use that data, because it can come in a positive, it can actually assist you in a positive way for them to have that access, can also be used in a negative way. So that is one of the issues. The other thing that we need to think about is the use of cloud. If you look at most of our data links, as we migrate to IP-based systems or voice-over IP-based systems in some of them, you realize that we will be starting to use the cloud technologies, which can be either online or offline, depending on the packages that you choose. But that tells you that someone else will have access to your data. The question is, what measures do we have in place then to ensure that that data is not misused? Especially if you're going to utilize AI, how do you ensure the integrity of that data, that is not manipulated somehow and actually end up having the results that are not intended for the purpose? So I think it's something that we can take as a takeaway here and think about it, and thanks to the engineer that actually raised this issue. And that is my last program director.
Thank you so much, Nkululeko. Most of us will see you in Cape Town. I would like to thank my panelists, very experienced and knowledgeable on the subjects of AI, cybersecurity, and risk management. The takeaway from our paper, it's like we should not stop to learn. Let us train ourselves, not to wait on the ANSPs or our big bosses to send us to school, but on the issues of AI, there are many open sources trainings which are free of charge. So we have to learn and be aware. The second, also, we have to agree or to deliberate on a framework or a roadmap that we are going to use when we are integrating the AI in our CNS systems. The encouragement which has come is that we have to have a system that is our own, because the main aim of AI is to help us to perform our works better, to make informed decisions based on the data. The other one is on the issue of the risk management, to include the issues of cybersecurity into our risk management, what we are performing in our organizations. Having said that, thank you so much for listening to us. Thank you so much, my dear panelists, and bon appetit. Thank you.
Thank you so much. Beautiful. A round of hand clap. You know, Madame Angela is the only president, female president in IFATSEA. I had to stay in a corner until she was ready to bequeath. It is lunchtime, and it is ready. Lunch has been ready for you, it has been waiting for you, and you are refusing. I'm going to force you to go for lunch. But before I do, allow me to recognize amongst us, we have Manager Safety Management Systems, Uganda Civil Aviation Authority, Mr. David Matovu. Then we also have another manager, Manager IT, Information Technology. I don't know if he picked the day or it was just other things, but we have Dr. James Mubiru, Manager Information Technology, is among. This one is special. He's a Manager Engineering, Kenya Civil Aviation Authority, Mr. Eric Mary. Yesterday was an ATSEP, but today is a manager. So bear with me. Please go for lunch. Please go for lunch. I can't stand in your way. Thank you. While you walk out, they are going to give you a coupon. Just like yesterday, same place, enjoy. It is sumptuous, it's different. It's Ugandan. Yeah, thank you.
flight, navigational aids ensure safety by transmitting signals into the air and providing the information the aircraft needs from the moment it takes off to the moment it lands. Types of navigational aids include the instrument landing system, which consists of the glide path that provides information on the landing glide path of 3 degrees, and a localizer that guides the aircraft to the center of line of the runway. The VOR, which provides the azimuth, which provides positioning information for military aircraft. In the past, these navigational aids were operated by personnel who used measuring devices on the ground or on a rooftop to check transmitted signals. The range of the signals to be measured did not reach to the air by this method. In order to overcome the limitations of ground-based checking, since 2016, Korea Airports Corporation has been developing the drone-based glide path checking system called While a plane is in flight, navigational aids ensure safety by transmitting signals into the air and providing the information the aircraft needs from the moment it takes off to the moment it lands. Types of navigational aids include the instrument landing system, which consists of the glide path that provides information on the landing glide path of 3 degrees, and a localizer that guides the aircraft to the center of line of the runway. The VOR, which provides the azimuth, which provides positioning information for military aircraft. In the past, these navigational aids were operated by personnel who used measuring devices on the ground or on a rooftop to check transmitted signals. The range of the signals to be measured did not reach to the air by this method. In order to overcome the limitations of ground-based checking, since 2016, Korea Airports Corporation has been developing the drone-based glide path checking system called DIVA. The core technology of DIVA lies on the signal measurement systems for navigational aids and its portability that easily equipped on a drone. These compact, ultra-lightweight measurement systems can be mounted on any drone and can check and analyze information from the localizer, glide path, VOR, and TACAN. KAC has registered 4 patents for this technology and received CE certification for its signal measurement systems. These signal measurement systems collect and analyze navigational aid signals while in the air and transmits the data to monitors on the ground. Drone-based checks allow for faster checking than ground-based systems by eliminating the efforts to move and relocate to multiple checking stations. It is also available to receive 3-dimensional in-air transmission data, which leads to more precise and meticulous check. The drone check can be done as a way of pre-inspection and prevents the additional flight inspection by the government that is time and money consuming. The DIVA system receives RF signals in the air using the navigational aid antenna. Then, the signal measurement systems analyze the signals and convert them into data, and the measurement data is transmitted to the ground. Next, the measurement data is sent to analysis terminals via a ground station. The analysis terminals can use proprietary software to analyze measurement data signals in real time. The first step for creating a flight path for navigational aid checks using a drone is inputting data from sources such as flight information publications. The path-generating program is used to make drone flight course as KML file, and Google Maps check for any errors. Finally, the automatic flight path for the drone is uploaded and reviewed. There are a total of 4 flight paths, depending on the navigational aid. The first is the process for checking the localizer, called the approach level run orbit check, which inspects whether the signals for the structure and course of the approach slope provided by the localizer are normal. The second is the orbit check, which checks whether the transmission signal for the clearance of the localizer is normal within a range of 35 degrees, left and right. The third is the approach level run flight method, which checks whether the course and clearance of the glide path's approach slope are normal. Next, in-air transmission signals from the VHF omnidirectional radio range and the tactical air navigation system are analyzed by drones, performing remote flight around the 2 devices. Korea's DIVA system can also simultaneously check 2 flight facility systems, allowing for faster and easier inspections. These drone flights can be used to check items such as the structure, course width, symmetry, modulation, alignment, identification, and RF level on course. For a straight line localizer flight, DDM 0 microampere can be measured on course, and the structure can be used to check alignment and centerline true bearing. When checking the localizer, the width point of the transmission signal can be checked from a specific point midair. This point shows the width point of the localizer and has a DDM value of 150 microampere. When checking glide path level run, the width point of the transmission signal can be checked from a particular point midair. This point shows the width point of the localizer and has a DDM value of 150 microampere. When checking the glide path approach, the DDM 0 microampere on course can be measured, and the safety of the path structure can be inspected. After the flight has been concluded, a report is automatically generated and the check is completed. The localizer result report provides the analyzed values of transmission signal checks, average of the modulation, the minimum, the maximum, and power. The report also shows the modulation degree of the ID signal, the code course, the frequency of the clearance signal, and information on the precision of the drone flight. In addition, graph values and the capture point are also analyzed and displayed. The localizer clearance check report shows the modulation of the localizer signal at each angle, as well as the power values and the analysis values for the signals in general. This report also shows analyzed data on the course, the frequency of the clearance signal, and information on the precision of drone flight, along with graph values and the capture points for each category. The glide path result report displays the characteristic value and modulation of transmissions, the measurement values for power, the frequency, and information on the precision of drone flight, along with graphs of the measurement values. The VOR result report allows users to check transmitted values such as the while a plane is in flight. Navigational aids ensure safety by transmitting signals into the air and providing the information the aircraft needs from the moment it takes off to the moment it lands. Types of navigational aids include the instrument landing system, which consists of the glide path that provides information on the landing glide path of 3 degrees, and the localizer that guides the aircraft to the center of line of the runway. The VOR, which provides the azimuth, which provides positioning information for military aircraft. In the past, these navigational aids were operated by personnel who used measuring devices on the ground or on a rooftop to check transmitted signals. The range of the signals to be measured did not reach to the air by this method. In order to overcome the limitations of ground-based checking, since 2016, Korea Airports Corporation has been developing the drone-based glide path checking system called DIVA. The core technology of DIVA lies on the signal measurement systems for navigational aids and its portability that easily equipped on a drone. These compact, ultra-lightweight measurement systems can be mounted on any drone and can check and analyze information from the localizer, glide path, VOR, and TACAN. KAC has registered 4 patents for this technology and received CE certification for its signal measurement systems. These signal measurement systems collect and analyze navigational aid signals while in the air and transmits the data to monitors on the ground. Drone-based checks allow for faster checking than ground-based systems by eliminating the efforts to move and relocate to multiple checking stations. It is also available to receive 3-dimensional in-air transmission data, which leads to more precise and meticulous check. The drone check can be done as a way of pre-inspection and prevents the additional flight inspection by the government that is time and money consuming. The DIVA system receives RF signals in the air using the navigational aid antenna. Then, the signal measurement systems analyze the signals and convert them into data, and the measurement data is transmitted to the ground. Next, the measurement data is sent to analysis terminals via a ground station. the analysis terminals can use proprietary software to analyze measurement data signals in real time. The first step for creating a flight path for navigational aid checks using a drone is inputting data from sources such as flight information publications. The path generating program is used to make drone flight course as KML file, and Google Maps check for any errors. Finally, the automatic flight path for the drone is uploaded and reviewed. There are a total of 4 flight paths, depending on the navigational aid. The first is the process for checking the localizer, called the approach level run orbit check, which inspects whether the signals for the structure and course of the approach slope provided by the localizer are normal. The second is the orbit check, which checks whether the transmission signal for the clearance of the localizer is normal within a range of 35 degrees, left and right. The third is the approach level run flight method, which checks whether the course and clearance of the glide path's approach slope are normal. Next, in-air transmission signals from the VHF omnidirectional radio range and the tactical air navigation system are analyzed by drones, performing remote flight around the 2 devices. Korea's DIVA system can also simultaneously check 2 flight facility systems, allowing for faster and easier inspections. These drone flights can be used to check items such as the structure, course width, symmetry, modulation, alignment, identification, and RF level on course. For a straight line localizer flight, DDM 0 microampere can be measured on course, and the structure can be used to check alignment and centerline true bearing. When checking the localizer, the width point of the transmission signal can be checked from a specific point mid-air. This point shows the width point of the localizer and has a DDM value of 150 microampere. When checking glide path level run, the width point of the transmission signal can be checked from a particular point mid-air. This point shows the width point of the localizer and has a DDM value of 150 microampere. When checking the glide path approach, the DDM 0 microampere on course can be measured, and the safety of the path structure can be inspected. After the flight has been concluded, a report is automatically generated and the check is completed. The localizer result report provides the analyzed values of transmission signal checks, average of the modulation, the minimum, the maximum, and power. The report also shows the modulation degree of the ID signal, the code course, the frequency of the clearance signal, and information on the precision of the drone flight. In addition, graph values and the capture point are also analyzed and displayed. The localizer clearance check report shows the modulation of the localizer signal at each angle, as well as the power values and the analysis values for the signals in general. This report also shows analyzed data on the course, the frequency of the clearance signal, and information on the precision of drone flight, along with graph values and the capture points for each category. The glide path result report displays the characteristic value and modulation of transmissions, the measurement values for power, the frequency, and information on the precision of drone flight, along with graphs of the measurement values. The VOR result report allows users to check transmitted values such as the while a plane is in flight. Navigational aids ensure safety by transmitting signals into the air and providing the information the aircraft needs from the moment it takes off to the moment it lands. Types of navigational aids include the instrument landing system, which consists of the glide path that provides information on the landing glide path of 3 degrees, and a localizer that guides the aircraft to the center of line of the runway. The VOR, which provides the azimuth, which which provides positioning information for military aircraft. In the past, these navigational aids were operated by personnel who used measuring devices on the ground or on a rooftop to check transmitted signals. The range of the signals to be measured did not reach to the air by this method. In order to overcome the limitations of ground-based checking, since 2016, Korea Airports Corporation has been developing the drone-based glide path checking system called DIVA. The core technology of DIVA lies on the signal measurement systems for navigational aids and its portability that easily equipped on a drone. These compact, ultra-lightweight measurement systems can be mounted on any drone and can check and analyze information from the localizer, glide path, VOR, and TACAN. KAC has registered 4 patents for this technology and received CE certification for its signal measurement systems. These signal measurement systems collect and analyze navigational aid signals while in the air and transmits the data to monitors on the ground. Drone-based checks allow for faster checking than ground-based systems by eliminating the efforts to move and relocate to multiple checking stations. It is also available to receive 3-dimensional in-air transmission data, which leads to more precise and meticulous check. The drone check can be done as a way of pre-inspection and prevents the additional flight inspection by the government that is time and money consuming. The DIVA system receives RF signals in the air using the navigational aid antenna. Then, the signal measurement systems analyze the signals and convert them into data, and the measurement data is transmitted to the ground. Next, the measurement data is sent to analysis terminals via a ground station. The analysis terminals can use proprietary software to analyze measurement data signals in real time. The first step for creating a flight path for navigational aid checks using a drone is inputting data from sources such as flight information publications. The path generating program is used to make drone flight course as KML file and Google Maps check for any errors. Finally, the automatic flight path for the drone is uploaded and reviewed. There are a total of 4 flight paths, depending on the navigational aid. The first is the process for checking the localizer, called the approach level run orbit check, which inspects whether the signals for the structure and course of the approach slope provided by the localizer are normal. The second is the orbit check, which checks whether the transmission signal for the clearance of the localizer is normal within a range of 35 degrees left and right. The third is the approach level run flight method, which checks whether the course and clearance of the glide path's approach slope are normal. Next, in-air transmission signals from the VHF omnidirectional radio range and the tactical air navigation system are analyzed by drones, performing remote flight around the 2 devices. Korea's DIVA system can also simultaneously check 2 flight facility systems, allowing for faster and easier inspections. These drone flights can be used to check items such as the structure, course width, symmetry, modulation, alignment, identification, and RF level on course. For a straight line localizer flight, DDM 0 microampere can be measured on course, and the structure can be used to check alignment and centerline true bearing. When checking the localizer, the width point of the transmission signal can be checked from a specific point midair. This point shows the width point of the localizer and has a DDM value of 150 microampere. When checking glide path level run, the width point of the transmission signal can be checked from a particular point midair. This point shows the width point of the localizer and has a DDM value of 150 microampere. When checking the glide path approach, the DDM 0 microampere on course can be measured, and the safety of the path structure can be inspected. After the flight has been concluded, a report is automatically generated and the check is completed. The localizer result report provides the analyzed values of transmission signal checks, average of the modulation, the minimum, the maximum, and power. The report also shows the modulation degree of the ID signal, the code course, the frequency of the clearance signal, and information on the precision of the drone flight. In addition, graph values and the capture point are also analyzed and displayed. The localizer clearance check report shows the modulation of the localizer signal at each angle, as well as the power values and the analysis values for the signals in general. This report also shows analyzed data on the course, the frequency of the clearance signal, and information on the precision of drone flight, along with graph values and the capture points for each category. The glide path result report displays the characteristic value and modulation of transmissions, the measurement values for power, the frequency, and information on the precision of drone flight, along with graphs of the measurement values. The VOR result report allows users to check transmitted values such as the while a plane is in flight. Navigational aids ensure safety by transmitting signals into the air and providing the information the aircraft needs from the moment it takes off to the moment it lands. Types of navigational aids include the instrument landing system, which consists of the glide path that provides information on the landing glide path of 3 degrees, and the localizer that guides the aircraft to the center of line of the runway. The VOR, which provides the azimuth, which provides positioning information for military aircraft. In the past, these navigational aids were operated by personnel who used measuring devices on the ground or on a rooftop to check transmitted signals. The range of the signals to be measured did not reach to the air by this method. In order to overcome the limitations of ground-based checking, since 2016, Korea Airports Corporation has been developing the drone-based glide path checking system called DIVA. The core technology of DIVA lies on the signal measurement systems for navigational aids and its portability that easily equipped on a drone. These compact, ultra-lightweight measurement systems can be mounted on any drone and can check and analyze information from the localizer, glide path, VOR, and TACAN. KAC has registered 4 patents for this technology and received CE certification for its signal measurement systems. These signal measurement systems collect and analyze navigational aid signals while in the air and transmits the data to monitors on the ground. Drone-based checks allow for faster checking than ground-based systems by eliminating the efforts to move
Shall we please be seated and
to multiple check
for our final panel discussion? So before we call the panelists for the discussion, there's a short presentation which is going to be done by Mr. Daniel Shukurani Karungu. He's a registered professional technologist with over 2 decades of experience in aviation systems engineering. He holds a bachelor's of technology in electrical electronics engineering from Technical University of Kenya, and is certified specialist in airspace system inspection from FAA Academy. Daniel is instrumental in setting flight inspection standards, ensuring compliance with ICAO regulations, and overseeing the operational integrity of navigation and surveillance system. His career reflects a strong commitment to aviation safety, regulatory experience or excellence, and continuous technical advancement. Shall we invite Daniel Kasungu for the presentation. Thank you very much.
Okay. Good afternoon, everyone. As you've heard from Mr. Bless, my name is Daniel Shukrani Kazungu from Kenya. And I'm standing in for Dr. Salami. He was the one supposed to do this presentation, but he was taken ill and he lost his voice, so I have to give credit to Dr. Salami and cite that this is his work I'm presenting. It's not my personal work. So I'll try as much as possible to fit into his shoes and into his inspiration and his thinking. So you'll bear with me. Okay. First, I'll put you through the presentation outline. We're going to take you through context and definition, the future of flight inspection of navigational aids using drones, the challenges, and also recommendations. Moving. Okay. Okay. Let me go back. The pointer usually has a habit of trying to point you where you don't want. Yeah, AI. Okay, but eventually I think it's called machine learning. It's going to learn what I want. Yeah. Okay. What is flight inspection? Flight inspection refers to periodic evaluation of navigational aids used in aviation and flight procedures to ensure they are safe and accurate. Yeah. Flight validation comprises of reviewing flight procedures such as routes, approaches, and departures. Some of them entails things like STAR, that is a standard terminal arrival routes, and standard instrument departures. So all those standards, all those procedures have to be validated by flight inspection. Flight inspection is regulated by ICAO and contracting states regulation. Yeah, every state usually domesticates ICAO standards, and this thing is sensitive, yeah, very. So ICAO document 8071 is actually the one dedicated for flight inspection operation and procedures to ensure safety and accuracy of execution of the works. There's a Doc 8071 is a manual on testing of radio navigation aids. Yeah. So flight inspection has around, there are 4 types of flight inspection. The site proofing, where the flight inspection comes and certify if that site is appropriate for an AVID to be installed. Okay. Then after site proofing, there is commissioning. After the flight inspection has certified that this place is appropriate for installation of an AVID, then after the installation is complete, it's commissioned. And then there's periodic. Periodic is the flight inspection that is required by ICAO regulation to be done periodically after a certain interval. And then there's special. Special inspection is where you have a major breakdown, and after you restore the system back to operation, you have to do inspection to verify the integrity of the signal you're sending out. Current traditional flight inspection, we are using aircrafts, which entails you have an aircraft, you have a flight inspection system installed in the aircraft, and you have trained pilots to fly that aircraft, and also a trained flight inspector to interpret the data. And then you also have ATSEPs who are on the ground now, adjusting that equipment according to instruction of the flight inspector. And then, of course, the manual and procedures, that is Doc 8071, which actually dictates the kind of procedures you are going to do. So there are limitations to this current traditional flight inspection using aircraft. One is airspace disruption. During flight inspection, of course, you usually have to issue NOTAMs, and the maneuvers involved in this aircraft usually limits other aircraft from flying freely. So there are maneuvers which sometimes you cut across the runway. So that one disrupts actually and gives a lot of headache to the controller. Then high operational cost. Yeah. That is now maybe if a state doesn't have an aircraft, you have actually to contract an external person to come and do it for you, which is costly. And even buying that aircraft and mobilizing the personnel and all that is very costly. Then we have environmental impact because of carbon emissions, and its weather dependency, because during when it's heavy, raining heavily, the signal is sometimes affected. So you can't do a lot of adjustment on the system, and complex logistics in terms of mobilizing, getting permits, flying restricted areas and all that. It's time consuming. It involves a lot of people, and you have to have meetings and all that. Then calibration downtime. During calibration, that equipment cannot be used. Yeah, it cannot be used. So flight inspection system also is very expensive, and limited repeatability. This is where the aircraft flies a certain pull up, because the pilot is approaching, is below the minimum, and yet he has not the landing gear is still up. So you'll find that it's very dangerous, and mostly we have accidents and fatalities. So those are some of the limitations that goes with the flight inspection aircraft. So what do? we are trying to find a solution with drones. So we have to see if we can employ drones to do flight inspection. So with the drones, it entails the drone itself. Like you can see in the screen, there is a quadcopter. Then the quadcopter entails also flight inspection system and sensors. Then you have to have a drone pilot. You have to have an average flight inspector and the ATSEP also to assist in adjusting the equipment. And also it follows the same manual, Doc 8071 ICAO. So the benefits of drones is accuracy and precision. It's cost efficient compared to manned aircraft flight inspection. It doesn't emit carbon, so reduced environmental impact. Then there's high quality and real-time data collection, precise repeatable flights, because its flight path is short, and then reduced airspace disruption. In a non-segregated airspace, you don't need a lot of interruption with the other aircraft because you are flying below the flight level of the other aircrafts. Then there's a scalability and modularity. It's able to accommodate more data, and it's flexible in terms of the modules. You can change the module, hot swap batteries, things like that. And also it can be integrated with AI and machine learning and big data solutions, and also increase safety because there are no human being involved in flying with it. It's just the machine. So the crew is safe in a specific place. Challenges of drones. There are regulatory and certification issues. As you know, drones, there is an ICAO document 10019 on ARPAs, and not every country has adopted those ones, those standards, because the drones are not yet rolled out fully. Then weather and environmental conditions. The drone is usually affected by strong winds because it's a small aircraft, and also rain and precipitation. Flight path precision, and there is also signal fidelity. At the level where you are inspecting with the drones, the signal is not fully matured through space modulation. So you might find a little bit, there's a problem with the signal fidelity. Then there's data validation. It is required that when you inspect with a drone, then the calibration aircraft comes and verify and validate that data. Why? Because sometimes you might be testing at near field, but that signal in the far field maybe has some bends or dumps, which a drone will not detect at near field. So the flight calibration aircraft also must come and validate the data that has been collected by the drone. Then airport coordination. Of course, in a non-segregated airspace, you have to coordinate with the controller. The pilot have to know there's a drone around this side, so that's also a challenge. Then cybernetic risks, which involves the drone actually uses GNSS most of the time and GPS, and there's issues of spoofing, jamming, all that. Those are the risks involved. Maintenance and calibration. All the calibration aircrafts are required to calibrate their sensors and their systems. So with the drone, there's still not a clear procedure on how those sensors are calibrated. Okay. Then the skilled workforce required and training. Of course, when you have a drone, you must have a drone pilot, which will require training, and in some countries will require to be licensed. Yeah, not everybody should be taking a drone and flying it. Advanced technology. The technology is advancing very fast, as we were told in the morning. So the drone, you might find the drone is behind the technology. And electromagnetic interference is also, the sensors are subject to electromagnetic interference, which is a common thing in navigats. If you have some interference inducing component somewhere, maybe like wind turbines and all that. So, recommendations. Recommendations by Dr. Salami is creating an African work group. I think I'm informed there is a paper that has a working group, working paper that has been presented to the African countries. We are going to look at it later during the discussion. Creating a workflow in order to standardize the new inspection operation based on drones. Workflow presentation and validation. Organizing workshops and training session by IFATSEA Africa. Recommend workflow implementation to NSP. So this is something that it is recommended that we can adapt it and see how Africa can collaborate and acquire these drones to help in ground checks mostly, because ICAO still doesn't have has not accepted really drone inspection on a standalone basis. But it's good for, drone inspection is very good for correlation of data. It's more better than the ground inspection using a handheld walk-around PIR, yeah? And with that, I think we've come to the end of the presentation, and I'll leave it to Mr. Bless to continue moderating.
Thank you very much, Daniel, for the presentation. So basically what we are going to discuss this afternoon, we are talking about regional collaboration on drones for flight inspection. So let me just go to the panel and introduce the panelists, then we can start the conversation. Engineer Samuel Kojo Zomelo is a telecommunication engineer and seasoned aviation safety expert with over 2 decades of experience in civil aviation oversight, air navigation services, aeronautical telecommunication, ICAO USOP, CMA, SSP, NAPS, RPAS, and SMS implementation. As member of ANS Inspectorate at the Ghana Civil Aviation Authority, he leads the licensing, certification, and surveillance of ANS providers to ensure compliance with national regulation and ICAO SAPs. He is an ICAO certified instructor and auditor, and he contributes to ICAO, AFCAC, IFATSEA, and Bagasso working groups. With strong technical and policy expertise, he champions aviation safety across through innovation and strategic governance. In fact, Mr. Zomelo is my direct boss, and I thank him for honoring our invitation. Mr. Zomelo, thank you very much for joining us.
Thank you. Thank you, Blaise, for the kind words. I'm happy to be here.
Thank you. Next is Engineer
Hello.
Agaba.
Can you
Gerald.
hear me?
Yes, we can hear you. If you could just hold on for a brief moment so that I introduce the rest of the panel. Thank you. So Agaba Gerald is a principal air navigation service inspector, communication navigation surveillance at the Uganda CAA. He's a safety inspector and with over 17 years in the aviation industry. He started the aviation career in 2007 as a technical officer, CNS officer, in the Directorate of ANS and Air Navigation Service Provider, responsible for provision of air navigation services in Uganda. In 2012, he was assigned responsibilities as a safety inspector in regulatory entity in Uganda, where he attained experience in regulatory roles as a senior CNS inspector to the principal air navigation service inspector. He holds bachelor's in electrical engineering and a post-degree in project management, project planning and management, and holds master's degree in aeronautics. He has been instrumental in several national and regional initiatives, including but not limited to being ANS expert within AFCAC Technical Working Group, a member of the APEC IM subgroup, and project team lead in an APEC IMM project on aeronautical frequency management project, and was part of development of the ANS ITS as a representative of Kasua to Bagasso. Shall we welcome Gerald Agaba? Finally, Isaac Kamugu is a seasoned asset with 15 years experience in design, implementation, and maintenance in CNS systems, with a strong background in both technical operations and system innovation. Currently, serving as Principal Technical Officer, Research and Development at Uganda Civil Aviation Authority. In his role, Isaac leads initiatives that focus on innovation, applied research, and the development of technical solutions that address real-world challenges in aviation. His work bridges operational needs and emerging technologies, contributing to the modernization and sustainability of air navigation services. We round of applause. Shall we welcome Isaac Kamungu? So the call, I think earlier, there was a call on about inspectors, the regulators, their involvement in our work. And I'm happy to announce that here on the podium, we have one inspector, a regulator, the other joining us online. Then we have two in operation. I thought we were going to clap to that. So all what I'm trying to say is that we have two seasoned regulators for this particular discussion. Now, so we are talking about regional collaboration for drones, on drones for flight inspection. If you could just put the paper, the AFCAC paper on the screen. So there is a paper developed by AFCAC on the ground inspection, and this particular paper, they were put together or they were worked on by Gerald Agaba and Engineer Zomelo. They form part of the AFCAC working group, so they put all these things together. So AFCAC has come up with this particular working paper to be presented to ICAO. And when you look at the executive summary, the working paper proposes the integration of UAS for ground check for navigates as a supplementary method with the potential to extend periodicity of manned aircraft flight tests. This addresses challenges in maintaining timely navigates testing in developing states, which has led to significant safety concerns during the use of CMA audit. Developing SAPs for UAS-based checks offers a cost-effective reliability or reliable solutions that reduces operational costs, lowers CO2 emissions, and enhances overall aviation safety. Mr. Agaba, you know this paper very well. What really informed it?
Thank you, moderator. Exactly what we are discussing in this meeting. The concerns of flight inspection cannot be over-reiterated. We know as an African continent that flight calibration has become a thorn in the flesh, resulting into significant safety concerns. A significant safety concern is usually a concern that is put out on the public website of ICAO, indicating to the flying public that State X lacks the capacity to carry out some safety critical activities in the state. And one of them is the ensuring that the nav aids are operated in their original format or in the correct version of operation. So looking at the challenges that come up out of us having significant safety concerns is one, we have very few flight inspection companies that we can go out to look out for. Two, the cost is really very high. And three, the periodicity that is generally acceptable in the aviation industry through the DOC 8071 is, if I take two facilities, the ILS and the VOR, 6 monthly for the ILS and 1 yearly for the VOR. So you imagine going out there, probably in Europe, to source a service provider to come within your state to flight calibrate, how much it will cost just for requesting that service. Another issue is that we always carry out ground tests, and ground tests are, as was already discussed in the presentation, are done using portable receivers and many other test facilities, oscillators, frequency counters, etc. However, when you look at some of the requirements for you to carry out ground test, you need to go out a bit. Usually, sometimes the terrain within the environment of the aerodrome is not good, and driving through or having people going through may not give you the exact signal, that the exact parameters that you need. So we imagine that if, after knowing that drones are a part of us, and what are drones? Drones are usually, I don't like using the word drones because it underestimates what is the composition of that facility. It is a system that has various components. Leave alone the manned aircraft, whereby you walk into the aircraft and that is what you're flying. Here you have different components. You need your ground control station, you need the aircraft itself, you need the communication links, you need the control links, you need the launch and recovery facility. So you realize that it's a component of many things. And noting also that the air traffic management operational concept that we rely on in our operations of aviation was based on the concept of see and avoid. See and avoid means you must have a human in the loop. Now here we are having a concept of drones trying to retrofit it within the concept that was already initially designed for only see and avoid, and you're bringing in the concept of detect, sense, and avoid. It becomes a bit complex for the aviation industry to manage the inclusion of drones within the operations without changing the concept at the beginning. So what is happening is that we are trying to push ICAO through this working group, and the working group is consistent of many experts across the country, across the continent, both in all the expert areas. Me and Zomelo, we are privileged to be part of the team. We thought if we can push as an African unit, 54 states, we develop a paper and request the assembly to direct ICAO to include in the SAPs the use of drones, at least at the baseline for ground inspection, would be a very good building block to, at forthcoming sessions, to push for the use of drones for flight inspection. So ideally, the concept of this paper is to bring the block together, 54 states, and usually, you know, the concept at the assembly is about votes. So we know we have 54 votes. We are saying Africa, we are having a challenge in as regards to flight calibration, and we think if we can increase the use of drones for at least ground inspections, that will drive us to reduce the periodicity that I had already discussed, 6 monthly and 1 yearly. And as progressively we build the progress, as we progressively build the capacity of drones, we can also have them do the flight inspection. Thank you.
Yeah, thank you very much. Engineer Zomelo, what's your take on the paper?
Yes, thank you very much. How do you read?
5 by 5.
Thank you very much. This morning I've had some few challenges with internet, and but coming back to the paper, so as my colleague Gerard had explained, this paper is very timely, particularly considering the various challenges, the cost implication in acquiring these flight inspections. It's a major issue. When you take the use of results, on ANS, you would realize that, I'm sure my colleague had mentioned it, you would realize that calibration of navigation aids is a major issue that is leading a lot of the states into significant safety concerns in Africa. And so, as he rightly pointed out, how do we ensure that we are meeting or we are complying with the ICAO requirements, the standards? The Annex 10, Volume 1, Chapter 2 has it clearly that all these navigational aids must be tested, flight testing, and then ground checks. Now, so how do we make sure that we have these records so that we could provide evidence to any ICAO auditor during USOP that we are doing what we are doing? So it's a bigger issue, and this paper we think that is very timely. It should be supported by all African states in the upcoming ICAO assembly, so as to get that SAPs to support the use of drones or use of RPAS for complementing the flight checks. Is very critical, and it will go a longer way, reduce costs significantly, because it is clear in the ICAO Doc 8071 clearly stated that if we're able to correlate the results of ground checks with the results of flight check 4 consecutive times, you could now extend the periodicity of the flight checks. So it's a very timely paper, I must say. Thank you.
Thank you very much, Engineer Zomelo. Isaac, so you lead a team here in Uganda in terms of research and development. And I saw on the exhibition, isn't that at least you have exhibited use of drones for flight calibration and all those things. Is this something you have Is this something you have implemented already, or what really are you doing with regards to the drones for flight calibration? Thank you.
Thank you. So, when you look at Uganda, first of all, from the presentation Engineer Kato made yesterday, the one of the industrial revolutions, you must have noticed something if you were paying attention. All those developments, all the changes, I didn't see Africa anywhere. Okay? The first industrial revolution, the mechanization. When we talk about the steam engines, when we talk about electricity, the development of the computers, we were not anywhere. Okay? But we can't blame ourselves because we were not there. We are here now in the fourth industrial revolution, at the start of this fourth industrial revolution. So for us, we take it as a big opportunity. We no longer want to follow after everyone has done everything and then we just consume. We also want to be at the forefront to contribute to this development. Okay? So in Uganda, at Civil Aviation Authority, we've gone ahead, we've drawn a roadmap. We want to actively participate and contribute in this issue of calibration using drones. So our project, we've phased it. Why we've phased it? Because, as you know, with any research, there is a cost implication required, and we've taken a couple of steps. Okay, so on one front, we, when you look at the presentation that was made by Dr. Salami, one of the key components that you need there, one, you need to have drone pilots. Okay, so we've gone ahead, organized for training for our ATSEP to be the ones who are going to do this work, to do this study, to acquire drone pilot licenses. We are already in the process of acquiring the way we've structured it. We want to get the drone payload that we want to use to do the measurements in the field. We acquire that first and study it. Then the next step is, I think, this financial year that is beginning July, we plan to acquire the drone that we shall use. So by the end of this year that is started, we will have started to see some of the results. So yeah, so that is on the operational side. But of course, like you've explained, it's not just a matter of doing things. We have the regulator with us. We intend to work out what is the requirement, how, because we need to convince, we need to assure the regulator that if we use the drones, the results that we get are actually reliable. They reflect the truth, and once we acquire the data to prove that, then over time we can begin to talk about how to extend the validity of the certificate of the requirement for this regular calibration. Because also for us locally, I don't know how it is in your place, but calibration is one of those activities that we know we must do, but always it is a challenge to get done. It's every time we do it, it's like it's the first time we are doing it. Okay, so it's usually hard to get it done on time and arrange everything, looking at the schedules of the service providers and our own schedules. So yeah, so that's the Ugandan experience. That's where we are at the moment.
Thank you very much, Isaac. Before I come to Daniel, Engineer Zamelo, you were in Nigeria, I think, a few weeks ago on a drone exhibition. What was the experience like? If you kindly share.
Thank you very much. Yes, thank you very much for the question. So we have had an invitation to participate in a live drone demonstration.
Mr. Zomelo, if you could take that again, I
Hello,
think
how do you read?
we lost you a bit. Yeah, I think it's okay now. It's okay now. Proceed.
Yes. All right. Okay. Thank you. So, pardon my challenges. Okay. So, we were invited. Ghana Civil Aviation Authority was invited to participate in a live drone demonstration that carrying out flight inspection or ground checks using drones, and this was done under the auspices of the Transport Minister of the Federal Republic of Nigeria. NAMA, in partnership with the Nigeria Civil Aviation Authority, invited Ghana Civil Aviation, and so I was privileged to be there with my senior colleague, Engineer Fred Opoku, and we observed the demonstration, the live demonstration. It was a very good demonstration, I might say, because within an hour, 2 live demonstrations, 2 measurements were carried out, and we were done. And the results were readily available, questions on. And this was a collaborative platform. Several states were involved. The Sierra Leone Civil Aviation was involved. The Uganda Civil Aviation was involved. Ghana Civil Aviation, including Nigeria. So we observed, asked questions, and I must say it was an eye-opener, very innovative, because hitherto the demonstration that we observed, it was in March actually of this year. Ghana exploring avenues to consider this innovative.
I think we're having the challenges.
Technology, how we could integrate ground checks in Russia and all that. But I must say observe a live demonstration, all had been videos. But this time we have opportunity, and we are thankful to ministry.
So, engineer,
it's really
engineer Zomelo
attest to the fact that yes, it is not a theory.
Yeah, we lost you a bit. I would suggest, if you can hear me, you work on your the internet, and then you come at that. I am really interested in your observation. So when you observed, hitherto there were things that you see on screens and the videos and all those things, but now it was a live demonstration. What really did you observe? Like, so want to find out what has your impression been? What did you observe? Is it like, okay, now the conclusion is that, okay, I have approval of the drone for a ground check? Is that where you want to get to? That is what we want to understand. Or is more like, okay, it's still work in progress, maybe we'll come at it at another time. What has been your impression? Yeah.
All right, so let me put it this way. Okay, so when you consider even the preparation from the presentation was clear. Preparation for flight check, it takes a while. You have to do pre-flight call. You need to now during the flight check, several hours are involved. Not even, you cannot do a flight check simply less than an hour. It has to, several maneuvering is involved. But I must say that when we were in Abuja, it was under 1 hour, it was simply done. And you could see the results on the ground. You could readily get the results. It's not a pilot telling an engineer that increase this, reduce that. No, the engineer on the ground is monitoring live the results and is able to make the adjustments that is needed readily in preparation. If there's going to be a flight check, you are prepared. So taking what I took away from it, it's really an innovative way that is going to improve, enhance efficiency so far as maintenance of navigational aids is concerned. That's what is going to improve it greatly, and it's not a matter of going around with, as the presenter said, going around with PIRs, fixed locations, climbing on top of roofs and all that, but you can readily, observe the flight. This time, even the drone is able to go above 100 meters. I don't know which antenna on the ground you can use to do ground checks, which stall more than 100 meters. You see, so it was a very good thing. The demonstration was good. I would say that if we're able to get these systems as ANSPs, as CAs, it will enhance our maintenance and then improve efficiency. That's what I want to say. I hope I answered your question.
Yeah, thank you very much, Engineer Zomelo. Now, Daniel, so everything boils down on training. If it were the case that we want to implement such technology for flight car, training, ASEP training, they have to interpret data that the systems are churning out. What do you think? Do we envisage any difficulties as far as training is concerned to be able to get to the level that we want the ASEP to get to in terms of the operation of this flight calibration vis-a-vis usage of the drones?
Thank you, Blaise. Before I answer your question, I would like first to support what Engineer Zomelo said. We usually have a problem with doing ground checks for GP. Yeah, because at the level where you're supposed to intercept the slope, nobody can go there. Yeah, but with the drone, that problem is solved. Yeah, you can actually do ground checks with a drone on the GP, right? Yeah. Now, coming to your question about training. Training, I don't think it will be a big issue, yeah, because our ATSEPs are very bright guys. As long as there is a syllabus in place and a procedure. For example, now for them to be competent in using that drone, at first they have to be trained on basic drone ARPAS training, yeah? That is piloting that drone, yeah? Then after that, they have to be trained on NAVAIDS concept, which already I think now they have. Yeah. Most of them they know the NAVAIDS concept, yeah? Where they know the limits, the tolerances, how the signal is, how it's supposed to be, yeah? Already that one we have. So what we don't have is now the piloting and data analysis. Most ATSEP actually can do data analysis when you give them flight inspection data, which is actually the same data that a drone will give you, okay? Because a drone actually correlates with the flight inspection strongly. There's research that has been done. So to me, I think for them to be able to interpret that data, yeah, they will have to do the concept first, and then after they know the concept, that is when they can be able to to interpret signal strength, modulation depth, DDM, SDM. They will know very well this is out of tolerance, this is within tolerance. So to me, I think in terms of training, our IFATSEA just need to do basic drone ARPAS piloting. Okay, that's all.
Thank you very much. So now I'll turn to our colleague audience. I'll pick probably about 2 questions, then I'll come back. If you have any question. Yes, please go ahead.
Thank you. Thank you, panel. Mine is just an observation. I'd want to say it has been a pleasant surprise for me. I am actually shocked and been watching here in awe that in front of us we are having regulators championing a technology. I've never seen that in my life. And that's an observation I really need to thank these guys here and the manager out there in Ghana. Thank you very much. You are pushing a paper for technology to be used in operations. Thank you very much.
Yeah, so Engineer Mary, so let me just say this, Engineer Mary, before you come in. So the Air Traffic Safety Electronics International, the journal edited by our own Professor Adenka, you were quoted in that paper, the latest edition, as saying that, and I quote, although a good support, a drone is actually a complementary aspect of flight calibration now. Definitely, drones cannot replace flight calibration. Calibration aircraft represent, except it's a situation where the regulations have been amended. Most regulators don't have drone regulation. In terms of range, the capability of drones is 1 to 1.5 nautical miles on line of sight, whereas flight calibration aircraft can do a range that is in excess of 20 nautical miles. As such, drones cannot perform most of the specification in Doc 8071 unquote. Before you come in with your question, the Engineer Mary, this attribution to you, is it true?
I can't deny that.
All right. Yeah, thank you very much. Could you expatiate on this particular this that you have said? What are you talking about? Just give us a sense in this whole. So now there are 2 things here. We are talking about the range. So if the drone is able to cover the 20 nautical miles, as you put it. 2, and there's regulation. So it covers the flight calibration from what you just said.
Thank you very much. I raised my hand to make some comments, but you've taken me off guard, not knowing that you are reading a document somewhere and was already preparing for me. I can't deny that. Yeah, I made that statement after an interview that was granted to me after the drone demonstration in Nigeria. I want to first start by commending the panelists here for the beautiful presentation, particularly the preamble we received before the discussion commenced. It was fantastic and has a lot of knowledge that we can embrace and can help us. However, I'm an advocate of new technologies, and drone flight calibration or drone calibration of navigates happen to be one. The demonstration in Nigeria was at the center stage of it. The planning with the organizers,
So we did quite a lot together, and we were able to discover some of the limitations. But just like the beautiful presentation we had by the panelists here, it points to the fact that for now, we don't have enough regulations to support the use of drones to extend the periodicity of our air navigation facilities. The best for now that we can get from the drone services is just like being x-rayed by our panelists again, that it can give us a good support for the ground maintenance. And I want to say that that is a very critical point in the sense that when we talk about the costs involved in flight calibration, most of them is as a result of the time spent to flight check a particular system. Take for instance, if you are going to do a flight commissioning of an ILS, you may not need less than 10 hours for the proper commissioning of that facility. And keeping an aircraft in the air for about 10 hours, you know what that means in terms of fuel consumption, the manpower that will be there, and so that makes it a little expensive. But with the support of drone in the navigate maintenance, you discover that you, instead of spending 10 hours for a flight commissioning, you could cut down that hours to like 6 hours or far more less, depending on how good the groundwork is done. Because most of this time that are spent with the aircraft is as a result of repetitive runs to make adjustments. You want to flight check a glide slope, for instance, and you give a shot, and you discover that the glide angle is either high or low. The maintenance engineers, in most cases in commissioning, may not be able to adjust the angle electronically. They may have to do a manual movement of the antennas, and the aircraft may have to be on ground, wait for them, do the adjustment. So, but the drone can help you eliminate all this process. You could see with the drone that the angle is high, and you could make adjustment until the angle is correct. When the aircraft comes, instead of flying 3, 4, 5 runs and discover that the angle is high, you are still making adjustment, you could use one run and pass that equipment. Fortunately, I'm a flight inspector, and I've had to do an inspection of a glide slope where we run 21 runs just to correct an angle. 21 runs, because it was a critical system, and the customer wants this equipment to pass at all cost. And after 21 runs, the equipment still did not pass. A drone could have saved all those energies. You could use a drone, you could discover this, and keep the aircraft away until you have settled this issue, and then bring in the drone. So I think the drone innovation, until the regulatory aspect is fully established, you will discover that it is a very good support for ground maintenance. The statement I made on that publication as regarding the range, when you go to the ICAO document 8071, it gives a details processes of the flight calibration that should be conducted on navigate facilities, that you could now use it to extend the validity or periodicity of that facility. And some of these runs, take for instance, if you are checking a localizer, it is required that you check the coverage at 25 nautical miles, check at 17 nautical miles, check at 6 nautical miles. So you discover that drone does not cover this range. So you have that limitation of trying to cover this required range by the
regulations that we already have in place. So those are some of the few challenges. Otherwise, drone is a very beautiful technology. But one critical observation we had in Nigeria during the drone demonstration, like the first presenter mentioned about airspace disruption, we discovered that it was difficult for the air traffic controllers because during this demonstration, the air traffic controllers at the approach needed to, be able to have a view of this aircraft, of this drone. But because the drone doesn't have the broadcast facility, like the ADSB facilities, where the approach radar can be able to see this facility. So it was difficult for them to control aircraft too, because they cannot see where the drone is. We had to visibly ask the drone, come down, because there was an aircraft coming. We had to visibly ask the drone pilot, bring down this facility, otherwise the aircraft coming can jam it. So it was difficult for the air traffic controllers to, monitor this drone movement. So we raised that as an observation for the manufacturers and those who are projecting the drone facilities to consider. There's quite a lot I would have loved to say on this drone. Thank you very much for the opportunity.
Yeah, thank you very much. Thank you very much. So, hitherto, this whole discussion would have centered on the possibilities. What do we do so that the ANSPs within the continent will be able to embrace this? Here lies the case. Our job, our work has been cut. AFCAC is made a paper. So now we should be thinking of the regulatory framework, something that will guide us as to what we are supposed to do and how we do it. So as a regulator, so this question goes to Mr. Agaba and Engineer Zomelo. As regulators, what do you see? What framework, regulatory framework, should the continent develop to be able to meet this particular goal?
First of all, the focus should be on the facilities that we use. How best can we ensure that they remain integrity-wise up there? The regulation as regards to calibration of flight inspection of nav aids are there. The current technical guidance material that we have issued out are only based on two parts: the ground tests using the PIRs and the flight. Yes. Now the only component that we need to include is the drones. But I have been talking with my colleagues in Uganda, the R&D. It becomes a very hard thing to implement when you have no data. First things first, as regards to the procurement and the establishment of the unit to carry out tests using drones, I accept. But before I include it in any regulatory framework, I need to see some data. It has to be backed up by data. And this data can only be collected collaboratively while you are using the other known methods of tests. Why do I insist on having that data? We want to maintain the integrity of our facilities, our procedures, and our tools that we use. To maintain that integrity without ICAO backing us up. Remember, we don't have any subs as regards to that. To have that integrity without ICAO backing us up is now the onus of the states or the sovereign states to be able to come up with data that is authentic, that can be used to defend any actions you have made. So, as regards to regulatory framework, first thing first, as we push the idea for this to be adopted at ICAO, and meanwhile the purpose of us doing at the assembly is that the assembly has the mandate to direct the technical working groups within ICAO to set up teams to be able to look at what we are doing, if the numbers are right, and to be able to come up with resolutions or conclusions as regards to that. That is the idea on the side. So as we wait for that to work, what we are doing here, I would encourage those states that have R&D to go ahead while also collaborating with already known NAV8 drone operators, as Nigeria has already done. Call those people out, visit them, look at their tools, look at their payloads, look at the softwares that they are using, run them collaboratively with the test procedures you have in the state, verify the data, collaborate the data, if need be, procure, and continue using them. Now, as you build your data, I keep telling my colleagues, we need to blend these two technologies. As we continue building data, we are establishing a basis of trust in what we are doing. We are establishing a basis for usability of the drones for our activities. Remember, our activities are safety of light activities, and any mess up, you know, the catastrophe that comes in. So as we build the trust, we are building the trust on data. We are also on the other side pushing ICAO to look at our problems as Africa. We have challenges, and I believe, if you all know, we have an Annex 10 Volume 6 that is coming out, I think, next year, and it is on the basis of C3 links or C2 links for drones. That is a good thing. We are now looking at the command and control part of the drones. So that is bringing standardization for drones as we look forward to using them for other activities. Right now, the only proposal I can make for the ANSPs, take it as the Ugandans have taken it. Do your groundwork, look out for those drone operators that are already out there, use them or establish data based on your facilities, leave alone their operations out there. Let them make it yours, like Nigeria has done. Make it yours, make it your thing, local, that you may be able to authenticate the data that you have gotten from the runs that the drones make. And then we can then include the tool for use of drones for whatever tests we are seeing are workable as one way of trying to solve our challenges in Africa.
Yeah, thank you very much. Before I get to Engineer Zomelo regarding the regulatory framework, Isaac and Daniel. So Daniel, work with me when we talk about data. How do we get data, and we talk about the integrity? How do we get there? Walk us through from step by step. I just want to understand that we are no more in a situation whereby we would have to be thinking through whether we need to do this. The agreement is that yes, this is doable. We've gotten to the point where we realize that yes, what do we do, the regulatory framework and all those things. But we are talking about the integrity of the data we are talking about. So how do we get there? How are we sure that what we are coming up with is something that in all aspects we are talking about safety? So how do we get to the realization that yes, what is coming out is what we actually want?
Okay, thank you, Bless. About data, a drone actually collects data on continuous verified signal. Yeah, and the data that is being collected by the drone, actually, if you look at the graphs generated by the drones, are almost similar to the graphs generated by the aircraft. Yeah. Now the only thing comes in collaboration with other states, where maybe we want to save costs, and a region wants to collaborate and buy a flight inspection drone. Now that is where the problem will come in about the data, because there are some sensitive data which some countries will feel not comfortable to share with the other country. Remember, that data is collected by the drone, so probably it's somewhere in a database in the system of that drone, right? So if you go somewhere and especially when you go and do ground checks for the military, they become very sensitive. So I think with that, countries can come up with a way of working out on how this data should be preserved, yeah? Should be preserved so that the integrity of that data will not leak out to people who are not authorized to do it. So I think through collaboration and agreement and understanding between countries, that one can be done.
Thank you very much. Engineer Zomalo.
Yes,
yeah.
Go ahead, please. Sorry.
No, it's still about the question on the regulatory framework.
Yes, thank you very much for the opportunity. So, just to add a few words to what my colleague Gerald explained. Typically, you would have regional safety oversight organizations, which almost all the states belong to. You may have Kasua, you may have Bagasso, and these regional safety oversight organizations exist to harmonize regulations. Because if we operate in a region and we have harmonized regulations, it's easier for us to transfer capabilities like pilots from one country coming to another country, like a drone pilot coming from Nigeria, coming to Ghana. The certification processes for that pilot to conduct any assessment becomes a bit easier. So these are platforms, the regional safety oversight organizations are platforms that we could look at, where countries that already have existing drone regulations, could be harmonized, and then other countries that do not have that capability can adopt. ICAO has quite an extensive guidance and even standards for remotely piloted aircraft systems. They have that for licensing of the pilots in the Annex 1. They have that for Annex 6, Part 4, which is going through rigorous development, and also the Annex 10, Volume 6. However, the part that may be missing in the conversation will be for this flight testing, ground checking or ground testing of navigational aids. That's why we are advocating that, look, if we look at this, it will be a bit easier to integrate the drone into our legal frameworks and then our maintenance arrangements to ensure compliance. So these are the regulatory platforms that we could exploit, we could explore, and then countries that have fully developed RPAS regulations, others who do not have can also make use of. Typically, you would have certain assessments like the specific operating risk assessment that is conducted on a remotely piloted aircraft system, right? SORA, you do a SORA, you do some use ARROW, which is assessment of risk on RPAS operators. So once the concept of operation is understood and you have passed this, all this will be outlined clearly in a regulatory framework, and getting drones to work or to complement our flight inspections becomes something that we could explore. So it's not difficult to do. We just have to put our shoulders to the wheel as inspectors, as regulators, to look at this drone thing, try to fashion out something. Africa, we are discussing a lot, particularly the AFCAC, at the AFCAC level, African Civil Aviation Commission level. There are expert working groups that are looking at several issues that border on ANS efficiency, and this is one of them. And it's also another platform we could look at to develop the requisite regulatory requirements and framework. Even if ICAO decides not to let it pass now, we could still spearhead some activities. I think IFATSEA can also collaborate with AFCAC and also set up a committee to look at how the inspectors in the affiliates can collaborate to also fashion up something that can be proposed for consideration. That would be my take.
All right, thank you very much, Isaac. Yeah, so the issue about the data, just in about 30 seconds.
Yeah, so from our side, the issue about the data is that, of course, you need to have the drone, your payload, and you get the data from the payload, but you need to collaborate to, how do you say, to compare it vis-a-vis the other traditional methods that you've got. So since we are starting with the ground checks, then you have your traditional methods, the PIR, which should give you some indication as to whether your measurements with the drone are close or they're far off. And then, of course, when you look at the drones and the remote, generally the remote pilot aircraft, you do have the different levels of operation that you can have.
Okay.
So with the visual line of sight operation, this falls within what we can do with the ground checks. Okay. So later, if we can validate the results of the ground checks, then now we can look at the more complex operation, that is the beyond visual line of sight operation, where you need a much bigger aircraft with, again, more capable payloads, and then now you can actually tackle the real flight calibration. Yeah. So, but I do believe that it's only a matter of time. Okay, it's only a matter of time, and I do believe that even the established service providers should be looking into this for their own operations for the future. If they're not, I think they will go the way of the big corporations that fail to adapt to change.
Yeah. All right. Thank you very much. I think that we are almost wrapping up. My final question, we'll go around anyway. But before that, I will go to the audience and pick about 3 questions and come back to you. Before that, we are talking about regional collaboration on drones. So now that we have established a situation whereby that is the way we want to go, how do we collaborate? I want you to think about this very question as we go to the audience. Yes.
It had to be you.
Okay, thank you very much, working group, for that paper. It's really very welcome, and especially on the issue of extending periodicity of the flight calibration. I think it will really, make business sense and add value so that we don't spend a lot of money on flight calibration. Now, back to what we've been discussing and ensuring that Africa is not lagging behind. I don't know whether I picked well, but it seems even in this wave, we are participating in this new technology as consumers of the technology. Yeah. So these days, technology is ubiquitous. Things are demystified. Why can't we work on developing and owning the technology ourselves and not participating in the 4IR as still consumers of technology? I thank you.
Yeah, thank you. Any other? There's a hand behind.
My name's Johnson Mugisha. My question is directed to the team that is developing the working group, the working paper, Engineer Agawa Jared and team. In addition to freight inspection of, freight carrying out ground checks, I was of the view that you should include other functions like search and rescue operations, especially in hard-to-reach areas. We have had incidences in Uganda where there was an accident on Mount Rwenzori, and it took our airworthiness inspectors weeks and weeks to reach that hard-to-reach area. So I was of the view that you could include such other functions in addition to our freight inspection or checks, other aviation-related tasks like search and rescue operations. Thank you. And the other thing is these trained drone pilots. Do you also plan to call them captains like pilots of other? Okay, thank you.
Yes, Peter.
Thank you, panelists, for the discussion. I want to ask Mr. Isaac. We recently have many issues concerning AI, and as we are discussing in the morning that we should be proactive and we should use the data we have from the facilities. Actually, during flight check and flight calibration, it's just we are just checking the signal if they've been degraded. Can't we use the AI or the analysis of the system logs to identify that my system has degraded performance, then now I need to do the flight check instead of having a periodicity maybe of 6 months for ILS and 1 year for VRR. Can't we develop maybe a regulation and submit it to regulators, then they can approve that we can use the data and assess the data from the system as a requirement for flight calibration?
I was expecting a clap from such a question, but
okay, so the final one. So let's take the Isaac. Yeah, Michael. Yeah, let's give it to Isaac.
Thank you for those questions. I'll start with the one from Engineer Peter. So, in my understanding, what you're describing relates a lot with the topic that was here earlier in the morning. That is the predictive maintenance that we're talking about, where you, of course, have you're monitoring the data, the logs from your equipment about the status that is being observed by the monitors, okay? So that observation and analysis of that data, you can apply AI or you can do data analysis by the ATSEP, and then you come to the conclusion that there is something wrong with your system and you need to check. So once you've suspected that there is something wrong, then this is where you would ideally come in with your drone and you fly. You check the signal that is being radiated to confirm that there is actually a problem. Because also sometimes this is also electronics. It can happen that the signal in air is okay, but maybe something is in the monitoring system is giving you these false positives. So I remember someone was asking about how do we ensure that we don't deal with the false positives. Okay, so the false positives is you deal with it by doing the real live check of the system. Okay, so in that, when we confirm that these measurements are being reliable, then this is where now the regulator has to come in. Once we've convinced the regulator that the data we have corresponds, that I mean if I've if I have flown the nav aid and I have actually confirmed that there is something that needs to be corrected, and I correct it, and then I confirm it later with the flight calibration, and it is actually correct, then it means that the regulator has grounds to say that, you know what, there is a strong correlation between the data from the drone and the data from flight calibration. So you build this trust, and then you can come to conclusion that if I do the check using the drone, it is as good as that done using the aircraft. So you can then now extend reliably the periodicity and say, instead of 1 year, let's do 2 years, where the aircraft comes in at 2 years to confirm that actually it is still the case. Okay. Then Engineer Andrew was talking about our participation being largely still consumers. Okay. Yeah. So for someone who was just woken up, you don't start by running. Okay. Yes, you can start by walking, but you see that even in our participation this time, there is a difference. Previously, we would maybe sit down and we wait for the manufacturers and the Europeans and Americans to do all the research, and then they come to us with the finished product. Okay. But we are now saying that, okay, maybe we didn't create the technology, but the technology exists, and we can come up with our own product. Yeah. Okay. So after our own product, then maybe we shall come up with a technology or contribute actively to the technology. But of course, that will not happen by just the ANSPs and the ATSEPs. For us to actually contribute meaningfully to the technology side and the development on that front, we also have to bring on board the academics, the universities, because they are the ones who really have this, who can go into that very detailed research. And yeah, so if we take it at that front and include and have collaboration with the academic institutions, then we probably have, that will give us a leg up into stepping up our contributions to the technology. Yeah. Thank you.
Yeah. I wanted to respond to Johnson Mugishai's questions regarding why can't we use drones for activities like you described, where there's an accident or search and rescue. I think the paper we developed was on the basis or on the background on, I don't remember offhand the assembly resolution which called for ICAO to, the resolution was by states, the assembly calling on ICAO to develop SAPs as regards to safe integration of drones in the controlled airspace. So that has already been done. The request has already been made. But I want to note that the challenges that have cropped up ever since then are visible. The drones have, how can I call it? They pull together very many stakeholders, and they have so many stringent attachments to, say, security. You realize that for you to be able to successfully use drones for your benefit, you have to work out how to manage those who will want to use it against our well-being. And it brings in the issue of privacy also. In 2018, when I was concluding my master's, it was actually a master's in unmanned aerospace systems. My research was about how to integrate, of course the categories are many. Mine was small UAVs into the non-segregated airspaces. And the airspace I was working with already had already matured, and the national airspace system was mature, and they already had, through one of their research centers, that was NASA, they had already called on its centers to develop to develop and qualify how we can work together with manned aircraft systems within the same segregated within the same airspace. But the challenge has always been, again, like I mentioned at the beginning, that the concept at the very beginning was not meant for unmanned. I think we never even conceptualized it at the very beginning. So now you've already built your basket based on a concept that is having a human in the loop. And now you are trying to bring in something that is outside that. It has very many factors attached onto it. You have to look at the other stakeholders that are involved. You have to look at standardization, whereby drones have already been in play before even standardization was put in. That has been even, we haven't even gotten regulations regarding or SAPs regarding standardization of drones. So the biggest challenge we are having now is threefold. One, security. Two, the concept. And three, an issue of people have already started using them. How do you manage that? Yeah, so for Johnson, yes, there are very many benefits of using drones, not only for search and rescue, for even surveys, road surveys. We are going to have a pipeline here. You'll need a drone to monitor your line. You can use it for many other things. But the challenge has always been a security challenge, which I will not go in depth, because in many discussions, when you give more information, you're giving fruit for people to think otherwise. But it is an issue of security, and security is wide. Until we get a cover for how to deal with that, there is the way we are only going to be managing the use of drones strategically, only for safety critical, like we have developed this paper, only for issues in the states that are beneficial for the state. Otherwise, my take was, I was very passionate about this. My paper was adopted and used also for development of some regulations in that state. However, this challenge came in later, much later, and it is a challenge which we have to deal with. Thank you.
Okay, all right. You want to come in?
Yes, yes, I also want to add to the responses given already. With respect to the drone pilots, yes, they are also called pilots. Per the Annex 1 licensing regime, once they undergo, they are also called pilots. Only pilots for unmanned aircraft or aircraft vehicles. So that's it. Now, as Gerald puts it, the case of the use of drones have several uses. It can be used for several things. It can, area, he mentioned the area use. We could use the drone for search and rescue and related matters. However, as engineers at IFATSEA, as we are concerned with our performance, our operations, and so that's what came to mind readily. What is the problem we are faced with? The challenge we have is that a while ago, they indicated that conventional navigational aids were to be done away with and replaced with GNSS. But all of a sudden, interference, radio frequency interference on GNSS signals is becoming a challenge. It's posing a lot of difficulties. And in March this year, ICAO and IMO and the ITU, the International Telecommunication Union, released a joint statement saying that as a stopgap measure, we should continue to maintain conventional radio navigational aids. So maintaining these facilities is very critical, and that's how come we had focused on making sure that when it comes to performance as service providers, we're able to comply with the requirements. And then also as CAs, we are able to pass our audits and have very good records. I mean, we want to keep the top-notch safety performance. So that's how come maybe we have looked at this. But I can say that drone use, we have several uses for it, and it can be used for search and rescue and any other. However, because this was a performance issue where air navigation service providers, the cost implications were becoming unbearable. The delays, for instance, one service provider and a flight calibration unit or service provider for you to contract it to come and assist you if you don't have, you'd have to wait for some number of years or days and whatever before they add you to their list. And then the cost is becoming unbearable. And so if there's any way we could ensure efficiency, that's how come this paper came to be. Now about the AI aspect, I think that's a very good question. However, I must say that, as we all may know, the navigational aid systems have internal monitoring mechanisms that built-in self-test equipment that are already picking data within, and you could use those data. Maybe AI can analyze and help you. However, when the signals are transmitted, terrain issues come to play, where multipath signals bouncing off buildings and structures may affect the signals as being received by aircraft. So we're dealing with signal in space. So AI may have limited use so far as we are dealing with signal in space. After you have now picked the data from your flight check, as my colleague panelist mentioned, then AI can now help you with the interpretation and analysis of the data so as to make the best decisions. So yes, AI has a role, but readily you still have to go out and then pick the information. Concerning the consumer technology, and I think the panelists did justice to it, it's a fact that we are air navigation service providers, we are CAs, and we have some job task to pay attention to. Little can be done maybe in terms of research and development, although some organizations may have that aspect, but it's an area we are not fully developed. Drone technology, so far as outpass integration to civil aviation use, is still undergoing evolution, is still evolving. It's not reached maturity levels yet. So yes, we could also set up some collaboration schemes with the universities, as he mentioned, and then find ways that upcoming Gen Zs and the newer generations may look into it, as in developing that capacity to also build this technology. I mean, you make use of technology and build these drones so that we can also become developers and not consumers only. So this will be my take on the issues as well.
Yeah, thank you very much. Daniel?
Okay, thank you very much. There is a gentleman from Tanzania who asked about AI. Actually, the drone data, if integrated with AI, can predict exactly what parameter you are likely to adjust during now the real flight inspection. Because a drone is easy to deploy, yeah, you can take it somewhere in a very short duration. Yeah, you can actually travel with it, and once you deploy, you go and do measurements over a period of time. You'll be able to see the trend of that equipment. You can see now your alignment maybe is shifting, and you can actually predict that these parameters are most likely to go and adjust during flight inspection. So true, it can be integrated with AI for predictive maintenance.
Yeah, the last question. Yes, go ahead. Oh, okay.
Good afternoon. My name is Kelvin from Ghana. So my question is, in the conventional PNRs, we tend to do periodic calibrations on the PNRs to ensure data accuracy. So in the case of the drones, what software or hardware sense is there to ensure that the measurements we pick are always accurate? That's my question. Thank you.
You heard him?
Yeah, so
Thanks.
yes.
Go ahead, sir. Go ahead.
Okay, thank you. So for the calibration of our, regarding the drones, our payloads that are actually the PNRs that you're talking about, there is no way around it. It is a sensor, so you also have to calibrate it to ensure that what it's reading is the right thing. So that one is standard. Yep.
Okay. Engineer Zamelo, were you coming in? Otherwise, we'll just wrap up. So I just want to go around that. So what are the steps do we envisage for the African ANSPs to come up with in terms of the piloting of these drones? I'm saying this in relation to the collaboration that we are talking about. So where do we go from here? So I'm going round. Who wants to go first? Anybody?
You're going first.
Oh, I mentioned, and I want to thank the audience so much. They have exercised patience, and when I look at you, you don't feel tired. The issue is that our colleagues, Uganda, you have your guests here. You cannot leave your guests, and the fortunate thing is that the guests are not complaining, and so I think that we are all here. Thank you very much. Yeah.
Yes. What are the steps? I think we are already doing some of them.
Okay.
One step is what Nigeria did by inviting some of the service providers for radio navigation, for drone navigation aid calibration to come and showcase what they have. That's the first step. And they did not do it alone. They included all the other states that can be reached.
Yeah.
That's the first step. Collaboration is talk to the known providers, have them showcase what they have, work together as a team, African team. The other step is what we are doing as the regulators, front the desires of Africa at another level to try and bring this into play for Africa. Then work out the framework, regulatory framework, including guidance material as a unit. Again, I'm emphasizing working together because at the end of the day, even the data collection would make more sense if you have big data. If you have data from more than 50 states, instead of having data from one state, to be able to analyze and authenticate some of those tools.
Yeah.
And then finally, blend the inspection test, the tests, both drone and the conventional ways. That is my take.
Okay. Thank you. Yeah. Well, okay, Engineer Zamelo. Let's finish with the regulators. Can you pick that up?
All right, thank you. Yes, thank you very much. And I must say that my colleague has hit the nail right on the head. And the little I would add is that actually we need to influence decision makers as a group, because the decision still rests with people who are above us, and we need to bring them to the understanding that we need these technologies to help enhance our operations and efficiency. So it's one of the things, a major step. Whether we can even, as an ANSP, as a state, allow the integration of the drone for CNS ground checks is a major issue. It's not so easy. Most states will want to deal with what ICAO has documented. Is it in the annex? If it's not there, forget it. But we can always, find a way, bring the discussions to our superiors, the decision makers, so as we would have some deliberate policies to enhance, our operations. So that is a major step I think we need to also consider. Aside that, Gerald had said it all. Thank you very much.
All right, thank you. But you kept saying decision makers. Who are the decision makers? So you are in Ghana. Who is the decision maker? So that when I get there, I'll just go to him or her.
Well, right, it starts from the. So if you take at the organizational level, you would have a head of organization, maybe your DG, your MD for an air navigation service provider. You scale it up to the ministry. Minister is involved. You have several people who make such decisions. Yes, you may have found an innovative mechanism or technology that will enhance operation, but you still have to bring it to the attention of those who spend, the spenders. I mean, those who are spending. Those are the people we need to convince them so that they will be ready to spend on these technologies. I hope I've pointed you in the right direction.
Yes, you have. Only that they are above my pay grade, so thank you very much, Engineer Zomelo, for your time and joining us online. I think that will be about it. I'm not sure there is any other question. So if you think that you have something else to do, we can, unless of course there's something else you may want to add. Yeah. So who else? Isaac. Yeah. And then finally we come to Daniel. Yeah.
Okay. So in terms of the regional collaboration steps we can take, Gerard has already mentioned one of them. Of course, is that before we even begin to collaborate, the people to collaborate with must be there and they must be ready. So within your state, what are you ready to take part to? At what level do you want to participate? Okay. In Uganda, we've said that we're taking this thing head on. So we want to acquire our own tools, the drone and the payload and all that, and we want to do the research on that level. Others could say maybe we are going to work with an established service provider. Then, like the case with Nigeria. So the first step is that whatever the findings that we have, we need to share these findings among ourselves, which will help us to grow the discussion. And then also for those who decide to take the same path that we've taken, we can find ways of working together and say maybe, okay, so Uganda has the equipment, but we have one ILS and it's on Thales, so maybe Kenya has a different type of ILS, so we want to say maybe if we use on this type of equipment, it works. So we then maybe we need to work with our sisters in Kenya, and we say, okay, so let's find a way of organizing to have the research done on that side as well, so that we can get the results. So that coordination at that level, operational level, is also very important.
Yeah. Thank you very much, Isaac. Daniel.
Okay, thank you. In terms of collaboration with neighboring states, I think we are silently collaborating, especially with Uganda, because even right now, in Kenya, there is a calibration exercise going on, and that aircraft that came from Uganda. Yeah. It came to Uganda first, then comes to Kenya. So that's silently collaborating, right? So in terms of drones, Kenya, we have also decided to face it head on, and we are in the process of acquiring one. We've already done extensive research on it, and we think it's a good thing. It can really help our engineering personnel to to set up the equipment before time of calibration, and so calibration will just be confirming. Then, as Engineer Miri put it, it will take a very short time to calibrate a system that has already been checked by a drone.
Thank you very much for your time, the panelists and the other colleagues at the other side. We've heard it all. Director, what say you?
Thank you, Bless. Thank you for facilitating this exciting discussion. I think the team, they've said it all in terms of what needs to happen now, in terms of those collaborations. And I'm glad that it's coming from the team here, which most of us are already ATSEPs, are doing the work in this space. So we need to internalize the collaborations that we are talking about. So we need to concretize the action steps of what we need to do. So there's work already that AFCAC is just doing, even though the paper is still going to be submitted at the upcoming assembly. If there is an opportunity for us then to also contribute, it could be in a matter of supporting as IFATSEA. I think the president is here. It's something that we can consider, because it's the area of interest, especially for us as the continent. As you can see, those 54 states, they are pretty much saying this is something that we need to seriously look into. And when you look at it, how is it captured? It speaks to the cost, the rents and cents, and the decision makers that Zomel was talking about. We need to answer that fundamental question: the efficiency that we are bringing in. Am I saving money here? Is it helping? Yes, I understand the safety element is quite critical, but at the same time, it should not be a solution that's going to cost me an arm and a leg. And already we are addressing those pertinent areas where we've got so much limited resources. So innovative of this nature, they are contributing to trying to tap into those limited resources. We need to take action items from this and then see how do we build further. I think the collaborations that Isaac has alluded to it, that we need to, those partners that we are bringing on board, let's concretize those collaboration areas so that we are able to map a way forward. And maybe as a side note, what I'm picking up here, there's a lot of work that has been done on the ground. But I had to organize a regional meeting for me to learn about this exciting work. So that needs to change. And IFATSEA is there probably as a vehicle, and all these other platforms. We need to blow our horns. We cannot be doing such great work and yet it's not known. The platforms are there for us to use it, because we are not, one will say you are blowing your own horn, but maybe that's what we need to do. Because we have put our blood and sweat, I think, on this work, great work that we are doing. I mean, the work that Isaac is talking about now. I speak to this man almost every day, but I never got to learn about this exciting work that they are currently doing. But I think we are on the right track. We just need to keep on pushing on, and we don't look back. I think it's time for Africa to rise. We are there. I think we are jumping that line of talking about things and starting to implement. And I think this room, we can, in our area, we can start here and only build from here. Thank you very much.
Thank you, Director. We are not. Where's the photographer?
Hey, not yet. I just wanted to add something. What the director just mentioned. I can understand where Isaac is coming from. Ugandans are very humble people, but Isaac, please let him know that we are doing nice things.
Yeah, I'm looking for the photographer. I need to take a group busy with the panels. It's very necessary. question? Okay, all right. How many questions are we talking about, Michael? Just one, okay. Two. All right.
Yes, my name is Joel Chiwanuka, and I happen to be part of the team that went to witness the demonstration in Nigeria in March, and I was glad to see Sam there because we were with him, along with my boss, Engineer Chris Rukundo, in his absence. It was a very fruitful demonstration, and I want to expound. I just want to add my voice to this solution that is coming through. I want to expound on the applications of the solutions. Engineer Johnson was talking about, applying it in search and rescue. And we witnessed, apart from having drones being used for navigate calibration, a company called Colibrex had already done it, that they were using it for spectrum. They had a spectrum analyzer on the drone. So recently at CAA we obtained a roads and shores spectrum analyzer, but now imagine it being on a drone and you're analyzing the spectrum. So that is another application. And also Airbus is using the drones to inspect aircraft. So that is another application also being used. The Nigerians have done a great work to welcome Colibrex, the company, German company, and I want to add a voice that collaboration, we can invite maybe Colibrex, the German company, or the Koreans, or the Spanish people who are already doing this, to come to the East African region or to come to the South African region, because we didn't see so many countries come through to see the demonstration, and it was a very good thing. So in collaborating, we can also do that. And I want to highlight also a challenge that I saw. It doesn't go without saying that when you are bringing in a drone, there are challenges of clearing it. Now, clearing it means going through military, Africans, you must go through military. Here you must go to the president maybe to clear it, something like that. So we have to prepare for such challenges, and maybe Mr. Gerald, you know what I'm talking about. So we have that challenge. Then I want to also tell you a story that when we were almost landing in Nigeria, we were held in a holding pattern for went about 3 rounds, and we wondered why. But they were testing the drone they were doing a test for the calibration that day. We found out later. So we must take into account that challenge, that when this calibration is taking place, it must be done in maybe in a non-peak hour. Okay. Then I would also like to say that I had a very interesting story in Nigeria. I had jollof rice and I almost choked to death. Thank you.
Okay, Michael.
Forgive our colleague.
Who is the last person?
Thank you. I've been sitting for a long time. Moderator, allow me to stand. I would like to respond to the concern about the people that are above your paycheck. Yeah, it is very important for us. I actually enjoyed the discussion, the innovativeness that we're talking about, which is really great. And I know that you guys are the great African think tank, and the thinking should now come into reality. I'd like to talk about engagement and partnership. We can come with all these great ideas. To illustrate, let me say this child, a village child whose parent has never gone to school. So they have a geography ramble. And he's telling daddy, I need so much money to go for a geography ramble. The uneducated parent has no idea what that is. It's very difficult for him to put his money there. In the same way, all that you are all the innovation that you are coming up here, for you to be supported, that engagement is very important, to a point where we break down all these jargons, all this innovativeness, to a point that the finance person understands it, the DG understands it, so that there is a win-win, this understanding, we're all on the same page. Thank you.
Absolutely, absolutely. Thank you, thank you. Any further question? Do you have any other?
Finally, now let me become also. They've been talking about the signals and the calibration of the telecom signals, the navis and stuff. In Uganda, as you know, there is an issue of calibrating puppies or the is it visual? The visual aids. Are they part of this, or that is another? I mean, using the drones for calibrating the visual aids, because right now when the aircraft comes, it does that. So is it part of this initiative, or for it is what you talked about for the later? That is for especially the inspectors. Thank you.
Yes, anybody else?
Yeah, so that is really just a matter of the capability of your payload. Okay, so the different payloads with different capabilities. You have those that look at the VOR signals, ILS, VHF signals, and then as well as the visual aids. The particular payload that you choose is the one that gives you that capability.
So forgetting the politics, I know. In short, your answer is yes.
Yes.
Thank you.
All right, thank you very much, colleagues on the panel. We are very grateful for your time and your insight into the topic. And the audience, I find it difficult to call you audience anyway, but I guess that's what we are. I want to thank you so much for your time, and I can say that you might think the discussion ends here, but no. I think there's a call for action, and we are going to follow this particular thing through till the end. That I can assure you. On this note, I thank you very much. Thank you.
Before you leave, there's some gifts for you. Thank you, Bless. Members, while they're receiving their gifts, I have to mention that our moderator today, Mr. Bless from Ghana, these are the gentlemen who are making IFATSEA Africa work. He works in Ghana. The African Region Director is in South Africa, but they're getting IFATSEA working, calling each and every president all over the place. Yet they're in different time zones. So you can imagine this kind of work. We thank you. Thank you, panel. So, finally, the day has come to a close. But before we close, a few remarks. Since yesterday, we've been talking about capacity development, here, there, capacity building. Allow me to. Something to do with competence, licensing, certification, proficiency, and cross-training. Allow me to invite for a message of support. Amidst us, we have a very, very, very important guest. is the Secretary General of the African Approved Training Organization, a founding member of IFATSEA, that's the Tanzanian ATSEP Association, a former IFATSEA president who has worked with Tanzania Civil Aviation and has been a principal. Principal, I mean the head of the Civil Aviation Training Academy of Tanzania. A very powerful lady, Engineer Margaret Charenda. Please invite her for a word. For you gentlemen who don't know, when a woman decides to pursue a career beyond being a mother, it is a sacrifice. When you find powerful ladies like this one over here, and all the experience they have put in, when you have them, you hold forever. Please.
Thank you very much. The Director of Ceremony, ATSEPs, colleagues, I call you colleagues because that's the name I prefer. So, 1st June this year, 1st June 2025, I've clocked 44 years in the aviation industry. By the raise of hands, some of you have not, do not qualify to that age. Hands up, those below 44. Wow, amazing. So, I'm very glad to be here with you, and I promised the President, IFATSEA President, and IFATSEA Regional Director that I'll be here, because this is my passion, to be with you colleagues and share some few thoughts. So what you are doing is quite amazing. I'm quite interested. The world has evolved. When I started is when Frank said the amplifiers were the valve. And the huge transmitter, Philips, I don't know what, a cabinet, just there's nobody here with maybe some. That's the height of the cabinet. And before you start working on the valve, we have to earth it because the voltages were 33 kV, you see, for the amplifier. But then we've evolved, now we have friendly and very flexible, small in size, integrated circuits and the like. But we'll continue working and maybe we'll evolve to the, I don't know how the future looks like, but so long as we live, we survive, we will see how the future looks like. So I had some few issues to discuss with you, and I wanted to share them during the first discussion session this morning. And the issue from my experience in terms of ATSEPs, you need full participation of qualified and experienced ATSEPs on the area of specialization. What does that mean? We have now seen the, I can say, like an interference of the specialization from other, I can say, fellow staff. I recently heard from one organization, I don't want to mention, but you can imagine a Director General of CAA being enrolled for factory acceptance trip. Isn't that funny? Public relations officer in the trip for factory acceptance. So when I say that, it means it is us, the ATSEPs, who have been bestowed by the responsibility of being the project managers. We need to really work in a very highly professional manner. I once was a project manager for the installation of Viora DME in Dar es Salaam. And I was almost tricked to fall in that trap. And I refused, categorically refused. I gave the reason, being the project manager, so and so will participate and why. So with very strong reasons, I managed to not fall on that trap. So there was one issue also in the facilities we procure and work on. By your expertise, or our expertise at ATSEPS, you eventually become manufacturers of the facilities. If you take the records properly, for those who know me, in Tanzania, they used to say that I had my own manual. And that is true. From the time I went for training, I kept on adding on that notebook, and I created a manual of my own. That's why it was very easy for me to work on Navids. Eventually, these faults recur, and so it was for me like it will take some few seconds and the fault has been cleared. Why? Because of the records. So record keeping, even what we are discussing about AI, we need to put the records. And it happened, I had worked for the ILS, although it was Thomson CSF, then we purchased Thales. And then I mastered the systems in such a way that everybody thought that I had already been sent for training, while I did it on my own initiative. So when I was enrolled for training in Thales, then I had my manual. First of all, even before it was during the tendering process when the supplier brought those huge manuals. The secret is go through each line, each sentence. Although it is quite involving, but do it. So we started during the tendering process, and I asked them, for example, why do you not list, say, spare A? It was a local control and status unit. It was not in the list of the critical spares. And they told me this unit never fails. I told them, no, it has failed twice in our country, so you have to put it. They looked at me and said, after all, we are the customers. Put it in. And in Dar es Salaam, having the temperatures we had, even the shelters had only one air conditioner. Then I said, how do you put redundancy for the critical spares and not the AC? So there was so many, and they did it because I knew the system. And there was one issue which I did it when we went for factory acceptance in Thales factory. So as we were being taken through the systems and whatnot, I asked the professor, for those who have gone to Thales, it was Mr. Zola, if you have seen him. So I told him, the way these antenna, it was the pickup probes, the way they have been manufactured, we need to modify them so that we restrict insects to go into the pickup probes. Then he asked me why, because I said, if you have an insect in the pickup probe, you have a total shutdown. He said, no, Margaret, this is not right. And I gave him my records. And that was a very, very interesting failure, because when you check the powers, they were all okay. But then the monitor had total shutdown. So I had nothing to use, maybe to check like you remember the pickup probes, yeah? So what I used a normal standing wave ratio meter to feed signal and check on the probes. Then I find the central probe had a very high standing wave ratio. And when I opened it, I found a frog sitting comfortably on the. and they removed it, and sharp, everything was okay. So these are the things, you know, when you work and keep your records. The professor was very happy actually. So I told them, maybe here in Europe you don't have frogs, and that's why you can. So I then following consignment, the antennas were improved. So, and what else can we do to assist, to customize our brands? We were talking about the cost of maintenance. From the time I managed maybe 3 projects, we opted for Thales. So all the following facilities were from Thales. So if we have critical spares from one station, then when you purchase the other one, you don't need it. You use that one station as a backup. And then as you, maybe you have used the spare, that's when you can order. So we should also refrain from having Thales, ICANN, I don't know who and who. That is not using, being cost effective. So, my passionate plea to you colleagues, you are doing the right thing, you are doing the right job, and with this dedication, safety will be guaranteed. So currently, as the director of program said, I moved from operations for 34 years and then went for training, and then we established, we had, during the safety audits, ICAO safety audits in 2008, it was found that we have inconsistency in training in Africa. So the resolution was to establish a body which will now look for the standardization and harmonization of training in Africa. So I was part of the work group when we were establishing the organization, and then they advertised for the post, and I applied and I got as the first Secretary General for the Association of African Aviation Training Organizations. So I worked for, it was one first term, 5 years, renewable, I got the second term. Then it was over, by constitution, it is, you are not allowed to, but they kept asking me to continue. So I have an extension of 2 years, working on training, standardization. So I am here also to capture on the training needs, on all these evolving technologies, the new concepts, the AI. And in November this year, we'll have the Training Organizations General Assembly. I invite you all to attend, because that's when you can voice for all your concerns, your requirements for training, and then it will be our duty to capture, because for us, we train for the industry and not for our own good. I think that's all about it, and thank you very much for listening to me.
Hello? Now you understand what I was talking about. I don't know if it's about Tanzania. I don't know if it's about Tanzania. The President of the Republic is a female. The President of IFATSEA is a female. And another powerful woman here, 40 years of experience. For other countries, I don't know. And I can't speak for Uganda. Members, thank you very much for being very kind and very patient. The day finally is coming to the end. Just an announcement, special recognition. Special recognition, we've been joined Assistant Registrar of the Engineering Registration Board of Uganda, Engineer Eric Gurminsiriza. Thank you. You notice some people were calling them engineer, others were very quiet, just you call. Because we are very sensitive. This is an engineering fraternity. We don't make mistakes. But out there, you call me engineer, it's okay. But here, no. We want to appreciate our online audience. Thank you for being very patient and keeping up out there. I know you're watching. Oh, all right. Engineer Mary here has told me they are watching as far as German. They have been online since morning. Yeah, thank you for being part of the conference. And then members, don't forget, register. This is an air traffic safety electronics international magazine. This is for ATSEPs. Anything you want about ATSEPs, this is ours. Thanks to Professor, my good friend, Professor Osunusi Adeyinka. When we were in Zambia, I thought I knew a lot about training, and then he comes in front, he starts talking, and I'm thinking, what is he talking about? I think when they say he's a professor, you have to respect. So please, members, everyone, subscribe. I think it was launched in Zambia. I don't know, if I'm not mistaken. Different editions, okay, yeah. So this is an edition for Uganda today. You find very similar faces, like the African Regional Director. I have seen the IFATSEA President is facing here. So please, everyone, register for this one here. I was not paid for that advert. Then for our dear guests, there will be a gala dinner tomorrow. Please, in the evening, of course, after the function. Your invitations are in those bags that they gave you. So when you look inside, you see your invitation there. Please make sure you are there. We have organized a lot. That's why I have to announce, even if you're new. And then we have an excursion on Friday for our guests. We are going to River Chira at the source on Friday. That's June 20th. Please register. There's a registration desk out there. We really need to know how many are going to join us, because we have to make arrangements on the other side. The numbers matter. But just from an experience, when we were in Zambia, I was enchanted by the Mositonia. They call it the smoke that thunders. For those who read history that has been distorted, they call it is it Victoria Falls or something. But in Zambia, they call it Mositonia. When I was there, I realized that God exists. So, for Uganda, Ugandans are very proud of our endowments. The last time we tried to tell people about them, we were colonized in the disguise of a protectorate. And we are still suffering with those consequences. So, I'm encouraging all of you to have the PAL experience. Go for that excursion. Because you're Africans, so I'm not afraid. You can't colonize us. Enjoy the PAL experience. You'll know about the sights and the sounds, but especially the people. Because Uganda is about the people. When you see potholes, it's because we are in the season of renewal. They're trying to construct almost a new city. It's an attempt. New drainage system, highways, but focus on the hospitality, the people. They smile. What you see is for real. When I'm smiling, that is mine, natural. Okay? So Ugandans are cultured, spiritual Africans. So just go and enjoy the source. We call it the source of the Nile, yes. 24/7, that river is supplying connected almost 9 nations downstream with life up to Egypt. So you go and experience it. Like I saw the Mosotonia in Zambia, I'm sure you'll be changed. I believe all of you are going. We are organizing very many vehicles to accommodate all of you. Please register while you go out there. Yesterday we had the cocktail. It was supposed to be from 6:30 to 8. I think that was the plan. But I don't think we can do it today. No. You need you need to go back and wind down, because yesterday the night was elastic. Some of us, our homes were evading. They steamed further than usual. So for today we are giving you coffee. We are giving you coffee and tea, especially because in Uganda we grow coffee, a lot of it, we grow tea, a lot of it, but we don't drink it. So on behalf of our Ethiopian brothers who take a lot of coffee, and on behalf of our Kenyan brothers who take a lot of tea, please join us for a tea break, tea and coffee break out there as usual. Until tomorrow, this is the end of the day. Thank you very much.